Welcome to the long-awaited CompTIA A+ 220.12.02 full course. My sincere apologies for not getting this out sooner. I really wanted to. This is several hundred slides more than the A+ 220.12.01 course, which means we're going to have to make sure that we stick within the YouTube 12-hour, because there's a cap to videos for 12 hours long, and I feel like we're going to hit that cap, but you know more than I do at this point because you can actually see how long it's going to wind up being overall. So let's get it started. This guide was developed in 2025 specifically for the CompTIA A+ 220.12.02. It is not redone or repurposed. A lot of guides online are repurposed from old courses. This one is not. This one is brand new for the 220.12.02. It's a basic course. There are parts that are going to go a little bit more in depth for special videos. If you want to see more on a specific subtopic, maybe if we didn't cover it enough, then please let me know in the comments. Constructive criticism is great. This way we can improve in future iterations. So this is going to be a 90 question maximum exam. They're going to be multiple choice and performance based. We do have multiple choice practice exams on the channel as well, so you guys can go along with that and get some experience doing those. Length of the test is 90 minutes. I recommend taking the entire time. There's also test tip videos on this channel as well. Recommended experience, take this lightly. 12 months of hands-on experience in a help desk support technician, desktop support technician, or field service technician job role. Most people that take this exam, in my experience, don't have the 12 months experience. They're trying to get those roles, and that's why they get the A+. So don't worry too much about that. The passing score is 700, so it is more than the 1201, but it should also be a touch easier than the 1201 in terms of the questions. So the exam objectives, so it's going to be roughly 28% operating systems, 28% security software, 23% troubleshooting, and 21% operational procedures. So let's get it started with operating systems. First up, we have Windows operating systems. Windows 10 is widely used in consumer and business environments for personal computing, offering features like Cortana, virtual desktops, and robust security features. Most of you, I'm sure, are familiar with this. Windows 11, probably a lot of you are familiar with this at this point as well. Latest version providing enhanced security, better integration with Microsoft Teams, and a redesigned user interface aimed at improving productivity and user experience. Windows Server, which is a family of server operating systems used in enterprise environments for tasks like managing networks, hosting websites, and supporting virtual machines. And then we have Windows for embedded systems. Specialized Windows versions like Windows IoT, Internet of Things, are used for specific devices, offering minimal resource usage and tailored functionalities for industrial or consumer products. Those are not for Windows for embedded systems is not for regular computers. Then we have Linux operating systems. Linux is available in a multiple distributions or distros such as Ubuntu, Fedora, and Debian, each catering to different user needs. For example, home use, servers, security, or also Internet of Things as well. Open source and customizable. Linux is open source, allowing users to modify the source code and customize it for specific requirements or to enhance performance. That's why there are so many different distributions of Linux. It is widely used in server environments due to its stability, security, and performance, powering many web servers, databases, and enterprise applications, as well as, of course, Internet of Things. Variants of Linux, like Linux for IoT, are used in embedded systems for devices such as routers, security cameras, and industrial machinery. Linux for development is preferred by developers for its command line interface, powerful scripting capabilities, and compatibility with programming tools and environments. I would strongly recommend if you haven't played with Linux yet, if you have a crappy computer that's just laying around that maybe you had from like 5 years ago, install Linux on it. It will automatically start running wonderfully, and you can play around and learn the Linux operating system. Ubuntu and Mint are good places to start, but I would definitely recommend for anyone trying to get into IT to learn Linux. Then we have macOS operating systems, is Apple's proprietary operating system known for its sleek user interface, reliability, and integration with Apple hardware. Primarily designed for use in creative industries such as graphic design, video editing, and music production due to its performance and software ecosystem. It's known for strong built-in security features like Gatekeeper, File Vault, and regular system updates that protect against malware and data breaches. It's increasingly used in business environments, particularly in tech industries, users due to its stability, integration with other Apple products, and support for virtualization tools. A popular choice for software developers is macOS for developers, especially those creating applications for the Apple ecosystem like iOS, macOS, watchOS for the Apple Watches, and tvOS. Another thing that I want to mention is that macOS is generally considered to be the least customizable of the big three operating systems. You have Linux, which is the most customizable, Windows, which is kind of in the middle, although they are gravitating more towards the Mac side, which is less customization with Windows 11, and probably going to be even less with Windows 12 as well. And then we have macOS, which is mostly closed, less customization options for the end users. That's why you don't really see too many people building their own Macs. You see them buying them off the shelf already done, whereas Windows, you see a lot more people that are designing their own systems for gaming and other specifications. Then we have Chrome OS, which is a lightweight cloud-based operating system developed by Google, primarily designed for use on Chromebooks. Chrome OS is built around the Chrome browser, emphasizing cloud computing and web applications over traditional software. So everything is server-side. Well, most of it is server-side with the Chrome operating system, Chrome OS. It's ideal for users who rely on internet-based services, education sectors like they give them to students, and businesses that prioritize simplicity, security, and low maintenance. Chrome OS includes built-in security such as automatic updates, sandboxing, and verified boots, ensuring a secure and up-to-date experience. Although it is cloud-based, Chrome OS offers offline functionality for certain apps, allowing users to work without an internet connection. Next, we have iPad OS, which is different from iOS. It's a variant of iOS specifically designed for Apple's iPad, optimizing the user experience for tablet devices. iPad OS offers advanced multitasking features, including split view, slide over, and the ability to use external displays, making it more versatile for productivity. It's primarily aimed at consumers who need a tablet that can handle productivity tasks, media consumption, and creative applications such as drawing or video editing. iPad OS supports a rich ecosystem of apps, including those optimized for the iPad, such as Procreate for design and iMovie for video editing. iPad OS includes robust security features such as biometric authentication, Face ID, Touch ID, and privacy controls to protect user data. iOS is Apple's proprietary mobile operating system designed for iPhone, iPod Touch, and iPad devices, providing a seamless experience with Apple's hardware and software. iOS features an intuitive, touch-based interface optimized for mobile devices with capabilities such as gestures, app icons, and notifications. The App Store provides access to millions of applications, including productivity tools, games, and entertainment apps, ensuring a rich user experience. iOS is known for its robust security measures, including encryption, Face ID, Touch ID, and secure app review processes. iOS integrates seamlessly with other Apple products such as macOS, iPadOS, and watchOS, offering a unified experience across devices. Android is an open-source mobile operating system with the most popular version developed by Google, used by a wide range of manufacturers for smartphones, tablets, and other devices. Android is highly customizable, allowing manufacturers and users to personalize the interface, features, and functionality of devices. The Google Play Store offers a vast selection of apps, including games, productivity tools, and utilities, catering to a wide variety of user needs. Android includes security measures such as app permissions, Google Play Protect, and regular updates to enhance data privacy and device security. Android devices integrate seamlessly with Google services such as Gmail, Google Drive, and Google Assistant, offering a connected experience. NTFS, or the New Technology File System, is the default file system for Windows operating systems, offering advanced features like security and large file support. NTFS allows for detailed file and folder permissions, enabling administrators to control access to files and protect sensitive data. NTFS supports very large files and volumes, making it ideal for modern systems with large storage capacities. It includes features like journaling, which helps recover data in case of power failures or system crashes. While primarily used in Windows environments, NTFS is supported by other operating systems like Linux and macOS, though with limited write functionality. The Resilient File System, or REFS, is a file system developed by Microsoft designed to provide high data availability, scalability, and integrity, particularly for enterprise-level storage. REFS includes features like automatic data correction and integrity checks to prevent data corruption, making it ideal for systems where uptime and data protection are critical. REFS is designed to handle large volumes of data efficiently, supporting very large file sizes and storage volumes without significant performance loss. REFS is used in Windows Server editions and some professional versions of Windows, though it is not commonly used in consumer versions of Windows. While REFS offers numerous benefits for data integrity and scalability, it lacks full compatibility with certain features of NTFS, such as file compression and encryption. FAT32, or File Allocation Table 32, is a file system developed by Microsoft widely used for its compatibility and simplicity. FAT32 is supported by nearly all major operating systems, including Windows, macOS, Linux, and some embedded systems, making it ideal for portable storage devices like USB drives and memory cards. FAT32 supports file sizes up to 4 GB and volume sizes up to 8 TB, which limits its use for modern systems with larger storage requirements. The simplicity of FAT32 file system provides fast performance on smaller devices and easy management for basic storage needs. FAT32 is commonly used for external storage devices like USB flash drives, SD cards, and other devices requiring broad, cross-platform compatibility. ext4, or the Fourth Extended File System, is a widely used file system for Linux operating systems, offering improved performance, scalability, and reliability over its predecessors ext2 and ext3. It includes features such as journaling, delayed allocation, and extents, which improve file system performance and reduce fragmentation. ext4 supports large files and volumes, making it suitable for modern systems with significant storage needs, supporting files up to 16 TB. With built-in checksums and journaling, ext4 ensures better data integrity and recovery in the event of system crashes or power failures. ext4 is the default file system for many Linux distributions, including Ubuntu and Fedora, due to its stability and performance. Extended File System, or EXT, is a family of file systems used primarily in Linux operating systems with several versions, ext2, 3, and 4, offering various enhancements over time. The original version, ext2, was widely used for its simplicity and reliability but lacked journaling, making it less robust in the event of system crashes. ext3 introduced journaling, which provides greater data integrity and faster recovery after power failures, becoming the default for many Linux distributions before ext4. The latest version, ext4, improved on the previous versions by adding features like larger file support, delayed allocation, and better performance and scalability. ext file systems, especially ext4, remain the default choice for most Linux distributions due to their stability, performance, and open source nature. Apple File System, or APFS, is the default file system for macOS, iOS, and other Apple devices optimized for flash and solid-state storage. APFS offers faster file access, improved efficiency, and enhanced file system management, especially with tasks like file copying and cloning. APFS includes built-in encryption support, allowing for full disk encryption, file-level encryption, and better protection of user data. APFS uses a unique method of managing storage that allows for space sharing, reduced waste storage, and improving the allocation of available space. APFS is primarily used in modern Apple devices but is incompatible with older macOS file systems like HFS+. exFAT, or Extended File Allocation Table, is a file system developed by Microsoft designed for flash drives, memory cards, and external storage devices. exFAT is supported by multiple operating systems including Windows, macOS, and some Linux distributions, making it ideal for portable storage. exFAT supports larger files and volumes compared to FAT32, with file size limits up to 16 exabytes and volumes up to 128 petabytes. exFAT is optimized for flash memory such as USB drives, SD cards, and external hard drives, offering better performance and reliability than FAT32. Unlike more advanced file systems like NTFS, exFAT does not include journaling, which can make it less reliable in the event of a system crash. End of life refers to the point in time when an operating system or software version is no longer supported by the vendor with updates, patches, or security fixes. Using end-of-life software can expose systems to security vulnerabilities, as no new patches or fixes are released to address potential threats. As operating systems reach end of life, newer software applications and hardware may no longer be compatible, limiting functionality and performance. Once an operating system reaches end of life, users may need to upgrade to a newer version to receive ongoing support, including bug fixes, security updates, and technical assistance. Popular operating systems such as Windows 7 and now Windows 10 and macOS versions like 10.14 Mojave have reached or are approaching end of life, requiring users to upgrade for continued support. Update limitations refer to the restrictions or challenges that prevent an operating system from receiving or installing updates, such as hardware compatibility, software conflicts, or network issues. Older hardware may not support the latest updates, leading to performance issues or the inability to upgrade to newer OS versions. Sometimes, third-party applications or drivers can interfere with the update process, preventing successful installations or causing system instability. Slow or unreliable internet connections can hinder the download and installation of updates, leading to incomplete or failed update processes. Operating systems that have reached end of life may no longer receive updates, leaving users vulnerable to security risks and compatibility issues. Different operating systems may not support these same software applications, leading to compatibility issues when trying to run software across platforms. For example, Windows applications on macOS. Operating systems use different file systems, for example, NTFS for Windows, HFS Plus for macOS, making it challenging to read and write files between systems without special tools or configurations. Certain hardware devices may only have drivers available for specific operating systems, limiting the functionality of peripherals when switching or dual booting between systems. While some applications are designed to work across multiple OS types, others are OS-specific and may require alternatives or virtual machines to function on different platforms. Using virtual machines or emulators can help mitigate compatibility issues by allowing users to run applications from one OS within another, but these solutions can introduce performance overhead. USB booting allows users to install or upgrade an operating system by booting directly from a USB drive instead of the system's internal storage or optical drive. The USB boot method is widely compatible with various operating systems including Windows, Linux, and macOS, making it ideal for diverse environments with different hardware setups. USB booting provides a fast and portable solution for OS installations and upgrades, allowing IT professionals to deploy new systems or update existing ones without relying on network connections. To boot from a USB device, the BIOS or UEFI settings on the system must be configured to prioritize the USB device as the boot drive. A USB boot drive can also be used for emergency data recovery or system repairs, offering an easy-to-carry solution for troubleshooting and restoring operating systems. Network booting, or PXE boot, allows systems to boot and install an operating system over a network connection rather than from local storage or a USB drive. The network boot method is ideal for environments with many computers as it enables centralized OS deployment and upgrades across multiple devices simultaneously. Network booting works with various operating systems including Windows, Linux, and macOS, providing flexibility for diverse environments. Successful network booting requires a properly configured DHCP server, TFTP server, and network infrastructure to deliver the OS image to client devices. This method saves time and resources by automating the OS installation process across multiple machines, reducing the need for physical media and individual setups. Solid-state drives, or SSDs, and flash drives are portable storage devices commonly used for booting and installing operating systems due to their speed and reliability. Booting from SSDs or flash drives offers faster read-write speeds compared to traditional hard drives or optical media, reducing installation and upgrade time significantly. These devices are portable, making them ideal for troubleshooting, system recovery, and OS deployment across various devices and environments. SSDs and flash drives are compatible with most operating systems including Windows, Linux, and macOS, providing flexibility in diverse environments. To boot from SSDs or flash drives, the system's UEFI or BIOS must be configured to prioritize these devices as the boot source. Internet-based booting allows a system to download and install an operating system over the internet rather than from local storage or physical media. This method is ideal for environments that use cloud-based services or require rapid remote OS deployments across diverse systems without needing physical access to each device. Successful internet-based booting requires a reliable network connection and appropriate cloud or server infrastructure, such as a network server with OS images and provisioning tools. This method supports large-scale deployments, enabling IT teams to manage OS installations and updates on multiple devices simultaneously, even in remote or distributed environments. Internet-based booting supports various operating systems like Windows, Linux, and macOS, providing flexibility for diverse environments that use different platforms. External or hot swappable drives can serve as boot devices for OS installs or upgrades, letting you plug in the drive and boot from it without shutting the system down. This approach is especially useful across mixed hardware environments since the same external drive can be used on multiple systems without touching internal storage. Booting from a fast external SSD or USB drive can significantly speed up installation and upgrade workflows versus slower traditional media. External boot drives can support multiple operating systems such as Windows, Linux, and macOS, making them practical in multi-platform setups. For this to work, the system's BIOS or UEFI boot order or one-time boot menu must be set to boot from the external drive first. A partitioned internal hard drive involves dividing a physical disk into multiple sections, each of which can hold an operating system or other data, allowing for multiple OS installations on a single device. This method enables users to set up a multi-boot environment where different operating systems such as Windows, Linux, and macOS can be installed and accessed from separate partitions on the same drive. Partitioning allows for more efficient use of available storage by isolating different operating systems and their data, making upgrades and reinstallation easier without affecting other partitions. The BIOS or UEFI must be configured to recognize the correct partition for booting, ensuring the right OS is loaded during the boot process. Partitioned internal hard drives are compatible with most operating systems and offer flexibility in managing different OS installations on a single machine, especially in testing or development environments. The multi-boot boot method allows users to install and run multiple operating systems on a single machine with the option to choose which OS to boot into during startup. This method is compatible with a variety of operating systems including Windows, Linux, and macOS, making it ideal for environments that require multiple OS platforms. Each operating system is typically installed on a separate partition of the hard drive, isolating them from one another and preventing data conflicts or corruption. A bootloader such as Grub or Windows Boot Manager is used to manage the selection of operating systems during startup, allowing users to choose which OS to load. Proper configuration of partitions, bootloaders, and BIOS UEFI settings is essential to ensure smooth multi-boot functionality and prevent conflicts between operating systems. A clean install involves wiping the existing operating system from a device and installing a fresh copy of the desired operating system, ensuring that no previous configurations, files, or software remain. It offers a fresh start, eliminating performance issues, malware, and software conflicts associated with outdated or corrupted systems. Before performing a clean install, it's essential to back up all important data, as the process will erase all files and programs on the device. A clean install is often recommended when upgrading to a new major version of an OS, as it ensures optimal performance and compatibility with the new system. It's important to ensure that hardware components are compatible with the new OS version before performing a clean install, especially in diverse environments with varying hardware. An operating system upgrade involves installing a newer version of an operating system over an existing one, retaining user data, applications, and settings while improving system features and performance. Upgrading is quicker than a clean install as it preserves user data and applications, minimizing downtime and setup time. Before upgrading, ensure that the system hardware and applications are compatible with the new OS version, especially in diverse environments with different devices. Even though data is typically retained during an upgrade, it's essential to back up important files to prevent data loss in case of upgrade failure. Check licensing requirements and ensure that the current version of the OS is eligible for an upgrade to the desired version, including ensuring proper activation. Image deployment involves creating a master image of an operating system and system configurations, which is then used to replicate the OS onto multiple devices quickly and efficiently. This method is ideal for environments with many devices such as businesses or educational institutions, as it allows for uniform OS installations across multiple machines without manual intervention. A master image can be customized with specific applications, settings, and configurations, ensuring consistency in deployment across diverse hardware. Common tools for image deployment include Windows Deployment Services, Clonezilla, and Semantic Ghost, which help automate the process and ensure accuracy. Image deployment requires a reliable network infrastructure and sufficient storage space for hosting the images, particularly in environments with large numbers of systems. Remote network installation allows an operating system to be installed or upgraded on a device over a network connection without the need for physical media or local access to a machine. This method is ideal for managing OS installations and upgrades on multiple devices across different locations, providing a centralized point for deployment. Pixie boot is a common method for remote network installation where systems boot from the network and download the OS image for installation. Remote installation significantly reduces the need for physical intervention, making it particularly useful in large organizations or remote environments with diverse hardware. Successful remote network installation requires a properly configured network, including DHCP and TFTP servers, to deliver the OS image to client devices. Zero-touch deployment is an automated method for deploying operating systems to devices with no manual intervention required, typically using pre-configured profiles and systems. Tools such as Microsoft Endpoint Configuration Manager, formerly SCCM, and Windows Autopilot enable IT administrators to configure and deploy OS installations or upgrades automatically across many devices. This method is ideal for large organizations as it allows administrators to remotely deploy OS images and updates to multiple devices simultaneously, reducing downtime and manual work. With zero-touch deployment, users receive their devices with the OS pre-installed and pre-configured, requiring little or no interaction, improving user experience and productivity. Successful zero-touch deployment requires a well-configured network infrastructure, including cloud or server resources to manage device provisioning, OS images, and configurations. A recovery partition is a dedicated section of a hard drive that contains a copy of the operating system and recovery tools, allowing users to restore their system to its original state without needing external media. It allows users to perform a factory reset or system restore, which can be essential for troubleshooting issues, recovering from a system crash, or reinstalling the operating system. In environments with multiple devices or operating systems, recovery partitions provide a fast, localized solution for system restoration without relying on network connections or physical media. Recovery partitions take up disk space, and depending on the size of the operating system and the recovery tools, they may reduce available storage for user data or applications. Some systems may allow custom recovery partitions, while others may restrict users to manufacturer-provided recovery partitions, limiting flexibility in certain environments. A repair installation is a method of reinstalling an operating system over an existing one to fix issues such as system corruption or missing files without affecting user data or applications. Unlike a clean install, a repair installation preserves user files, settings, and applications, making it a less disruptive solution for fixing system issues. This method is especially useful when the OS has become unstable due to corrupt files or misconfigurations, and reinstalling the system is necessary to restore functionality. Repair installations are typically used with Windows operating systems, but can be used in various environments, including multiple OS setups, to resolve compatibility issues. Performing a repair installation requires using installation media or recovery tools and may involve repairing the boot configuration, system files, or registry entries. Third-party drivers are non-native drivers developed by hardware manufacturers or other companies to enable devices to work with an operating system, especially when the OS does not provide built-in support. In diverse environments, using third-party drivers can introduce compatibility issues if the driver is not optimized for the specific OS version or hardware configuration. It's essential to ensure that third-party drivers are updated regularly to maintain compatibility with new OS versions and security patches, preventing system instability or malfunction. Before using third-party drivers, it's important to verify that the hardware vendor offers support and updates for those drivers, as improper or outdated drivers can lead to performance issues or system crashes. Testing third-party drivers in a controlled environment before deployment helps ensure they do not cause conflicts or other issues in production systems. GUID Partition Table, or GPT, is a modern partitioning scheme that replaces the older MBR, or Master Boot Record System, offering advantages such as support for larger disk sizes and more partitions. GPT is often used with UEFI, or Unified Extensible Firmware Interface systems, offering benefits such as faster boot times and better security features compared to legacy BIOS systems. GPT supports disks larger than 2 terabytes, making it ideal for modern storage requirements and ensuring that OS installations or upgrades can accommodate larger drives. Unlike MBR, which is limited to 4 primary partitions, GPT allows for up to 128 partitions on a single disk, providing flexibility in managing disk space for multiple OS installations or data storage. Most modern operating systems, including Windows, Linux, and macOS, support GPT, but older operating systems or hardware may have limitations, so compatibility checks are necessary in diverse environments. The Master Boot Record, or MBR, is an older partitioning scheme used for managing disk partitions, storing the partition table and bootloader in the first sector of the disk. MBR is limited to 4 primary partitions per disk, or 3 primary partitions and 1 extended partition, which can be further subdivided into logical partitions. MBR supports disks up to 2 terabytes in size, making it less suitable for modern high-capacity storage needs where larger disk sizes are required. MBR is compatible with older systems and operating systems, making it a good option for environments that rely on legacy BIOS systems or older hardware. While MBR is still in use, it's increasingly being replaced by GUID Partition Table, or GPT, due to its limitations, especially in environments where large storage and multiple partitions are needed. Drive formatting is the process of preparing a storage device for use by an operating system, including the creation of a file system and the partitioning of the drive. Common file systems include NTFS, HFS+, ext4, and exFAT, among others. The choice of file system affects system performance, compatibility, and available features like security and permissions. The partitioning scheme, whether it's MBR or GPT, is selected during the formatting process and determines how data is organized and accessed on the drive. GPT is preferred for modern systems, while MBR is used in older systems. In diverse environments, it's essential to choose the right file system and partitioning scheme to ensure compatibility with different operating systems and hardware, particularly when dual booting or using external drives. Formatting a drive typically erases all existing data, so it's important to back up critical files before proceeding with the format. Backing up files in user preferences ensures that critical data, settings, and configurations are preserved before performing an operating system installation or upgrade. Important data to back up includes user files, application settings, system preferences, and browser configurations, among others. Common backup methods include cloud storage, external drives, and network-attached storage. Each method offers different benefits depending on the environment. Restoring user preferences and files after an operating system upgrade or installation can be automated with tools like Windows Backup or macOS Time Machine, or manually through the use of backup software. In diverse environments with multiple operating systems, it's essential to choose backup tools that support cross-platform restoration to ensure that files and settings can be restored regardless of operating system. During operating system installations and upgrades, ensuring that critical applications function properly on the new system is crucial. Some applications may require updates or patches to run smoothly on newer operating system versions. Drivers are essential for hardware functionality, and upgrading an operating system may require updating drivers or installing new ones for devices such as printers, graphics cards, and network adapters. Some older applications or devices may not be compatible with newer operating system versions. Backward compatibility features or compatibility modes can help run older software without issues. In diverse environments, it's essential to test applications and drivers before the upgrade to ensure that all critical software and hardware will continue to function correctly after the operating system upgrade. In environments with multiple operating systems, ensuring compatibility across platforms is necessary for a seamless user experience and interoperability. Ensuring that the hardware components of a system are compatible with the selected operating system is crucial for successful installations and upgrades. The operating system must support drivers for all hardware components, such as graphics cards, printers, and network adapters. Without proper drivers, hardware may not function correctly or may be unsupported altogether. Older hardware may lack driver support for newer operating systems, making it essential to verify whether the hardware is compatible or whether alternative solutions like compatibility modes are necessary. Each operating system has specific minimum hardware requirements, for example RAM, processor speed, disk space, etc., that must be met or exceeded to ensure smooth performance during and after the installation or upgrade process. In environments with diverse hardware setups, for example different manufacturers, devices, or operating systems, it's important to test hardware compatibility before initiating an operating system installation or upgrade to avoid performance issues or failures. The product lifecycle in the context of operating systems refers to the phases an operating system goes through from initial release to eventual end of life, including development, support, and retirement. The main phases of an operating system product lifecycle include introduction, growth, maturity, and end of life, each impacting the support and upgrade strategies for organizations. As an operating system reaches its end of life, it no longer receives updates or security patches, prompting the need for upgrades to newer, supported versions to maintain security and functionality. The length of a support for an operating system varies by vendor, for example Microsoft's extended support for Windows versions, and plays a crucial role in planning operating system installations and upgrades within a diverse environment. In environments using multiple operating system types, understanding the product life cycle of each operating system is vital for strategic planning to ensure compatibility, security, and efficient resource management during upgrades. Windows 10 Home is the most basic version of the Windows 10 operating system, designed primarily for home users with essential features for everyday computing. It includes the Start menu, Cortana for voice commands, Windows Defender for security, and access to the Microsoft Store for app downloads. It lacks certain advanced features like BitLocker encryption, group policy management, and advanced remote desktop functionality, which are available in higher editions like Windows 10 Pro. Windows 10 Home provides full support for multimedia, including the Microsoft Edge browser, Windows Media Player, and support for 4K content. It's designed for lower-cost personal devices. Windows 10 Home is optimized for everyday users, supporting both traditional and touch-enabled devices. Windows 10 Pro is designed for professional users and small businesses, offering more advanced features compared to the Home Edition, particularly in the areas of security and management. It includes BitLocker for disk encryption, group policy management for centralized control, and remote desktop for accessing computers remotely. In addition to Windows Defender, Windows 10 Pro provides Enterprise Mode Internet Explorer and access to Windows Update for Business, enhancing security and update management. Windows 10 Pro supports Hyper-V, Microsoft's built-in virtualization technology, allowing users to run multiple operating systems on a single machine. Designed for use in business environments, Windows 10 Pro is compatible with most business software, hardware, and IT infrastructure. Windows 10 for workstations is specifically designed for high-performance, resource-intensive tasks such as scientific computing, data analysis, and other professional applications that require more processing power. It supports high-end hardware configurations including REFS or Resilient File System, NVDIMM memory, and multi-processor setups, making it suitable for workstations with advanced needs. It offers better performance for demanding applications with features like persistent memory and faster file sharing, improving overall system responsiveness. It includes features from Windows 10 Pro such as BitLocker, group policy management, and remote desktop, as well as support for virtualization and enterprise-grade security. It's ideal for professionals and organizations that need high-end computing for tasks such as 3D rendering, simulation, and other resource-heavy applications. Windows 10 Enterprise is designed for large organizations and businesses, offering advanced features for security, management, and virtualization that go beyond the capabilities of Windows 10 Pro. It includes enhanced security features such as Device Guard, Credential Guard, and App Locker, providing robust protection against malware and unauthorized access. It offers comprehensive threat protection with Windows Defender ATP, helping businesses detect, investigate, and respond to advanced cyber threats. It supports Windows Autopilot for device provisioning, direct access for seamless remote connectivity, and group policy management for centralized control of devices and users. Windows 10 Enterprise is available through volume licensing, making it scalable and cost-effective for large organizations needing to deploy operating systems on multiple devices. Windows 11 Home is the basic edition of Windows 11 designed for home users with essential features for personal use, entertainment, and productivity. It features a centered start menu and taskbar offering a modern, streamlined design with improved multitasking features like snap layouts and snap groups. Windows 11 Home is integrated with Microsoft services such as OneDrive for cloud storage, Xbox Game Pass, and Microsoft Store for app downloads and entertainment. It includes built-in security features like Windows Defender, Secure Boot, and TPM 2.0, which helps protect user data and provides a safer computing environment. It provides gaming optimizations such as Auto HDR and Direct Storage, offering a better experience for gaming and high-performance applications. Windows 11 Pro is designed for professional and business users, offering advanced features that provide better security, manageability, and productivity tools compared to Windows 11 Home. It includes key business features like BitLocker for disk encryption, group policy management for centralized control, and remote desktop for connecting to other computers remotely. It offers advanced security features like Windows Defender and Windows Information Protection to protect data and prevent unauthorized access to sensitive information. Windows 10 Pro supports Hyper-V, allowing users to create and manage virtual machines for testing, development, or running multiple operating systems on the same device. It supports features like Azure Active Directory and Windows Update for Business, making it easier for IT administrators to manage devices in a business or enterprise environment. Windows 11 Enterprise is designed for large organizations, providing advanced features for security, management, and productivity to meet the needs of businesses with complex IT environments. It includes Windows Defender Advanced Threat Protection, Device Guard, and Credential Guard, providing comprehensive protection against advanced threats and unauthorized access. It supports group policy management, Windows Autopilot for deployment, and enterprise data protection for controlling and securing sensitive data. It includes support for Hyper-V virtualization and enhanced remote desktop capabilities, allowing businesses to manage and access multiple devices securely. It's available through volume licensing, making it cost-effective for large-scale deployments in enterprises that need to manage a large number of devices. Windows N versions are versions of Windows operating systems that are designed for the European market and exclude certain media-related technologies due to regulatory requirements. Key features like Windows Media Player, Windows Media Center, and related media functionality are excluded from the N editions, which are available for both Windows 10 and Windows 11. The N versions were created to comply with the European Union regulations that aim to ensure fair competition and provide consumers with more choice regarding media software. While lacking media features, Windows N versions function similarly to standard Windows editions, but require the user to manually install media software like Windows Media Player if needed. Windows N editions are available for various Windows versions, including Windows 10N and Windows 11N, and are available in both Home and Pro configurations. A domain network is a network setup used in larger, centralized environments typically managed by Active Directory for centralized authentication, security, and user management. A workgroup is a simpler, decentralized network model where each computer maintains its own user accounts and settings without centralized management. Domains offer enhanced security features and centralized management tools such as group policies and centralized access control, whereas workgroups have fewer security options and no centralized control. Domains are suitable for large networks with many computers, as they can easily scale and provide consistent settings across multiple devices. Workgroups are more suited for smaller networks, typically with fewer devices. Windows Home editions typically use workgroups, while Windows Pro and Enterprise editions support both domains and workgroups with more robust features for domain management. Desktop styles describe the look and layout of Windows, including the start menu, taskbar, and window behavior, which vary by version. Both Windows 10 and 11 offer modern interfaces and task view for multitasking. Windows 11 adds rounded corners, a cleaner design, and snap layouts for quick window organization. Both Windows Home and Pro look nearly identical, but Pro adds business tools like Remote Desktop and Group Policy, which affect management rather than appearance. Windows 11 introduces a centered taskbar, simplified start menu, and better support for virtual desktops and touchscreens. Windows 7 kept a classic desktop and start menu. Windows 8.1 tried a touch-first start screen. Windows 10 restored the start menu, and Windows 11 refined it with more modern, minimalist design. Remote Desktop Protocol is a feature that allows users to remotely connect to a computer accessing its desktop and applications from another location. RDP is available in Windows Pro, Enterprise, and Education editions, while Windows Home editions do not support hosting RDP connections natively. Windows Pro and higher editions, users can host an RDP session, allowing others to connect their remote machine remotely, whereas Windows Home can only use RDP to connect to other systems, not host. Higher-end editions, such as Windows Enterprise, offer enhanced security features with RDP, including network-level authentication, or NLA, and integration with Active Directory for better user management. RDP is crucial for IT administrators and businesses, allowing centralized access to machines for troubleshooting, remote work, or server management, and is fully supported in Pro and Enterprise editions. Different editions of Windows have varying limits on the amount of RAM they can support, which affects system performance, especially in memory-intensive tasks. Windows 10 Home supports up to 128 GB of RAM, while Windows 10 Pro supports up to 2 TB of RAM, making it more suitable for high-performance systems and professional environments. Similarly, Windows 11 Home supports up to 128 GB of RAM, while Windows 11 Pro can handle up to 2 TB of RAM, offering more memory support for workstations and enterprise use. Windows Enterprise and Windows Server editions support even higher RAM capacities, up to 6 TB or more, depending on the specific version, which is essential for large-scale data operations and virtualization. Higher RAM support in Pro, Enterprise, and Server editions is beneficial for environments that require handling large datasets, running virtual machines, or managing high-demand applications. BitLocker is a full disk encryption feature in Windows that helps protect data by encrypting the entire drive, preventing unauthorized access to information. BitLocker is available in Windows Pro, Enterprise, and Education editions, but is not included in Windows Home editions. In Windows Pro and Enterprise editions, BitLocker can be used with TPM, or Trusted Platform Module, for added hardware-based security, and BitLocker to Go supports encryption for external drives. Windows Enterprise editions allow for centralized management of BitLocker through Group Policy and Active Directory, making it suitable for business environments with many devices. Windows Home users can use a similar encryption feature called device encryption, but it lacks the advanced features and management tools offered by BitLocker in higher editions. The Group Policy Editor, or GPEdit MSC, is a tool used to manage and configure system settings, security policies, and other administrative templates in Windows. Group Policy Editor is available in Windows Pro, Enterprise, and Education editions, but is not available in Windows Home editions by default. In Pro and Enterprise editions, Group Policy Editor allows advanced configuration of system settings, including password policies, software installation settings, and security options. Windows Home users can access the Group Policy Editor through third-party tools or by enabling it through registry tweaks, but it is not officially supported. Windows Enterprise and Pro editions provide full functionality of the Group Policy Editor for managing policies across large business networks, such as Active Directory integration and network settings. An in-place upgrade allows users to upgrade their current Windows operating system to a newer version without losing their files, applications, or settings. In-place upgrades are available for various Windows editions, such as upgrading from Windows 7 to Windows 10 or from Windows 10 Home to Windows 10 Pro, depending on system compatibility. Unlike a clean install, an in-place upgrade preserves user data and applications, reducing downtime and the need for reinstallation of software. While in-place upgrades allow users to move to newer editions, certain edition upgrades, for example Home to Pro, may be limited or require additional licensing. The system must meet the minimum hardware requirements of the newer version of Windows for the upgrade to be successful, including storage, processor, and memory. A clean install upgrade involves wiping the existing operating system and performing a fresh installation of a newer version, ensuring a fresh start with no leftover files or settings from the previous OS. This method helps eliminate system errors, performance issues, and malware by removing old configurations and files, leading to a more stable system. A clean install upgrade is supported across all Windows editions, but may require a valid product key for the new version. It's particularly useful when upgrading to a major version, such as from Windows 7 to Windows 10. Since a clean install erases all data on the system, users must back up important files before proceeding with the installation. Unlike in-place upgrades, a clean install requires more time and effort, including reinstalling applications and restoring data after the OS installation. Trusted Platform Module, or TPM, is a hardware-based security feature that provides encryption and key management to protect sensitive data, ensuring system integrity. Windows 11 requires TPM 2.0 for installation, which is a more advanced version of TPM, offering stronger security features including support for modern encryption algorithms. While Windows 10 supports TPM 1.2 and 2.0, TPM 2.0 is recommended for better security, particularly for features like BitLocker encryption and Windows Hello. TPM support is available in many modern motherboards, but it must be enabled in the system's BIOS or UEFI settings. Older systems may not have TPM 2.0, which could limit the ability to upgrade to Windows 11. TPM is crucial in business environments for securing devices and protecting data through hardware-based encryption, reducing the risks of unauthorized access or data breaches. Unified Extensible Firmware Interface, or UEFI, is a modern firmware interface that replaces the older BIOS system, providing faster boot times, enhanced security, and support for larger hard drives. Windows 11 requires UEFI firmware for installation, with Secure Boot enabled to protect against unauthorized software loading during the boot process. Windows 10 also benefits from UEFI support, offering features such as fast startup and secure boot, but can run on both UEFI and legacy BIOS systems. UEFI provides better system security, faster boot times, and the ability to support drives larger than 2 TB, whereas legacy BIOS systems are limited to older hardware and configurations. To use UEFI, the system motherboard must support UEFI firmware, and UEFI settings must be enabled in the BIOS UEFI interface to allow installation and booting of compatible operating systems. In Windows, services are background processes that run without user interaction and are essential for the functioning of the operating system, providing various functions like network connectivity, security, and updates. The Task Manager allows users to view, start, stop, and manage services running on a system, providing an interface to monitor system performance. Users can access the Services tab in Task Manager to see the status of services, such as whether they're running or stopped, and can right-click to start, stop, or restart services as needed. Some services are dependent on others and may not start unless their associated services are running, which can be checked within Task Manager. By monitoring services in Task Manager, users can identify resource hogging processes or malfunctioning services and troubleshoot performance or startup issues. The Startup tab in Task Manager allows users to view and manage programs that are set to launch automatically when Windows starts, impacting boot times and system performance. Users can disable unnecessary or resource hogging programs from launching at startup to improve boot speed and overall system performance. Disabling non-essential startup programs can significantly improve system responsiveness and reduce memory usage, especially on systems with limited resources. The Startup tab also shows the impact on startup for each program, such as low, medium, or high, helping users prioritize which programs to disable. Right-clicking on a program in the Startup tab allows users to enable or disable it from launching automatically during system startup. The Performance tab in Task Manager provides real-time statistics about system resources, including CPU, memory, disk, network, and GPU usage, helping users monitor system performance. Users can view detailed information about CPU utilization, memory usage, and the number of processes running, identifying potential performance bottlenecks. The Performance tab also shows disk activity and network usage, allowing users to diagnose issues with storage devices or network connections that could affect system performance. The tab features resource graphs for each component, which display usage trends over time, helping users identify spikes in resource consumption. The Performance tab is essential for monitoring system health and optimizing performance by identifying resource-heavy processes that may need attention. The Processes tab in Task Manager displays a list of all running applications, background processes, and system processes showing how much system resources, CPU, memory, disk, and network each process is using. Users can monitor CPU usage, memory consumption, disk activity, and network activity for each process, helping to identify resource-intensive programs that may affect system performance. The tab allows users to end tasks that are unresponsive or consuming excessive resources, helping to troubleshoot and improve system performance. Processes can be sorted by CPU, memory, or disk usage, making it easier to find processes that are impacting the system the most. The Processes tab also displays essential system processes that run in the background, ensuring the proper functioning of Windows, which should generally not be terminated unless necessary for troubleshooting. The Users tab in Task Manager shows a list of all users currently logged into the system, along with information about their resource usage, CPU, memory, disk, and network. It displays each user's session details, such as their login status, idle time, and resource consumption, providing insight into how much system resources are being used by each active user. Administrators can disconnect or log off users from the system if needed, freeing up system resources or resolving issues caused by unresponsive sessions. The Users tab also shows users connected remotely, such as through Remote Desktop, making it easier to manage connections from different devices. The Users tab is useful for monitoring user activity, diagnosing issues caused by specific users, and ensuring that no unauthorized or unnecessary user sessions are active. Event Viewer is a tool in Windows used to view logs of system events, warnings, errors, and other notifications that are logged by the operating system and applications. Event Viewer can be accessed through the Microsoft Management Console, or MMC, which provides a centralized interface to manage various system tools and features, including Event Viewer. Event Viewer organizes logs into categories such as application, security, system, and setup, each providing different types of information about system performance and issues. Administrators can use Event Viewer to analyze error messages, identifying system failures, and troubleshoot performance or application-related problems. Event Viewer allows users to monitor events in real time, set filters to highlight specific types of events, and generate alerts for critical system issues. Disk Management is a tool in Windows that allows users to manage hard drives, partitions, and volumes, including tasks like creating, deleting, and formatting partitions. Disk Management can be accessed through the Microsoft Management Console snap-in, providing a centralized interface for managing disks and other system tools. Users can create, resize, format, and delete partitions and volumes, as well as assign drive letters and change file systems for improved disk management. Disk Management also supports dynamic disks, allowing for more advanced configurations like RAID, redundant array of independent disks, for improved data redundancy and performance. Administrators can use Disk Management to view disk health, check disk status, and troubleshoot issues related to disk space or drive failures. Task Scheduler is a tool in Windows that allows users to automate the execution of tasks and scripts at specified times or in response to system events, improving system management and efficiency. Task Scheduler can be accessed via the Microsoft Management Console, or MMC snap-in, providing a centralized interface for managing scheduled tasks and creating new automation jobs. Users can create, edit, and delete tasks, as well as configure them to run under specific conditions, such as on system startup, when a user logs in, or at scheduled intervals. Tasks are triggered by specific events or conditions, and each task can be configured to execute various actions, such as running a program, sending an email, or displaying a message. Task Scheduler is particularly useful for automated system maintenance tasks, such as disk cleanup, software updates, or backup procedures, reducing manual intervention. Device Manager is a Windows tool that provides a centralized interface for managing hardware devices installed on the system, allowing users to view, update, and troubleshoot drivers and devices. Device Manager can be accessed through the Microsoft Management Console, offering an easy way to manage all installed hardware from one location. Users can enable, disable, update, or uninstall drivers, as well as view device status and resolve conflicts or issues related to hardware devices. Devices in Device Manager are organized into categories such as display adapters, network adapters, sound devices, and others, making it easier to find specific hardware. Device Manager is essential for troubleshooting hardware issues, as it provides error codes and device status, allowing users to identify malfunctioning or improperly configured devices. Certificate Manager is a tool in Windows used to manage digital certificates, including installation, removal, and viewing certificates that ensure secure communications and transactions. Certificate Manager can be accessed via the Microsoft Management Console, offering a centralized interface for managing certificates on the system. Certificates are stored in different categories such as personal, trusted root certification authorities, and intermediate certification authorities, and Certificate Manager allows for easy management of these stores. Certificate Manager helps in managing certificates used for SSL, TLS encryption, code signing, and user authentication, essential for maintaining secure communications in Windows environments. Users can use Certificate Manager to troubleshoot certificate-related issues, import or export certificates, and manage the security of their network communications. Local Users and Groups is a tool in Windows that allows administrators to manage user accounts, groups, and their associated permissions on a local machine. This tool is accessed through the Microsoft Management Console, providing a centralized interface to manage local user accounts and groups. Administrators can create, modify, and delete user accounts, assign group memberships, and set permissions for various resources on the system. Users are assigned to specific groups, for example, administrators, users, guests, that define their access, rights, and privileges, helping implement role-based access control. The tool is used for troubleshooting user access issues, configuring user rights, and managing permissions to ensure appropriate access to system resources. Performance Monitor is a Windows tool that provides detailed, real-time data on system performance, including CPU, memory, disk usage, and network activity. It can be accessed through the Microsoft Management Console, allowing users to track system health and performance over time. Users can customize performance counters, selecting specific metrics to monitor and can track long-term trends or issues for troubleshooting. Performance Monitor allows for real-time monitoring of system performance and can be configured to send alerts when predefined thresholds are exceeded, helping with proactive system management. This tool is useful for diagnosing performance bottlenecks, resource overloads, and system failures by providing in-depth insights into various system components. The Group Policy Editor is a Windows tool that allows administrators to configure system and user settings, including security policies, application restrictions, and system behavior. The Group Policy Editor is accessible via the Microsoft Management Console snap-in, providing a centralized interface for managing policies across multiple machines in a domain or local computer. It enables administrators to configure both local policies and domain policies, including security settings, login scripts, and software installation restrictions. Administrators can set security settings such as password policies, user rights, and software restrictions to ensure compliance and security standards are met. Group Policy Editor is available in Windows Pro, Enterprise, and Education editions, but it is not included in Windows Home editions, limiting some advanced management features. The System Information tool in Windows provides detailed information about the system's hardware, software, and resources, including CPU, RAM, storage, and device drivers. While Task Manager is primarily used for performance and process monitoring, the System Information section within it can be accessed to view system details and health data. This feature includes insights into the operating system version, build, manufacturer, memory usage, and other crucial system components. System information is useful for diagnosing hardware issues, identifying system bottlenecks, and understanding the resources being used by different hardware components. Users can export the system information to a file for further analysis or to share with support teams for troubleshooting purposes. Resource Monitor is a tool that provides real-time monitoring of key system resources such as CPU, memory, disk, and network usage, offering more detailed information than Task Manager. Users can open Resource Monitor from the Performance tab in Task Manager, allowing for easy access to advanced resource monitoring features. Resource Monitor breaks down system resource usage by specific processes and services, providing detailed data on memory usage, disk I/O, network activity, and CPU usage. This tool is essential for identifying performance bottlenecks, monitoring disk and network activity, and diagnosing issues that impact system responsiveness. Resource Monitor allows users to filter and sort processes and services based on resource usage, enabling users to identify and manage high resource consuming processes. The System Configuration tool, also known as msconfig, allows users to configure startup settings, system services, and boot options to improve system performance and troubleshoot issues. While Task Manager does not directly handle system configurations, it provides a link to the System Configuration utility for adjusting system startup behaviors and managing services. Users can enable or disable startup programs, helping to reduce boot time and improve system performance by preventing unnecessary applications from launching at startup. System Configuration provides an interface to manage Windows services, enabling users to start, stop, or disable services that may be causing system problems or slowing performance. The tool also allows users to modify boot settings, such as booting into safe mode or adjusting startup options for troubleshooting and repair. Disk Cleanup is a built-in utility in Windows that helps users free up space on their hard drive by removing unnecessary files, including system files, temporary files, and cached data. While Disk Cleanup is not directly accessible through the Task Manager, users can initiate it from the Performance tab by selecting the Open Disk Cleanup option or use it independently from the Start menu. Disk Cleanup scans for unnecessary files such as temporary files, internet cache, system files, and old Windows installations, providing users the option to delete them safely. By removing redundant files, Disk Cleanup helps optimize system performance, improve storage space, and prevent issues related to low disk space. The tool also provides an option for cleaning up system files such as Windows Update files that can take up significant disk space over time. Disk Defragment is a tool in Windows that reorganizes fragmented data on a hard disk drive to improve access speed and overall system performance. While disk defragmentation is not directly managed in Task Manager, users can access it from the Performance tab in Task Manager by selecting the Open Disk Defragmenter option or access it independently through the Start menu. Fragmentation occurs when files are split across different physical sectors of the hard drive, leading to slower read and write operations. Disk defragmentation helps consolidate fragmented data for faster access. Disk defragmentation is primarily beneficial for HDDs or hard disk drives as it optimizes read and write speed, but it is generally not needed for SSDs or solid-state drives, which do not suffer from fragmentation in the same way. Windows automatically schedules periodic defragmentation for hard disk drives to maintain optimal performance, but users can also manually run the tool when needed. The Registry Editor, or regedit, is a tool that allows users to view and modify the Windows registry, which is a hierarchical database that stores configuration settings for the operating system and applications. The Windows registry is divided into key sections or hives like HKey local machine, HKey current user, and others, each containing settings that affect various parts of the system. Registry Editor enables advanced users to modify system settings, including startup programs, user preferences, and system policies, offering more granular control over the system. Editing the registry can have significant impacts on system stability and performance, and it is essential to back up the registry before making any changes to avoid potential system damage. So here are some of the most important Windows command line tools. These specifically are for the CompTIA A+ exam, but these are on a lot of different exams, and it's just nice to know these in general as well. ipconfig. This one displays information about the computer's network connections, including IP addresses, subnet masks, default gateways, and more. Ping. This sends 4 test packets to a specified network address or hostname to check for connectivity and measure response time. Hostname. This displays the computer's hostname or changes it to a new value. Netstat. This displays the active network connections, including ports, protocols, and IP addresses. NSLOOKUP. This one queries a DNS server for information about a specified domain or hostname. CheckDisk checks a specified disk drive for errors, and if possible, it will repair them as well. NetUser. This displays or modifies user accounts on a computer system. NetUse. This displays or modifies network connections to shared resources on other computers. Traceroute traces the route taken by network packets from the computer to a specified destination, showing each intermediate hop and response time along the way. Format is a very dangerous one. This formats a drive, erasing all the data from the entire drive.
These next three, copy, xcopy, and robocopy, will do copy first, copies files from one location to another with limited options for preserving attributes and permissions. Xcopy copies files and directories from one location to another with additional options for preserving attributes and permissions. Robocopy is a more advanced version of the copy command. It has additional options for copying files and directories and handling errors. GP Update refreshes the group policy settings on a computer system, pulling the latest settings from a domain controller. GP Result displays the group policy settings currently in effect on a computer system. Shutdown will, of course, shut down or restart a computer system. There are various options for timing and additional behavior. SFC System File Checker scans and repairs system files on a computer system. This one displays any help information for any specified command. DiskPart manages disk partitions and volumes. PathPing combines the functionality of ping and traceroute. It sends packets along a network path and measures response time at each hop. WinVer is just going to display the current version and build number of the Windows operating system you're running. So hopefully this was able to clarify some things for you, and if you're interested in this, you might be interested in a lot of the other videos we have on the videos page.
Now we're on to Windows commands. The cd or change directory command is used in the command prompt to navigate between directories or folders in the system. The basic syntax for the cd command is cd and then the directory, where directory is the path of the folder you want to move to. You can use cd ... to move up one directory level, and cd / to go to the root directory of the current drive. The cd command can accept absolute paths, for example cd user's name, or relative paths, for example cd documents, depending on your location within the file system. The cd command does not list directory contents, but it works in conjunction with the directory command to view the files and subdirectories within a folder. The directory command, or dir, is used in the command prompt to list the contents of a directory, including files, subdirectories, and other information like size, date, and time of creation. The basic syntax is dir directory, where directory is the path to the folder whose contents you want to view. If no directory is specified, dir lists the contents of the current directory. The directory command supports various switches such as /p, pause after each screen of output, /s, list files and subdirectories, and /b, display a bare format with just file names. The dir command can also be used to sort output by date, time, or file size using additional switches like /o, n for sorting by name. The command also provides useful file details such as file attributes, sizes, and creation or modification times, which can be helpful for system management. The ipconfig command in Windows is used to display and manage network configuration information, including IP addresses, subnet masks, and default gateways for network interfaces. The basic command, ipconfig, provides a summary of the current network configuration, including the IP address, subnet mask, and default gateway for each active network interface. ipconfig supports several useful switches, such as /all to display detailed network configuration, /release to release the current DHCP lease, and /renew to renew the DHCP lease. The ipconfig command is commonly used for troubleshooting network connectivity issues, allowing users to check their network settings and renew IP addresses as needed. Using ipconfig/all, users can view additional information, including DNS servers, DHCP server details, and network adapter information. The ping command is used to test network connectivity by sending ICMP echo request messages to a target IP address or domain and measuring the response time. The syntax for the ping command is ping hostname or ping IP address, which sends a request to the target and reports the time it takes for the request to be returned. Ping is commonly used to troubleshoot network connectivity problems, verifying whether a device or server is reachable over the network. The ping command has useful switches such as /t to continuously ping until manually stopped, /n count to specify the number of requests, and /l size to adjust the size of the packet sent. By using ping, users can identify issues like packet loss and latency, which may indicate network congestion or other connectivity problems. The netstat command provides information about active network connections, open ports, routing tables, and network statistics, offering valuable insights into network activity and system communication. Running netstat displays a list of active connections, including the local and remote IP addresses, along with the state of each connection, for example, established or listening. Netstat is essential for diagnosing network issues, identifying unauthorized connections, and verifying which applications are using network resources. The netstat command supports switches like /A to display all connections and listening ports, /B to show the executable involved in creating each connection, and /N to show numerical IP addresses and ports instead of resolving names. By monitoring open ports and active connections, netstat is also useful for security audits, helping to detect suspicious or malicious network activity. The NSLOOKUP command is a network utility used to query DNS or domain name system servers to retrieve domain name or IP address information, helping to troubleshoot DNS-related issues. The basic syntax for NSLOOKUP is NSLOOKUP domain name, which returns the IP address associated with the given domain name or vice versa, depending on the query type. By entering NSLOOKUP without parameters, users enter in interactive mode where they can query multiple domains and adjust settings like DNS server addresses. NSLOOKUP can be used to perform specific DNS lookups, including reverse DNS queries, finding a domain name from an IP address, and querying specific DNS servers using the server command with interactive mode. It is commonly used for troubleshooting DNS resolution issues, verifying domain configurations, and checking the connectivity between local and external servers. The netuse command is used to connect, disconnect, and manage network drives or shared resources in Windows, allowing users to map network drives to local drive letters. The basic syntax for netuse is netuse drive letter, network path, where drive letter is the desired local drive letter, and network path is the network share or folder being connected. This command is commonly used to map shared folders from other computers or servers, enabling users to access resources as though they are local drives. Netuse also allows users to specify user credentials using /user username password for connecting to network resources that require authentication. The command can also be used to disconnect a network drive with netuse drive letter delete, which helps manage and clean up network connections. The traceRT command, short for traceroute, is used to trace the path that packets take from a source computer to a destination host or IP address, helping to diagnose network routing issues. The basic syntax is traceroute hostname or traceroute IP address, which sends a series of ICMP echo requests to each router along the path to the destination and measures the time taken for each hop. Traceroute provides a detailed list of hops showing the routers the packet passed through and the round trip time or RTT for each hop, helping to identify where delays occur. By using traceroute, users can pinpoint network bottlenecks or failed connections by observing which hop takes the longest or fails to respond, aiding in troubleshooting routing or connectivity issues. Some routers may be configured to block ICMP echo requests, causing traceroute to display timeouts or incomplete route information. The pathping command combines the functionality of both traceroute and ping, providing detailed information about network performance by tracing the route and calculating packet loss at each hop. The basic syntax is pathping hostname or pathping IP address, which sends packets to each router along the route to the destination and then reports the packet loss and latency for each hop. Unlike traceroute, pathping performs a more thorough test by sending multiple packets to each hop and analyzing the results, helping to identify both latency and packet loss issues more accurately. The command is useful for pinpointing specific network issues, such as high packet loss or delays at particular hops, which can indicate congestion or faulty hardware. Since pathping tests each hop multiple times, it typically takes longer to complete than a standard traceroute or ping test. The check disk command is used to check the integrity of a disk and repair any errors or bad sectors in the file system, improving system stability and preventing data loss. The basic syntax is check disk drive letter, where drive letter is the letter assigned to the drive you want to check, such as check disk C to check the C drive. The check disk command scans the file system for issues such as file system errors, bad sectors, and lost clusters, and it can fix logical errors or mark bad sectors to prevent data corruption. Useful switches include /F to automatically fix errors, /R to locate bad sectors and recover readable data, and /X to force the drive to dismount before checking. Regularly running check disk can help prevent issues with hard drives and solid-state drives by ensuring the integrity of the file system and recovering lost data from damaged sectors. The format command is used to prepare a storage device, such as a hard drive or USB drive, for use by erasing all the existing data and setting up a new file system. The basic syntax for the format command is format drive letter, where drive letter is the letter assigned to the drive you wish to format, such as format D for formatting the D drive. When using format, users can specify the file system to use, such as FAT32, NTFS, or exFAT, depending on the needs of the device and its intended use. The format command erases all data on the selected drive, so it's important to back up any important files before proceeding. The process cannot be undone. Switches like /q, quick format, and /fs, file system to specify the file system, allow for more customized formatting, with /q performing a faster but less thorough format. The diskpart command is a powerful disk management tool used to manage disk partitions, format drives, and perform low-level operations on storage devices. The diskpart command is run in an elevated command prompt, where users can interactively select disks, partitions, or volumes and issue commands like creating, deleting, and resizing partitions. Users can perform tasks such as creating, deleting, and formatting partitions, as well as changing drive letters or converting disk formats, for example, MBR to GPT. Before performing operations, users must select a disk or partition using commands like select disk with the number and select partition with the number to specify the target for the operation. Common diskpart commands include create, delete, extend, shrink, and list to display available disks, partitions, and volumes. The md or make directory command is used in the command prompt to create new directories or folders within the file system. The syntax for the md command is md directory name, where directory name is the name of the new folder to be created, such as md documents to create a documents folder. Users can create multiple directories in a single command by specifying multiple directory names, for example, md, folder 1, folder 2, and folder 3. The md command can also create nested directories by using a path such as md, c, users, new user, documents, new folder, which will create the entire folder structure if it doesn't already exist. If the specified directory already exists, the md command will not overwrite it, but will return an error indicating the directory already exists. The rmdir, or remove directory command, is used to delete empty directories or folders in the file system through the command prompt. The syntax for the remove directory command is rmdir directory name, where directory name is the name of the directory you want to remove, such as rmdir old folder to delete the old folder. By using the /s switch, rmdir/s directory name, users can remove directories that contain files and subdirectories, but the command will prompt for confirmation before deleting. The /q switch, rmdir/s/q directory name, can be used for quiet mode, which will suppress prompts and forces the deletion of the directory and all its contents without confirmation. If the specified directory does not exist or is in use by another process, rmdir will return an error indicating the issue. Robocopy, or robust file copy, is a command line tool in Windows used to copy files and directories with advanced options for reliability, speed, and customization. The syntax for robocopy is robocopy source, destination, where source is the path to the directory or file to be copied, and destination is where the files will be copied to. Robocopy can copy entire directories, including their subdirectories and files, with the /e option ensuring that empty directories are also copied. The command supports a variety of switches such as /mir for mirroring directories, /copyAll for copying all file attributes, and /rn to specify the number of retries on failed copies. Robocopy includes built-in logging and error handling capabilities, allowing users to generate logs of the copying process and deal with any issues, such as network errors during file transfers. The hostname command is used to display the hostname of the computer, which is the name assigned to a device on a network. Running the hostname command in the command prompt simply returns the current hostname of the system, helping users identify their machine on the network. The hostname is essential for network communication as it helps distinguish devices on a local or wide area network. The hostname command itself does not allow users to change the hostname, but it provides the system's current name, which can be changed via the system properties or PowerShell. This command is used in network troubleshooting or configuration, helping users confirm the name of the machine when setting up or diagnosing network connections. The netuser command is used to manage user accounts on a Windows system, allowing administrators to create, modify, or delete user accounts. The basic syntax is netuser, username, password, /add, which creates a new user account with a specified username and password. It can also be used to change user attributes, such as their password or group membership. Administrators can use netuser to delete a user account with /delete, modify account settings, or list all user accounts on the system using the /list option. The command allows the addition of users to specific groups and the assignment of permissions to control what users can access or modify. Netuser is often used in security and troubleshooting to reset passwords, disable accounts, or audit account activity on a system. The winver command is used to display detailed information about the Windows operating system version installed on a computer, including the edition, build number, and version. Simply typing winver in the command prompt opens a window that shows the Windows version, build number, and service pack if applicable, helping users verify the OS version and updates. The winver command displays the Windows edition, for example, Home, Pro, or Enterprise, which is essential for identifying available features and support options. This command is useful for troubleshooting system compatibility issues, ensuring software is compatible with the correct version or build of Windows. Unlike many other commands, winver does not require any parameters or switches to execute. It simply shows the version info in a dialog box. The whoami command is used to display the current logged-in user's username in Windows, showing the account that is currently active in the session. Simply typing in whoami in the command prompt returns the username of the currently logged-in user, which is useful for verifying the active account. The whoami command can also display the domain if applicable, in addition to the username, formatted as domain \username, indicating whether the user is part of a network domain. The whoami command supports switches like /groups to display user groups associated with the current user, or /priv to show the privileges assigned to the user account. Whoami is useful for user management and security auditing, helping verify user identity and privileges in various environments, including local or domain-based systems. The question mark command is used in conjunction with other commands in the command prompt to display help information about the command, including its syntax, switches, and usage. To use the help feature, simply type the command followed by /, such as dir /, or ping /. This provides detailed information about how to use the command and the options available. The /? switch is an essential tool for quickly understanding what parameters, switches, or arguments can be used with a particular command. It serves as a built-in help system, making it easy for users to learn about command line tools without needing to access external documentation or online resources. The /? switch is particularly helpful for troubleshooting and learning the correct syntax for various commands, especially for complex tools with multiple options. The GP update command is used to refresh group policy settings on a local machine, ensuring that any changes to user or computer policies are applied immediately without needing to reboot the system. The syntax for GP update is simple. Typing GP update in the command prompt triggers the update process for both user and computer policies. The force switch can be used with GP update /force to reapply all group policies, even those that have not changed, ensuring that all policies are updated regardless of their current state. The command updates both user and computer configuration policies and is useful in environments where Active Directory policies have been modified. GP update is particularly useful in troubleshooting group policy issues, ensuring that new policies are applied without the need to wait for the typical update cycle or a system restart. The GP result command is used to display the group policy settings applied to a computer or a user, helping administrators analyze and troubleshoot the effects of group policy on a system. The syntax for GP result is GP result /r, which provides a summary of the applied group policies for the current user and computer, including details about security settings, software settings, and administrative templates. The /h switch generates a detailed HTML report that provides a comprehensive view of applied policies, making it easier to review and share the policy results. By using the /user and /scope switches, administrators can generate group policy results for specific users or computers, enabling precise troubleshooting. The GP result command is vital for troubleshooting group policy issues as it reveals which policies are applied, what settings are active, and if any conflicts or errors exist. The SFC, or System File Checker, command is used to scan and repair corrupted or missing system files in Windows, helping maintain system stability and functionality. The basic syntax is SFC/scanNow, which scans all protected system files and attempts to fix any issues it finds, replacing corrupted files with correct versions from the Windows system image. The SFC command can also be used with the /scanFile switch to scan and repair a specific file rather than the entire system. The SFC command generates a log of its actions, which can be reviewed to check for specific errors or problems, helping with troubleshooting and verifying repairs. If SFC is unavailable to fix a problem, it can be combined with the DISM, or Deployment Imaging Service and Management tool, to repair the Windows image and resolve deeper system issues. The Internet Options settings in Windows allow users to configure settings related to web browsing, network connections, security, and privacy. These settings can be accessed through the control panels or the Settings app and are typically used to manage settings for Internet Explorer and other web browsers using Windows settings. The Connections tab in Internet Options allow users to configure dial-up settings, VPN connections, and proxy settings, ensuring proper network access and Internet configuration. The Security tab provides options to set different security levels for different zones, for example, Internet, Local Intranet, Trusted Sites, helping to protect users from malicious content and control which sites can be accessed. Users can control cookies, pop-up blockers, and history settings from the Privacy tab and adjust advanced settings for browser behavior and performance through the Advanced tab. The Devices and Printers section in Windows settings provides a centralized location for managing and configuring hardware devices such as printers, scanners, and other peripherals connected to the system. From this menu, users can easily add new devices, for example printers or Bluetooth devices, by selecting Add a Device or remove devices that are no longer in use. Users can manage device settings, view device status, and troubleshoot issues related to specific devices, ensuring they function properly and are ready for use. The Printers section allows users to configure and manage print jobs, set default printers, and access printing preferences such as paper size, quality, and orientation. Windows offers built-in troubleshooting tools for devices in this section, helping users diagnose and fix issues with connected hardware quickly. The Programs and Features section in Windows settings allows users to manage installed applications, including installing, uninstalling, and modifying software. Users can easily remove unwanted programs by selecting them from the list and choosing the Uninstall option, helping to free up system space and improve performance. The Turn Windows Features On or Off option allows users to enable or disable specific Windows features, such as Internet Explorer, Hyper-V, or Windows Defender. Many installed programs offer a repair option in Programs and Features, which can help fix corrupted files or resolve issues with the software without needing a full reinstall. Users can also view installed Windows updates and manage updates from this section, including the ability to uninstall specific updates if necessary. The Network and Sharing Center in Windows settings provides a centralized location for managing network connections, viewing network status, and configuring network settings. Users can view details about their active network connections, including wired and wireless connections, and manage network adapters through this section. The center allows users to set up a new network connection, such as connecting to a wireless network, creating a home group, or configuring a VPN connection. The center also provides file and printer sharing settings, allowing users to enable or disable network sharing and set permissions for sharing files and printers between the devices on the network. The Troubleshoot Problems option within the Network and Sharing Center helps diagnose and resolve common network-related issues, such as connection problems or misconfigured settings. The System section in Windows settings provides essential information and configuration options for your computer's hardware and operating system. Users can view details such as the processor type, installed RAM, system type, and Windows version, offering a clear overview of the system's capabilities. The Advanced System Settings link allows users to configure performance options such as adjusting visual effects, managing virtual memory, and setting up user profiles. The Systems section also provides links to System Protection, where users can configure restore points and manage Windows backup settings. Users can configure remote access to the computer, allowing for remote assistance or remote desktop functionality, which is essential for IT management and support. The Windows Defender Firewall is a built-in security feature that helps protect your computer by filtering incoming and outgoing network traffic based on security rules. The firewall can be accessed and configured from the Windows Settings or Control panel, where users can enable or disable the firewall and customize its settings. Users can manage inbound and outbound rules to control which applications or services are allowed or blocked from accessing the network, helping to secure sensitive data. The firewall operates under different network profiles, for example, domain, private, or public, allowing different levels of protection depending on the type of network the computer is connected to. The Windows Defender Firewall provides logs and alert settings, allowing users to monitor network traffic, troubleshoot issues, and receive notifications about potential security risks. The Mail section in Windows Settings is used to configure email accounts and manage the default email application for sending, receiving, and managing emails. Users can select the default email client, such as Mail App or Outlook, for handling email tasks, ensuring emails are opened and sent using the preferred program. In the Email section, users can add or remove email accounts, configure incoming and outgoing server settings, and adjust sync preferences for email accounts. Users can set up synchronization preferences for email, contacts, and calendar, ensuring that emails and related information are kept up to date across devices. The Mail settings allow users to configure notifications for new emails, customizing how alerts are shown for incoming messages. The Sound section in Windows Settings allows users to configure and manage audio devices, volume levels, and sound preferences for the system. Users can choose the default output device and input device for their system, ensuring the correct device is used for audio playback and recording. The Sound settings provide options to adjust system volume, balance, and specific app volume levels, allowing for a customized audio experience. Users can manage sound effects and enhancements such as enabling or disabling spatial sound, adjusting bass, treble, and other audio properties for better sound quality. The Sound settings also provide options for troubleshooting audio problems, helping users identify and resolve issues with audio playback or devices. Device Manager in Windows Settings allows users to view and manage the hardware devices connected to their computer, providing detailed information about each device's status and functionality. Through Device Manager, users can update drivers, disable or enable devices, and troubleshoot hardware issues by checking device status and error codes. Users can access detailed device properties such as driver information, manufacturer details, and device status to manage and diagnose hardware-related issues. Devices are organized into categories such as display adapters, network adapters, and sound devices, making it easier to navigate and manage various components. Device Manager is a key tool for troubleshooting hardware problems, updating drivers, and resolving conflicts between devices by checking for issues like outdated drivers or missing devices. The indexing options in Windows Settings allow users to manage how Windows indexes files and folders for faster search results, improving the speed and accuracy of searches. Users can choose which folders or drives are included in the indexing process by adding or removing locations to ensure only relevant data is indexed. Indexing options enable users to customize how file types and content are indexed, allowing for more targeted searches based on specific file attributes. If search results are not appearing as expected or if the index becomes corrupted, users can use the rebuild option to refresh the index and ensure search results are accurate and up to date. The tool also provides a status indicator for indexing, letting users monitor progress and troubleshoot issues related to the indexing process. The administrative tools in Windows Settings provide access to a suite of system management utilities designed for advanced users and administrators to manage and troubleshoot system configurations. Common tools include Event Viewer, Disk Management, Services, Task Scheduler, and Local Security Policy, which allow users to configure, monitor, and maintain system performance and security. Tools like services allow users to manage and configure system services, such as starting, stopping, or setting services to automatic or manual startup modes. The event viewer helps with troubleshooting by logging system events, while disk management is used to manage disk partitions and drives, enabling tasks like formatting or creating new volumes. These tools can be accessed through the control panel, Windows tools, or by searching in the Start menu, providing a central location for managing system settings and performing administrative tasks. The View Hidden Files option in File Explorer allows users to view files in folders that are normally hidden by the operating system, providing access to important system files. Users can enable the viewing of hidden files by navigating to File Explorer options under the View tab and selecting Show Hidden Files, Folders, and Drives. In addition to normal hidden files, users can also choose to view protected operating system files by unchecking the option to hide protected system files, although this is typically not recommended for regular use. This option is useful for advanced users who need to access or troubleshoot system files, configuration files, or application data that are otherwise not visible. Viewing hidden files can expose critical system files that, if modified or deleted incorrectly, could affect system stability. It is important to use caution when handling these files. The Hide Extensions option in File Explorer settings controls whether file extensions such as .txt, .exe, or .jpg, in addition to others, are displayed alongside file names in File Explorer. By default, Windows hides extensions for known file types, but users can enable the option to show file extensions by unchecking Hide Extensions for known file types in File Explorer options under the View tab. Displaying file extensions can help users identify potentially unsafe files, such as executable files disguised as documents, which is especially useful for preventing malware infections. When extensions are visible, users can more easily rename files with the correct extension, which can be helpful for organizing files or ensuring proper associations with applications. The Hide Extensions option is mainly a visual preference. It does not impact how files are processed, but it provides better transparency and control over file management. The general options in File Explorer settings control basic behavior and appearance settings for the File Explorer interface, such as how files and folders are displayed and accessed. Users can choose how folders open in File Explorer, such as opening a new window or in the same window, to customize their file management workflow. The General Options menu allows users to control whether recently opened files are displayed in quick access, helping to streamline file access. Users can customize settings for how folders and search results are displayed, such as choosing to show or hide the file name extensions or showing hidden files. There are options to optimize File Explorer for performance, such as reducing visual effects and adjusting folder navigation for speed, particularly useful in managing larger sets of data. The View options in File Explorer settings control how files and folders are displayed within the File Explorer window, including visual elements and layout preferences. Users can choose different view modes for folders, such as icons, list, details, tiles, and content, allowing them to display files in a way that suits their needs. View options allow users to group files by attributes such as type, size, date modified, and name, making it easier to organize large sets of data. The settings also offer the ability to sort files by specific columns like name, date modified, or size, providing better control over file organization and accessibility. View options allow users to configure whether hidden files, folders, and file extensions are shown or hidden, which can aid in system management and troubleshooting. The Hibernate Power option in Windows allows users to save the current session state to the hard drive, enabling the computer to power off completely while preserving open applications and documents. Hibernate is a power-saving mode that uses less power than sleep mode, but takes longer to resume from. It is ideal for situations where users do not need to use the system for an extended period, but want to quickly resume their session later. Users can enable or disable Hibernate through the power options in the control panel or settings menu, where they can configure which power options, sleep, hibernate, shutdown, appear in the start menu. Unlike sleep, which keeps the computer in a low power state with the session stored in RAM, Hibernate writes the session to the hard drive, allowing the system to shut down completely, which consumes no power. Hibernate requires enough free space on the hard drive for the Hiber-File sys file to store the system's current state, and it may not be available on all systems, particularly those with limited storage or older hardware. Power plans in Windows settings allow users to select or customize predefined power settings that control how the system manages energy consumption, balancing performance, and battery life. Windows offers several default power plans, including Balanced, Power Saver, and High Performance, each designed for different use cases, such as maximizing battery life or improving system performance. Users can create and customize their own power plans, adjusting settings for screen brightness, sleep mode, processor power management, and more, allowing for a tailored balance between power savings and system responsiveness. Users can quickly switch between power plans through the power and sleep settings or the battery icon in the taskbar, making it easy to adapt to different scenarios, like working on battery power or plugged in. Each power plan provides advanced settings such as adjusting when the system should sleep, turn off the display, or manage the hard drive's power state, giving users finer control over energy usage. Sleep is a power-saving state that allows the computer to quickly resume full operation when the user is ready to continue working. It saves the current session to RAM, using very little power while keeping applications and documents open. While often used interchangeably, suspend, commonly referred to as hibernate, is a more energy-efficient option where the system state is saved to the hard drive rather than RAM, allowing the system to turn off completely while preserving the session for later use. Sleep and suspend modes are both designed to conserve energy, with sleep offering quicker wake-up times and suspend being more energy efficient as it completely powers down the system. Users can configure the sleep settings to automatically enter sleep mode after a set period of inactivity, or manually initiate sleep through the power options in Windows settings. Sleep and suspend modes are particularly useful on laptops and portable devices as they allow users to quickly pick up where they left off while minimizing battery drain. The standby power option, sometimes also referred to as sleep mode, is designed to reduce power consumption by placing the system in a low power state while keeping data in RAM. Standby mode allows for faster startup than a full shutdown, as it preserves the session in memory, enabling users to resume their work without the need to reopen applications or documents. Traditional sleep, or S3 standby, saves your user session and RAM for very low power and fast wake. However, unsaved work can be lost if power is lost. Modern connected standby is very similar to traditional S3 standby or traditional sleep. However, modern standby may allow for background activity such as notifications, email sync, or more, depending on settings. Unlike Hibernate, which saves the session to disk and shuts down the system completely, standby keeps the system partially active, using a small amount of power to maintain data in RAM. The Choose What Closing the Lid Does option in Windows Power Settings allows users to define the system's behavior when the laptop's lid is closed, such as putting the system to sleep, hibernating, or doing nothing. This option is particularly useful for laptops and portable devices, enabling users to customize the power behavior based on their preferences and usage scenarios. The available actions include sleep, hibernate, shut down, or do nothing, giving users control over how the laptop should respond to closing the lid, depending on whether they are on battery power or plugged in. Users can set different behaviors for when the laptop is plugged in or running on battery power, ensuring optimal power conservation without interrupting the user's workflow. The settings can be accessed through power options in the control panel or settings, where users can make changes based on their needs for mobility and energy savings. The Fast Startup option in Windows is a power-saving feature designed to help the system start up more quickly after being shut down by combining the benefits of shutdown and hibernation. When enabled, Fast Startup saves the system state, driver information, and kernel session to the hiber sys file during shutdown, allowing for faster boot times and loading the saved state rather than performing a full boot process. This feature reduces startup time significantly, making it ideal for users who frequently power on or restart their computers and want to save time during system startup. While Fast Startup helps improve boot times, it still offers the energy savings associated with a full shutdown by not leaving the system fully powered on. Fast Startup can be enabled or disabled through the control panel power options under the Choose What the Power Buttons Do section, with the option to select whether the computer should boot quickly or perform a full restart. The USB Selective Suspend feature in Windows allows the system to selectively suspend USB devices that are not in use, helping to conserve power without affecting the operation of active devices. By suspending idle USB devices, this feature helps to reduce power consumption, especially useful for laptops running on battery, as it ensures that power is only used by active peripherals. USB Selective Suspend works automatically by detecting when a device has been idle for a period and then suspending it, allowing it to wake up when needed without user intervention. Users can enable or disable USB Selective Suspend in Power Options, typically under Advanced Power Settings, where they can also adjust the timeout for how long devices should remain idle before being suspended. While the feature helps conserve energy, it can sometimes cause issues with specific USB devices, requiring troubleshooting or disabling of the feature for devices that do not resume properly. The ease of access settings in Windows are designed to make the operating system more accessible to users with disabilities or special needs, providing a range of options to customize the user interface and system behavior. This section includes features like Narrator, which is a screen reader, Magnifier for screen zoom, on-screen keyboard, and high contrast mode, all of which help users with visual, auditory, or motor impairments navigate and use their devices. Ease of access also provides options for speech recognition, enabling voice commands and audio settings such as visual notifications for incoming alerts or messages to assist those with hearing difficulties. Users can modify settings for sticky keys, filter keys, and mouse pointer size, providing greater control over input devices for those with limited dexterity. Ease of access settings can be highly customized to meet individual needs, ensuring that users can tailor the system's behavior and appearance to improve usability and comfort. The time and language settings in Windows allow users to configure regional settings, time zones, language preferences, and input methods to personalize the system's behavior and appearance. Users can adjust the time zone, date, and time on the system, as well as configure automatic time synchronization with an internet time server for accurate system time. This section allows users to set the display language for Windows, add additional languages, and configure language-specific settings such as date formats, currency formats, and keyboard layouts. Users can customize region-specific settings such as currency, measurements, and calendar formats based on their location, making the system more adaptable to different cultures and countries. The time and language settings also provide options to configure speech recognition, typing preferences, and input methods for different language or regions, enabling multi-language support with voice-based commands. The Update and Security section in Windows Settings manages system updates, security features, and recovery options, ensuring the computer remains secure, up-to-date, and protected from potential threats. Users can check for and manage Windows updates, configure automatic update settings, and delay updates when needed. This section ensures the system receives the latest security patches, bug fixes, and feature enhancements. The Windows security settings include tools like Windows Defender Antivirus, Firewall, Device Security, and Virus and Threat Protection, offering comprehensive protection against malware, viruses, and unauthorized access. This section allows users to configure backup options, including file history, and access System Restore or Reset This PC options to recover from system failures or restore the system to a previous state. Users can view the system's activation status and manage product keys, ensuring the system is properly activated and licensed for continued use of Windows. The personalization settings in Windows allow users to customize the look and feel of their operating system, including themes, backgrounds, and colors to create a more personalized experience. This section allows users to choose custom accent colors and adjust transparency effects for start menus, taskbars, and other system elements to enhance the visual appeal of the desktop environment. Personalization options also allow users to modify the start menu layout, pin apps, and change taskbar settings, ensuring the desktop reflects individual workflow preferences. Users can select from predefined themes or create their own, adjusting desktop backgrounds, colors, and lock screen images. They can also choose slideshow options for dynamic background changes. Users can customize the lock screen image and configure Windows Hello settings for facial recognition or fingerprint authentication, adding a personalized security touch as well. The Apps section in Windows Settings allows users to manage installed applications, set default apps for specific tasks, and configure app-related settings for better system performance and organization. Users can choose default applications for varying tasks such as web browsing, email, music, and photo viewing, ensuring seamless integration of preferred software for specific actions. The app settings allow users to uninstall or modify installed apps, providing an easy way to remove unnecessary software or adjust settings for apps like storage access or notifications. Users can manage notifications for individual apps, controlling which apps can send alerts or notifications and how those notifications are presented to the user. This section also provides access to optional features like language packs, tool sets, or other add-ons that can enhance the functionality of Windows or installed applications. The privacy section in Windows settings allows users to control how their personal data is collected, shared, and used by the system and third-party apps, enhancing privacy and security. Users can manage diagnostic data sent to Microsoft, control advertising ID usage, and disable features like location tracking and speech recognition to limit data collection. The privacy settings allow users to manage app permissions, determining which apps can access sensitive data such as camera, microphone, location, and contacts. Users can control whether Windows stores an activity history of the apps and websites that they use, and decide if that data should be sent to Microsoft for personal recommendations or features. The section also provides settings to manage feedback frequency and the level of diagnostic data collected by Windows, enabling users to control the balance between system improvement and data sharing. The Devices section in Windows settings allows users to manage and configure hardware devices such as printers, Bluetooth devices, and USB peripherals connected to the system. Users can add, remove, and configure printers and scanners, manage print queues, and set default printing preferences for seamless document handling. The Devices section also allows users to pair and manage Bluetooth devices like headphones, speakers, and keyboards, as well as configure settings for other connected devices. Users can configure typing settings for autocorrection, predictive text, and other keyboard-related features, along with autoplay settings for automatically handling devices like cameras, USB drives, and DVDs. The Devices settings also provide options for troubleshooting connected hardware, helping to resolve issues with connectivity or device performance. The Network and Internet settings in Windows allow users to manage network connections, configure Wi-Fi and Ethernet settings, and troubleshoot connectivity issues. Users can connect to Wi-Fi networks, set up Ethernet connections, and adjust settings like IP addresses and DNS servers to customize network connectivity. This section also provides configuration options for setting up a VPN or virtual private network to secure internet connections and manage proxy settings for privacy and internet access control. Users can monitor data usage and set certain connections as metered to limit background data consumption, which is especially useful for users with limited bandwidth or mobile data plans. Windows offers a built-in network troubleshooter tool to diagnose and fix common connectivity issues, helping users quickly resolve problems with network access or performance. The Gaming section in Windows settings provides options to optimize the system for gaming, including features for game mode, Xbox Game Bar, and other gaming-related settings to enhance performance and the user experience. Game mode helps prioritize system resources for games, improving performance by minimizing background processes and ensuring the game receives the maximum processing power available. The Xbox Game Bar provides in-game overlays for recording gameplay, taking screenshots, and accessing other gaming features like performance metrics, allowing users to enhance their gaming sessions. Users can configure game captures, including video recording settings, and the frame rate for gameplay recordings, allowing gamers to capture high-quality footage of their sessions. Windows also includes settings to stream or broadcast gameplay, offering integration with platforms like Twitch for a seamless gaming and streaming experience. The Accounts section in Windows settings allows users to manage user accounts, sign-in options, and account-related settings, offering control over how users access the system. Users can manage Microsoft accounts and local accounts, as well as switch between account types. Sign-in options provide settings for passwords, PINs, Windows Hello, and other biometric authentication methods to improve security and ease of access. The account settings also allow users to manage family accounts and guest accounts, enabling safe sharing of the system with specific permissions for family members or temporary users. Users can control sync settings, ensuring that app preferences, passwords, and other information are shared across devices, and manage privacy settings related to that account data. In a domain-joined network, computers are centrally managed by a domain controller, while in a workgroup, each computer is managed independently without a central authority impacting how shared resources are configured and accessed. In domain-joined environments, shared resources like files and printers are managed centrally through Active Directory, providing more granular control over permissions and user access. In workgroups, resource sharing relies on local user accounts and permission. Domain-joined systems typically allow for more seamless and secure sharing of resources across multiple machines with consistent permissions and policies. In a workgroup, users must manually set up sharing permissions for each device and manage access individually. Domain-joined environments benefit from centralized security settings, policies, and automated user management, which enhances security and ease of resource sharing. In workgroups, security settings must be configured on each individual system, which can be less efficient and more prone to misconfiguration. A domain-joined network can streamline access to shared resources across multiple computers with consistent configurations, while a workgroup setup may require more manual effort to establish and maintain shared resources, especially in larger environments. In a domain-joined environment, printers are typically managed centrally through a print server and Active Directory, allowing administrators to easily deploy and manage printers across multiple devices, enforcing security policies and permissions. In a workgroup environment, printers are shared on individual computers, requiring manual configuration of permissions for each user who needs access to the printer. There is no central server for managing printer access. Domain-joined printers benefit from centralized access control, where permissions are assigned via Active Directory, providing more consistent and secure printer access. In a workgroup, user-specific permissions must be configured manually on each machine. Domain-joined networks offer greater scalability and efficiency for managing multiple printers in larger environments, while workgroups can be more suitable for small peer-to-peer networks where centralized management is not necessary. Domain-joined networks allow for easier security and maintenance, as updates, drivers, and security policies can be rolled out to all computers in the domain. In a workgroup, maintaining and update printers requires more individual effort and is less streamlined. In a domain-joined environment, file servers are centrally managed through Active Directory and a domain controller, allowing for consistent user access, security policies, and streamlined file sharing across the network. In a workgroup environment, file sharing is managed individually on each machine, requiring manual configuration of file and folder permissions on each computer for users who access files stored on different systems. Domain-joined networks provide centralized access control through Active Directory, making it easier to manage user permissions, implement security policies, and maintain consistent access across multiple systems. In workgroups, access control must be managed on each individual device, making it harder to maintain consistent security. Domain-joined file servers are ideal for larger networks with multiple users, as they support scalability, ease of management, and integration with network services. In a workgroup, file sharing is typically more suitable for small, decentralized networks where centralized management is not required. In domain-joined environments, file servers can be backed up and recovered more easily using central management tools, while in workgroups, backup and recovery must be done on a per-computer basis, leading to less efficiency. In a domain-joined environment, mapped drives are typically deployed through group policy or Active Directory, allowing administrators to automatically map network drives for users across the domain with consistent access and security. In a workgroup environment, users must manually map network drives on each individual computer, requiring configuration for each user to ensure access to shared resources on other machines in the workgroup. Domain-joined networks provide centralized management of access through Active Directory, making it easier to manage drive mappings, permissions, and security settings for users. In workgroups, access control must be set individually on each system, increasing the potential for inconsistency and security risks. In domain-joined environments, drive mappings can be automated, ensuring seamless access for users as they log in, which is highly scalable for larger networks. In workgroups, the manual setup of mapped drives makes this process less efficient, especially in networks with multiple devices. Troubleshooting mapped drives in a domain-joined environment is simplified due to centralized control and visibility of settings. In a workgroup, resolving issues often requires checking each machine individually, which can be time-consuming. Local operating system firewall settings allow administrators to configure application restrictions, blocking or allowing specific applications from accessing the network based on security policies or system requirements. Exceptions can be created in the firewall settings to allow specific applications or services to bypass the firewall, ensuring necessary network communication while maintaining overall security. Administrators can set inbound and outbound rules to define which applications can send and receive data through the firewall, allowing for granular control over network traffic and application security. Application restrictions and exceptions play a key role in securing the system by blocking potentially harmful apps, while exceptions ensure that trusted applications such as email clients or business applications have network access. The firewall settings include the ability to monitor and log application traffic, allowing administrators to review activity and ensure compliance with security policies, as well as troubleshoot issues related to blocked applications. The local operating system firewall in Windows helps control inbound and outbound network traffic based on predefined security rules, protecting the system from unauthorized access while allowing legitimate communication. Administrators can configure inbound rules to control what data is allowed to enter the system, and outbound rules to control what data can leave the system, providing granular control over network traffic. The firewall can be configured to allow or block specific applications or services, creating exceptions for trusted software while blocking potentially harmful programs from accessing the network. Firewall settings allow for control over specific ports and protocols, enabling or restricting network traffic based on port numbers to enhance network security. Windows Firewall uses different profiles, for example, domain, private, or public, to apply different security settings depending on the type of network the system is connected to, ensuring appropriate protection in various environments. An IP addressing scheme is essential for assigning unique addresses to devices in a network, ensuring that data is properly routed between systems and can communicate over a network. IP addresses can be assigned dynamically through DHCP or Dynamic Host Configuration Protocol, or statically where the address is manually configured and remains fixed for a device, offering different levels of control and flexibility. The IP address scheme includes the concept of subnetting, which divides large networks into smaller, manageable segments, improving network organization, performance, and security. Traditional classful addressing, Class A, B, and C, is used to allocate IP addresses based on network size, though classless interdomain routing, or CIDR, is now preferred for more efficient address allocation. Private IP addresses are used for internal network communication and cannot be routed on the public internet, while public IP addresses are assigned by ISPs or internet service providers and are routable across the internet. The Domain Name System, or DNS, is responsible for translating human-readable domain names into IP addresses that computers can understand, enabling efficient communication over the internet. In client networking, DNS settings configure the primary and secondary DNS servers, which determine where the system sends requests for domain name resolutions. DNS settings can be static, where the DNS servers are manually configured, or dynamic, where DNS servers are assigned automatically via DHCP or Dynamic Host Configuration Protocol. Incorrect or misconfigured DNS settings can lead to website access issues or slow connection times, and the NSLookup command can be used to troubleshoot DNS-related problems. Windows caches DNS queries to speed up repeated requests, but users can clear the DNS cache with the ipconfig/flush DNS command if issues arise, ensuring that outdated or corrupted DNS records are removed. The subnet mask is used in networking to define the range of IP addresses that belong to a particular network, allowing devices to identify whether another device is on the same network or a different one. The subnet mask helps IP address classification, separating the network portion from the host portion of an IP address. It works by masking which part of the IP address is used for network identification and which part is used for device identification. Typically written in dotted decimal notation, the subnet mask consists of a series of ones, followed by zeros, where the ones identify the network portion and the zeros identify the host portion. Subnet masks can also be represented in CIDR notation or classless inter-domain routing notation, such as /24, which indicates the number of ones in the subnet mask. Proper configuration of the subnet mask is critical for subnetting, which helps divide larger networks into smaller, more manageable subnets, improving network performance and security. The gateway in a network configuration is a device that serves as an entry and exit point for traffic between different networks, often connecting a local network to the internet or other external networks. In a typical client networking configuration, the default gateway is the IP address of the router or firewall that provides access to resources outside the local network, such as the internet. The gateway is responsible for routing traffic from devices within a local network to remote networks, ensuring data reaches destinations beyond the local subnet. The default gateway can be assigned dynamically via DHCP or configured statically for devices requiring a fixed gateway IP address for consistent network access. Incorrect or unreachable gateway settings can prevent devices from accessing external networks, and issues can be diagnosed using commands like ping or traceroute to verify network connectivity. Static IP addressing involves manually assigning a fixed IP address, subnet mask, default gateway, and DNS servers to a device. This configuration is useful for servers or devices that require a consistent address for communication and network services. Dynamic IP addressing uses DHCP or Dynamic Host Configuration Protocol to automatically assign an IP address and other network settings to a device each time it connects to the network, reducing the need for manual configuration. Static IP addresses offer consistency, making them ideal for devices like printers, servers, or networked devices that need to be reliably accessed via the same address. Dynamic IP addressing simplifies network management, particularly for larger networks, as devices are automatically assigned IP addresses and network settings, reducing human error and administrative overhead. Static IPs are typically used for devices that need to be easily located and constantly reachable, while dynamic IPs are more commonly used for devices that are user devices like laptops, desktops, and mobile devices in larger or changing networks. Now we have a visualization for a VPN network, and you can see on the bottom the user's device going through the internet service provider without the VPN to the website, and then on the top you can see the VPN client and VPN server added to be an intermediary between the user's device and the website or any other source. A virtual private network creates a secure and encrypted connection between a client device and a remote network, allowing users to send data securely over the internet. VPNs provide privacy by masking a user's IP address and encrypting data, which is particularly useful when connecting to public networks or accessing remote resources securely. In Windows, users can configure a VPN connection through the network and internet settings, where they can specify the type of VPN and provide required authentication information such as a username and password. Windows supports various types of VPN protocols, including PPTP, L2TP, IPsec, IKE-v2, and SSTP, each offering different levels of security and performance based on network needs. VPNs are commonly used for remote access to corporate networks, ensuring that users can securely access internal resources such as files, applications, and databases from outside the office. Wireless networking in Windows allows devices to connect to a Wi-Fi network without the need for physical cables, using Wi-Fi adapters to communicate with wireless access points, WAPs, or routers. To establish a wireless connection, users can access the network and internet settings in Windows, select the available Wi-Fi network, and enter the appropriate security credentials, for example, password or WEP/WPA key. Windows provides options to manage Wi-Fi settings, including network priority, auto connect, and network profiles to customize how devices connect to different wireless networks. Tools such as the Network Troubleshooter in Windows can help diagnose and fix common wireless connection issues such as incorrect credentials, weak signal, or interference. It's important to configure wireless connections with proper encryption methods like WPA2 or WPA3 to protect data privacy and prevent unauthorized access to the network. A wired network connection in Windows is established using an Ethernet cable to connect a computer to a network switch, router, or modem, providing a reliable and stable internet or local network connection. For wired connections, IP addresses can be assigned automatically via DHCP or manually set as static IP based on network requirements and administrative preferences. In Windows, users can configure wired network settings under Network and Internet Settings, where they can set static or dynamic IP addresses and adjust other settings such as DNS and gateway preferences. If issues arise with a wired connection, users can use tools like Network Troubleshooter and check physical connections, for example Ethernet cables and ports, to diagnose and resolve connectivity problems. Wired connections are generally more stable and offer higher speed and lower latency compared to wireless connections, making them ideal for activities requiring consistent and high-speed internet access, such as streaming, gaming, or large file transfers. WWAN, or Wireless Wide Area Network, refers to a type of cellular network that allows mobile devices to connect to the internet through cellular data services typically provided by mobile carriers like Verizon, AT&T, or T-Mobile. In Windows, devices with cellular network capabilities can use mobile broadband or USB modems to connect to the internet via a WAN, which provides mobile users with internet access on the go. Cellular network settings can be configured in Network and Internet settings, where users can set up mobile data connections, manage data usage, and configure network preferences like roaming and data limits. WAN provides mobility and convenience, allowing users to access the network from almost anywhere within the coverage area of their cellular network provider, making it ideal for remote work or traveling. When using cellular networks, it's important to manage roaming settings and data usage limits to avoid additional charges when traveling outside the home network's coverage area. A proxy server acts as an intermediary between a client and the internet, helping control network traffic, enhance security, and enable content filtering, especially in corporate environments. In Windows, users can configure proxy settings in the Network and Internet section of the Settings menu, where they can manually enter the proxy server's address and port or use automatic proxy configuration or PAC files. Proxy settings can be configured either manually by entering the IP address and port of the proxy server, or automatically using scripts or WPAD, Web Proxy Auto Discovery Protocol, for dynamic proxy setup. Using a proxy server can help improve network performance by caching frequently accessed content, enhance security by hiding the client's IP address, and enforce network policies by controlling internet access. If users experience connectivity issues when using a proxy, it is essential to verify proxy settings, check network connectivity, and ensure that the proxy server is operational. In Windows, networks can be classified as public or private based on their security settings and how devices are allowed to communicate with each other. A private network is typically used for trusted environments, such as home or office networks, where devices can share resources like files and printers. Windows configures the network to allow communication between devices, making it easier to set up local network features. A public network is typically used for untrusted networks like public Wi-Fi hotspots. Windows applies stricter security settings to public networks, preventing devices from being discoverable and restricting sharing to minimize potential security risks. The private network setting allows devices to discover each other and share resources, while public networks disable such features to protect the system from potential threats, especially in public or unsecured environments. Users can easily switch between private and public network types in Network and Internet settings, depending on whether the network is considered trusted or untrusted. File Explorer in Windows is the primary tool for navigating, managing, and accessing files in folders on the local machine and connected network drives. It provides a graphical interface to easily browse directories, search for files, and manage file properties. Network paths are used to access shared folders and resources on other computers or servers within a network. They are often in the form of UNC or Universal Naming Convention paths, such as // computer name, / shared folder, which allow users to map or access network drives. Users can map network drives through File Explorer by assigning a drive letter to a network location, making it easier to access shared folders without repeatedly entering the entire network path. File Explorer allows users to access network resources by entering the network path in the address bar or through the network section, where devices and shared folders on the local network can be discovered. For network paths to work properly, network discovery and file and printer sharing must be enabled on both the local and remote machines, ensuring that the network devices can communicate and share resources. A metered connection is a network connection where data usage is limited, such as mobile data or certain internet plans with data caps. Windows allows users to set network connections as metered to help manage data usage. Users can configure a Wi-Fi or Ethernet connection as metered through the Network and Internet settings, which prevents certain apps from using excessive data in the background, helping to avoid overage charges. When a connection is set as metered, Windows limits automatic updates, live tile updates, and some background data usage while still allowing the user to manually download updates and use apps as needed. Metered connections limit the ability of apps to run updates, sync data, or download large files automatically. This helps prevent the consumption of large amounts of data, which is crucial for users with data-sensitive internet plans. Metered connections are commonly used for mobile hotspots or when connecting to networks that have data caps or slow internet speeds, allowing users to control their data usage more efficiently. A DMG or disk image file is a compressed file format in macOS used to package and distribute applications, system files, and other resources. It acts as a virtual disk that can be mounted on the desktop for easy installation. To install an application from a DMG file, users typically mount the file by double-clicking it and then drag the application icon to the Applications folder, which is the standard method for installing apps on macOS. Uninstalling an application installed via a DMG file is straightforward. Users can simply drag the application from the Applications folder to the trash, as macOS apps are generally not installed with complex registry entries like on Windows. DMG files are often signed and verified by Gatekeeper, macOS's security feature, ensuring that the application hasn't been tampered with and is safe to install. Once the application is installed, the DMG file can be ejected from the system and deleted, as it is no longer needed for running the application. A PKG file is a package file format used in macOS for installing applications, system updates, and other software packages. It contains all the files and instructions needed for installing the application. To install an application from a PKG file, users double-click the file, which launches the installer. The installer guides the user through the installation process, copying the necessary files to the correct locations on the system. PKG files often include a pre-configured installation path, allowing the application to be installed in standard locations like the Applications folder or system directories. Users may need to enter their admin password during installation to grant permission for system-level changes. Uninstalling a PKG installed application is typically not as simple as dragging it to the trash. Users may need to run an uninstaller if provided, or manually remove files that were installed in system directories. PKG files may be signed by the developer, and macOS's Gatekeeper feature checks the file for authenticity and ensures it hasn't been tampered with before installation. The app file is the application bundle format used by macOS, which contains all the resources, files, and executable code required for running a macOS application. App files are typically installed by dragging the application bundle to the Applications folder. This method does not require complex installation steps and is common for most macOS apps. Unlike PKG or DMG files, app files are already self-contained applications, meaning they do not require an external installer or additional steps beyond placing the app in the correct location. To uninstall an app file, users simply drag the application from the Applications folder to the trash, and it is removed. Some apps may leave behind additional files and system directories that need to be manually deleted for a thorough removal. The app bundle is a self-contained directory that includes all the necessary components for the app to run, such as resources, libraries, and configuration files, making it easy to manage and relocate. The Mac App Store is the official platform for discovering, purchasing, and downloading applications on macOS. It provides a secure, centralized location for apps that are optimized for macOS. To install an application from the App Store, users simply open the App Store, browse or search for the desired app, and click Get or Install. The app is then automatically downloaded and installed into the Applications folder. The App Store also manages automatic updates for installed applications, ensuring that users receive the latest versions and security patches without needing to manually check for updates. Uninstalling an app from the App Store is straightforward. Users can go to the Applications folder, find the app, and either drag it to the trash or use the App Store interface to uninstall it if supported by the app. Applications downloaded through the App Store are verified for security by Gatekeeper, ensuring that apps meet Apple's security standards and are safe for installation. In macOS, uninstalling most applications is as simple as dragging the application from the Applications folder to the trash. This removes the application from the system, though some residual files may remain. For a complete uninstallation, users may need to manually delete associated support files such as preferences, caches, and logs, often located in the library folder. Apps installed via the Mac App Store can be uninstalled from the Applications folder by dragging them to the trash, similar to other apps, with some apps providing their own uninstallers. Some third-party applications come with their own installation utilities, which can be accessed through the application settings or the installation directory, ensuring a cleaner removal process. Third-party apps like App Cleaner can assist in removing leftover files associated with uninstalled apps, helping ensure that no remnants are left behind after the main application is deleted. The Applications folder in macOS is the default location where most applications are installed and stored. It is a system directory that contains applications for the user, making it easy to access and manage software. Applications installed in the Applications folder are accessible by all user accounts on the system. These applications are typically installed by macOS or system administrators and often require administrator permissions to modify. In addition to the system-wide Applications folder, macOS also has a username, applications folder where applications can be installed for individual users. This allows for user-specific apps without affecting the entire system. The applications folder can be accessed via Finder or Spotlight, providing easy access to installed apps. Users can organize their applications by creating subfolders or grouping them based on functionality. Applications installed on the applications folder can be easily uninstalled by dragging them to the trash. Updates for these apps, especially those installed via the Mac App Store, can be managed through the App Store or System Preferences. The Users folder in macOS is a system directory that contains the home directories for all user accounts on the system. Each user has a dedicated folder under Users that stores their personal files, preferences, and application data. Inside the Users folder, each user account has its own folder typically named after the username. This folder contains the user's documents, desktop, items, downloads, and other personal data. Each user's folder also contains hidden system files and configuration settings, such as the library folder, which stores user-specific preferences, caches, and application settings. The users folder provides user-level access control, meaning that a user can typically only access their own folder and not others without administrative privileges, helping protect personal data. The users folder also contains a shared folder where files can be accessed by all users on the system, facilitating file sharing between different user accounts. The library folder in macOS is a system directory that stores critical system-wide resources, configurations, and files used by applications and the operating system itself. There are two main library folders, one located at the root level for system-wide files and one within each user account for user-specific files. The root library contains files shared by all users, while the user-specific library stores personal preferences, caches, and app-related data. The library folder contains important directories such as application support, fonts, preferences, and caches, which store system and application configurations, fonts, and cache data. The library folder at the system level is generally hidden from users and requires administrator privileges to modify, ensuring that critical system files are protected from accidental modification or deletion. The library folder is important for troubleshooting macOS performance and application issues. Deleting cache files or preferences from this folder can sometimes resolve issues, but caution is required to avoid removing essential system files. The System folder in macOS is a protected directory that contains essential operating system files, frameworks, and system-level components required for the proper functioning of macOS. The System folder is protected by System Integrity Protection, or SIP, a security feature that prevents modification of critical system files, ensuring the stability and security of the macOS operating system. Inside the System folder, you'll find system files, kernel extensions, system frameworks, and libraries that macOS relies on to operate efficiently and support the running of applications and processes. Due to SIP, most of the contents of the System folder are read-only for regular users and applications, with modification access typically restricted to system updates or administrators in recovery mode. The System folder plays a key role in macOS updates. When updates are applied, the necessary files within this directory are placed or updated, often requiring a restart of the system for changes to take effect. The Users Library folder in macOS is a hidden system folder within each user's home directory that contains user-specific configuration files, preferences, caches, and support files for applications. The Users Library folder stores individual user data such as preferences, caches, and logs for applications, as well as settings for the macOS system itself, tailored to the specific user. The Application Support subdirectory within Users Library holds data that is necessary for specific applications to function, including configuration files, databases, and other important resources. By default, the user's library folder is hidden to prevent accidental modification or deletion of important user data. It can be accessed through Finder by holding the Option key or via the Go to Folder option. The user's library folder is often used for troubleshooting macOS and applications. Users may delete or reset preferences or caches from this folder to fix issues, but caution is advised to avoid deleting important files. An Apple ID is a personal account used to access a wide range of Apple services, including the App Store, iCloud, and Apple Music, and is required to download apps or purchase content from Apple's ecosystem. On macOS, the Apple ID is used to sync data between devices, backup documents to iCloud, and access purchased apps and media. It also enables Find My Mac, a feature to track lost devices. In corporate environments, administrators can configure restrictions on Apple ID use through mobile device management solutions, limiting access to certain apps, services, or content for security and compliance reasons. Through corporate MDM systems, macOS devices can be enrolled with specific profiles that enforce security policies, such as requiring strong passwords, restricting app installations, or limiting iCloud usage to prevent data leaks. Corporations often manage Apple IDs for employees through managed Apple IDs, which allow for better control and oversight of devices and accounts, ensuring compliance with corporate policies. Time Machine is the built-in backup solution in macOS that automatically backs up the entire system, including files, applications, and system settings to an external drive or network storage that allows users to restore their system to a previous state in case of data loss or system failure. It's recommended to set up Time Machine to back up regularly to ensure data is consistently protected. Backups should be stored on a separate physical drive or network location to prevent data loss in case of hardware failure. iCloud provides a cloud-based backup option for important documents, photos, and app data. It's particularly useful for backing up user-specific data and syncing across multiple Apple devices. To ensure reliable data protection, it's best practice to follow the 3-2-1 rule for backups. Have at least 3 copies of your data, store 2 copies on different types of media, and keep 1 copy off-site or in the cloud for disaster recovery. Periodically, users should verify backup integrity to ensure that backups are being performed correctly and that data can be restored when needed. It's essential to test the restoration process to confirm backups are usable. macOS includes built-in security features such as XProtect, Apple's anti-malware system, and Gatekeeper, which help block malicious software and ensure that only trusted apps are installed on the system. Keeping macOS and all installed applications up to date is a critical best practice for preventing vulnerabilities. Apple regularly releases security updates that patch known exploits and improve system defenses. While macOS has strong built-in security, using third-party antivirus software can provide additional layers of protection, including real-time scanning and more comprehensive malware detection. Practicing safe browsing habits such as avoiding suspicious websites, not downloading untrusted software, and being cautious with email attachments is essential to prevent infections. Enabling and configuring the macOS Firewall helps block unauthorized network traffic, adding another layer of defense against potential threats. macOS is designed to automatically install security updates and other patches. Enabling automatic updates ensures that critical vulnerabilities are addressed promptly without requiring manual intervention. It's a best practice to check for system updates regularly through the App Store or System Preferences to ensure that both security patches and new features are installed. Security patches are released by Apple to address newly discovered vulnerabilities. These patches should be applied as soon as they're available to minimize the risk of exploitation. Users can configure notifications for updates, which allows them to be informed when updates are available, ensuring timely action to maintain system security and stability. In addition to macOS updates, it's important to also update third-party applications and software to their latest versions. Many apps receive updates for new features, bug fixes, and security improvements. A rapid security response involves quickly applying security patches and updates as soon as they're released by Apple to address vulnerabilities and prevent exploitation. Implementing proactive security monitoring tools to detect suspicious activity can help quickly identify and respond to potential threats before they cause significant damage. It's important to have an established incident response plan that includes identifying, isolating, and mitigating security breaches, ensuring quick and effective action in the event of a security incident. Regularly backing up macOS devices ensures that in the event of a security breach, such as malware attack or data corruption, data can be restored with minimal impact on business operations. Keeping macOS configuration secure by implementing strong passwords, enabling file vault encryption, and ensuring that firewalls are active helps limit vulnerabilities and improve rapid response capabilities. The display settings in macOS allow users to configure and adjust various aspects of the display, including resolution, brightness, and color profiles, ensuring optimal viewing and user comfort. Night shift is a feature in macOS that adjusts the color temperature of the display to reduce blue light exposure in the evening, which helps reduce eye strain and improve sleep patterns. macOS supports multiple displays, allowing users to configure additional monitors by adjusting arrangement, display resolution, and display mirroring options from the display settings in System Preferences. True Tone is a feature that adjusts the display's white balance based on the ambient light, providing a more natural viewing experience by making the screen appear consistent under various lighting conditions. macOS offers display scaling options that allow users to adjust the size of text and interface elements to improve readability or to increase screen real estate for multitasking. The network settings in macOS allow users to configure and manage various network connections, including Wi-Fi, Ethernet, Bluetooth, and VPN, enabling seamless connectivity to local and remote networks. In Network Preferences, users can view available Wi-Fi networks, select networks to connect to, and configure advanced options like network security settings and proxy settings. macOS allows users to configure a VPN connection to securely connect to remote networks. VPN settings, including server address, authentication type, and credentials can be managed within the network settings. macOS provides built-in network diagnostics tools that help users troubleshoot network issues such as connectivity problems or slow internet speeds by analyzing network configuration and identifying potential problems. For advanced users, the network settings provide the ability to configure DNS settings, IPv6, and proxy settings, giving complete control over the network connection behavior. The Printers and Scanners section in System Preferences allows users to add, configure, and manage printers connected to their macOS device, including both local and networked printers. Users can add printers by selecting Add Printer in the Printers and Scanners preferences, where they can choose from a list of available printers on the network or connected directly via USB or Bluetooth. Once a printer is added, users can access detailed settings such as paper size, print quality, and duplex printing options, as well as configure default printers and manage print queues. AirPrint is a feature in macOS that allows users to wirelessly print from their Mac to compatible printers over a Wi-Fi network without the need for additional drivers or software. The Printers and Scanners settings also allow users to manage print jobs, clear stalled print queues, and troubleshoot common printing issues, ensuring smooth printer operation. The Scanners and Cameras section in System Preferences allows users to configure and manage scanners, enabling the scanning of documents and images directly from their macOS device. Users can add scanners by selecting the Add Scanner option in the Scanners Preferences. macOS automatically detects compatible scanners connected via USB, Wi-Fi, or network and adds them to the list of available devices. Once the scanner is added, users can configure settings such as resolution, color mode, and file format for scanned documents. These settings ensure the desired output quality and file compatibility. macOS provides a built-in preview app that allows users to perform test scans before performing the actual scan, ensuring the proper setup and alignment of the document. The system settings also enable users to manage scan jobs, view error messages, and troubleshoot common issues such as connectivity or scanning failures. The Privacy setting in System Preferences on macOS allows users to control which apps and services have access to sensitive data, such as location, contacts, calendars, and microphone or camera use. Users can manage app-specific permissions, granting or denying access to various system resources like location services, photos, files and folders, and health data. Location Services lets users manage which apps and system services can access their geographical location, enhancing privacy while still allowing location-based features when needed. macOS provides options to control whether system data and diagnostics are shared with Apple for improving products and services, allowing users to opt in or out of such data collection. The Security and Privacy pane in System Preferences also includes settings for File Vault, Firewall, and Touch ID, offering a broader control over system security and privacy measures. The accessibility settings in macOS are designed to help users with disabilities by providing tools and features that enhance the system's usability, such as visual, auditory, and motor assistance. VoiceOver is a built-in screen reader that provides spoken description of what's on the screen, enabling users with visual impairments to navigate and interact with macOS effectively. Users can modify display settings, including increasing contrast, reducing motion, and enabling zoom for better visibility and reduced visual strain. macOS includes options for keyboard shortcuts, mouse and trackpad customization, and assistive touch for easier navigation, making it more accessible for users with motor impairments. The hearing section allows users to enable subtitles, adjust sound settings, and use audio balance, while the speech section enables the system to speak text aloud for users with hearing or speech impairments. Time Machine is macOS's built-in backup solution, automatically creating backups of the entire system, including files, applications, and system settings, to an external hard drive or network location. Users can configure Time Machine in System Preferences to select a backup disk, choose automatic backups, and set options such as local snapshots for offline data backup when external drives are available. Time Machine performs hourly backups for the past 24 hours, daily backups for the past month, and weekly backups for all previous months, ensuring that recent data is safely stored while older backups are automatically deleted as space is needed. Time Machine allows users to restore files, entire folders, or the entire system to a previous state, making it an invaluable tool for recovering lost data or fixing system issues. Time Machine backups can be encrypted to provide an additional layer of security, ensuring that sensitive data is protected when stored on external drives or network locations. The multiple desktop feature in macOS, also known as Mission Control, allows users to create and manage multiple virtual desktops, enhancing productivity by organizing different tasks or applications on separate screens. Users can create new desktops by entering Mission Control via F3 or swiping up with 3 or 4 fingers and selecting the plus icon. Users can easily switch between desktops using Mission Control, keyboard shortcuts, or swiping with 3 or 4 fingers. Each desktop can hold different windows or apps, allowing users to segregate tasks like work, entertainment, and research into different spaces for better focus and efficiency. Full-screen apps can be placed on their own virtual desktop, enabling users to work with full-screen programs while maintaining multiple workspaces, improving multitasking, and reducing desktop clutter. Users can easily move windows between desktops by dragging them in Mission Control, simplifying the organization of windows and tasks across multiple virtual environments. Mission Control is a macOS feature that provides an overview of all open windows, full-screen apps, and virtual desktops, helping users organize and navigate their workspace efficiently. Users can access Mission Control by swiping up with 3 or 4 fingers, pressing F3, or using hot corners to quickly view and manage open windows and desktops. Mission Control allows users to create and manage multiple virtual desktops, making it easy to organize different tasks, apps, and windows into separate workspaces for improved productivity. Mission Control displays all open windows from active applications, allowing users to quickly switch between them or drag them to different desktops for better organization. Full-screen apps appear as separate spaces in Mission Control, enabling users to easily switch between apps, arrange them, or move them to different virtual desktops. Keychain is a password management system built into macOS that securely stores and manages passwords, certificates, encryption keys, and other sensitive data, ensuring easy access while maintaining security. Keychain automatically stores passwords for Wi-Fi networks, websites, and applications, allowing users to access these services without manually entering credentials each time. The data stored in Keychain is encrypted using the user's login password, providing a secure method to store sensitive information such as credit card details and login credentials. Users can access and manage the Keychain Access app to view stored passwords, delete items, and troubleshoot issues related to credentials, certificates, and keys. With iCloud Keychain, users can sync their passwords and other sensitive information across multiple Apple devices, ensuring seamless access to passwords on iMacs, iPhones, and iPads. Spotlight is a powerful search and indexing feature in macOS that allows users to quickly find files, folders, apps, emails, documents, and even web content on their Mac. Spotlight provides fast and efficient search results by indexing content across the system, including local files, system settings, and metadata, enabling instant access to information. To use Spotlight, users can press Command and Space to open the search bar, where they can type keywords or phrases to locate items across the entire system, including apps, files, and online content. Spotlight not only provides search results, but also offers previews of files and quick actions like setting reminders or sending messages, making it a versatile tool for multitasking. Users can customize Spotlight's search behavior by adjusting the settings in system preferences, such as excluding specific folders or adjusting what content is indexed, while also managing privacy settings to prevent certain items from appearing in search results. iMessage is Apple's messaging service that allows users to send text messages, photos, videos, and more over the internet instead of using traditional SMS or MMS between Apple devices. The iMessage and iCloud feature enables users to sync their iMessages across all Apple devices signed in with the same Apple ID, including Mac, iPhone, and iPad, ensuring consistent messaging history. iMessages, including attachments, are stored in iCloud, meaning that messages are available on any device even if a user switches devices or loses their phone without losing their conversation history. To activate iMessaging on iCloud, users need to enable Messages in iCloud in System Preferences, Apple ID, iCloud, ensuring that messages and media are securely stored in iCloud and automatically synced. Since iMessages are stored in iCloud, they benefit from Apple's encryption standards, providing security and privacy. However, users should monitor their iCloud storage usage, as large message histories or media attachments can consume significant space. FaceTime is Apple's video and audio calling service, allowing users to make calls over Wi-Fi or cellular networks to other Apple devices using their Apple ID or phone number. The FaceTime and iCloud feature syncs FaceTime calls, including call history and voicemail messages, across all devices linked to the same Apple ID. This ensures that users can access FaceTime information regardless of which Apple device they use. With FaceTime and iCloud, users can start a call on one device like an iPhone and continue it on another device like a Mac or iPad, maintaining a seamless experience across multiple devices. To activate this feature, users must sign into iCloud and ensure that FaceTime is turned on for all devices under System Preferences, Apple ID, and iCloud, ensuring the call data is synced across devices. FaceTime and iCloud benefits from Apple's robust encryption standards, ensuring that all calls and communication are secure and private. iCloud Drive is a cloud storage service from Apple that allows users to store and access files, documents, and folders from any Apple device signed in with the same Apple ID, as well as from Windows devices via the iCloud for Windows app. Files stored in iCloud Drive are automatically synced across all devices, ensuring that the latest versions are available whether the user is on a Mac, iPhone, or iPad. Any changes made on one device are reflected across all others. iCloud Drive also supports folder sharing, allowing users to collaborate on documents and share files with others, making it easy to work together in real time. To enable iCloud Drive, users need to go to System Preferences, Apple ID, iCloud, and check the box for iCloud Drive. This ensures that files and folders are synced and stored in iCloud for easy access. iCloud Drive offers encrypted file storage, ensuring the security of users' data. However, users should monitor their iCloud storage to avoid running out of space, as larger files or extensive usage can quickly consume the available space. macOS offers a variety of trackpad gestures that enable users to navigate and interact with their system more efficiently, utilizing multi-touch inputs for tasks like scrolling, zooming, and switching between apps. Common gestures include 2-finger scrolling, pinch to zoom, 3-finger swipe for switching between full-screen apps, and 4-finger swipe for opening Mission Control to manage desktops and windows. Users can customize and view available gestures through System Preferences trackpad, where they can enable, disable, or adjust settings for specific gestures according to their preference. Using gestures increases efficiency and productivity, as users can quickly switch between tasks, navigate web pages, or manage apps with simple intuitive touch gestures, reducing reliance on the keyboard and mouse. Gestures are compatible with MacBook trackpads and external trackpads, offering a consistent and responsive experience across various macOS devices. Finder is the default file management application in macOS, allowing users to browse, organize, and access files, folders, and applications on their Mac. Finder provides a graphical interface for managing files and directories, including a sidebar for quick access and frequently used locations like documents, downloads, iCloud Drive, and applications. Finder includes a robust search feature that allows users to quickly find files, folders, and applications by typing keywords or using advanced filters based on file type, date, and more. The preview and quick look features in Finder enable users to view the contents of files, like images, PDFs, or documents, without opening them, providing a fast way to check file content. Finder allows users to drag and drop files between locations, organize items into folders, rename files, and manage permissions, making it an essential tool for file organization and system navigation. The dock in macOS is a convenient customizable toolbar located at the bottom or side of the screen, providing quick access to applications, files, and folders. The dock holds icons for frequently used applications, allowing users to launch programs with a single click. Users can also add or remove apps from the dock based on their preferences. The Stacks feature in the dock allows users to group files and folders, making it easier to access documents or directories without cluttering the screen. The dock can be customized in System Preferences to change its size, position, magnification effect, and even the appearance of the icons. The dock also functions as a place to minimize open windows. When a window is minimized, it is sent to the dock, providing easy access to restore it later. The Continuity feature in macOS allows seamless integration between Apple devices, enabling users to start a task on one device and continue it on another. One of the core features of Continuity, Handoff, allows users to start an activity on one device, like for example composing an email on an iPhone, and pick it up on another device, for example completing the email on their Mac, effortlessly. With Universal Clipboard, users can copy content such as text, images, or files on one Apple device and paste it on another, making it easier to work across devices. Instant Hotspot allows macOS devices to connect to the internet through an iPhone's cellular connection without needing to set up a separate hotspot, ensuring continuous internet access. The AirDrop feature enables users to wirelessly share files between Apple devices without needing an internet connection, allowing easy file transfer between a Mac, an iPhone, or iPad. Disk Utility is a built-in macOS application used for managing and maintaining storage devices such as hard drives, SSDs, and external drives. It allows users to format, partition, and repair disks. The First Aid feature in Disk Utility is used to check and repair file system errors, resolve disk-related issues, and ensure the integrity of the file system on macOS drives. Disk Utility enables users to format storage devices with macOS-compatible file systems such as APFS or HFS Plus and create partitions for better organization of data. Users can mount and unmount disks using Disk Utility, allowing for safe disconnection of external drives or accessing partitions and volumes without affecting other data. Disk Utility also provides the ability to encrypt drives with File Vault encryption, ensuring that sensitive data is protected and accessible only with the correct credentials. File Vault is macOS's built-in encryption feature that encrypts the entire hard drive, ensuring that all data stored on the disk is protected with strong encryption, making it unreadable without the correct password. File Vault uses XTS AES 128 encryption with a 256-bit key to protect data, ensuring robust security for users' files and sensitive information on the system. Users can enable File Vault in System Preferences, Security and Privacy, File Vault, where they're required to set a password and optionally create a recovery key to regain access in case the password is forgotten. While File Vault provides excellent security, there may be a slight impact on system performance due to the overhead of real-time encryption and decryption of data, particularly on older machines. If users forget their File Vault password, they can use their Apple ID or their recovery key to unlock the encrypted disk and regain access to the system. Terminal is a macOS application that provides a command line interface to interact with the system. It allows users to execute commands and perform tasks that may not be available through the graphical user interface. Terminal can be accessed through Applications, Utilities, Terminal, or by using Spotlight Search. It provides access to the Bash or ZSH shell, depending on the macOS version. Terminal enables users to run commands for file management, system configuration, network settings, and troubleshooting tasks. Common commands include ls or list directory contents, cd or change directory, and cp or copy files. Terminal allows for more advanced management of macOS, such as manipulating system settings, modifying permissions, installing software via package managers like Homebrew, and accessing hidden system files. Since Terminal allows users to directly manipulate system files and settings, it is important to be cautious when using commands, as improper commands can potentially damage the system or lead to data loss. The Force Quit feature in macOS allows users to close unresponsive applications or processes that are not responding to normal quit commands, ensuring that the system continues to function smoothly. Users can access Force Quit by pressing Command-Option-Escape or by selecting Apple menu, Force Quit. This opens a window listing all open applications, where users can select and forcefully terminate the problematic app. Force Quit is typically used when an application becomes frozen or stops responding, preventing further interaction and potentially causing system slowdowns or instability. While Force Quit is an effective tool, it can result in data loss if the application was in the middle of saving work or processing data. It's important to use this feature as a last resort. Before resorting to Force Quit, users can try to wait for the application to respond, use the activity monitor to identify the process, or restart the system if necessary. The ls command is one of the most commonly used commands in Linux for listing the contents of a directory. It provides users with an overview of the files and folders present in the specified directory. By typing ls in the terminal, users can display the names of files and directories in the current working directory. Additional options can modify the output, such as showing files or detailed file information. Key options for ls include -L for detailed listings with file permissions, ownership, and timestamps, -A to show hidden files, and -H to display human-readable file sizes. The ls command can sort files by name, modification time, size, or extension. Users can also control the output format, such as displaying files in columns or by grouping file types. ls is a fundamental tool for managing files and navigating directories, often used in conjunction with other file management commands like cd, cp, and rm. The pwd, or Print Working Directory command in Linux, displays the current directory path in which the user is working. It is an essential tool for navigating and confirming the directory context within the terminal. The pwd command returns the absolute path of the current directory starting from the root directory, ensuring users know exactly where they are in the file system. Unlike many Linux commands, pwd does not require any arguments to function. Simply typing pwd will output the full directory path. pwd is commonly used in conjunction with other commands, like cd or change directory, to track directory changes and ensure the user is working in the correct location. When working with symbolic links, pwd will display the path to the current directory as it appears in the file system, which may differ from the directory's physical location if the link is pointing to another location. The mv, or move command in Linux, is used to move files or directories from one location to another, or to rename files within the file system. To move a file, users simply specify the source file in the destination directory. For example, mvfile.txt, new path, moves file txt to the specified directory. The mv command can also be used to rename files. By specifying the same directory but a different file name, such as mv, old name text, new name text, the file is renamed without being moved. By default, if a file with the same name exists in the destination, mv will overwrite it without warning. Users can add the -I, or interactive option, to prompts before overwriting files. The mv command can be used with wildcards, for example star.txt, to move multiple files at once, providing flexibility in file management. The cp, or copy command in Linux, is used to copy files and directories from one location to another, allowing users to create duplicates of files without modifying the originals. To copy a file, the syntax is cp, source file, destination, where source file is the file to be copied, and destination is the location where the copy will be placed. To copy an entire directory and its contents, the -R, or recursive option, is used, as in cp-r source directory, destination directory, ensuring all files and all subdirectories are copied. The -P option preserves the file attributes such as modification time, ownership, and permissions while copying files, ensuring the copied file maintains the same properties as the original. The -I, or interactive option, prompts the user before overwriting an existing file at the destination, preventing accidental data loss. The rm or remove command in Linux is used to delete files and directories from the system, making it one of the most powerful file management tools for cleaning up unwanted files. To remove a file, the basic syntax is rm filename, which will permanently delete the specified file without sending it to trash or the recycle bin. To remove directories, the -r or recursive option is used, such as rm-r directory name, which deletes the directory and all its contents, including subdirectories. The -f or force option forces the deletion of files or directories, bypassing prompts for confirmation even if files are write protected. The rm command permanently deletes files without recovery options, so it's essential to use it carefully. The -i or interactive option can be used to confirm each deletion, reducing the risk of accidental data loss. The chmod or change mode command in Linux is used to modify the permissions of files and directories, allowing users to control who can read, write, or execute a file. Linux permissions are divided into read R, write W, and execute X, which can be applied to the owner, group, and others. Change mode allows users to assign these permissions using symbolic or numeric representations. In symbolic notation, users can add, plus, remove, minus, or set equal permissions. For example, change mode plus X file adds execute permissions to a file, and change mode U plus X file adds execute permissions to the owner. In numeric notation, permissions are represented by a 3-digit number. Each digit corresponds to a user class, owner, group, or others, and is a sum of the values for read, write, and execute, 4, 2, and 1. For example, change mode 755 file grants full permissions to the owner and read and execute permissions to others. The -r option allows users to apply changes recursively to directories and their contents. For example, change mode -r 755/directory changes the permissions of all files and subdirectories within the specified directory. The chown or change owner command in Linux is used to change the ownership of files and directories, allowing users to assign a new owner and/or group to a file or directory. The basic syntax for chown is chown, owner, group, filename, where owner is the new file owner, group is the new group, and filename is the file or directory to be modified. The -r or recursive option allows users to change the owner and group of an entire directory and its contents, making it easier to manage permissions across multiple files and subdirectories at once. Changing ownership with chown is important for managing file access and ensuring that only authorized users or groups have control over specific files, especially in multi-user environments. The chown command typically requires super user or root privileges to change ownership of files that are not owned by the user, making it an important tool for system administrators. The grep command in Linux is used to search for specific patterns or strings within files, making it an essential tool for finding text, logs, or configurations across large amounts of data. The basic syntax is grep, pattern, filename, where pattern is the text you are searching for, and filename is the file or files in which to search. grep supports regular expressions or regex, enabling complex search patterns for more advanced searches, such as matching multiple variations of a string or searching for case-insensitive text. Users can search through multiple files by specifying wildcard characters, for example, grep pattern star.txt to search all txt files in the directory. The -r or recursive option allows users to search through directories and subdirectories, while -i makes the search case insensitive, and -l lists only the file names that contain the pattern. The find command in Linux is used to search for files and directories based on specific criteria, such as name, size, modification date, or type, allowing users to efficiently locate files across the file system. The basic syntax is find, path, options, expression, where path is the directory to search in, options modifies the search behavior, and expression defines the search criteria such as file name or modification time. Common options include -name to search for files by name, -type to search by file type, for example, -f for files, -d for directories, and -mtime to find files modified within a certain number of days. The find command can execute actions on the files it locates using the -exec option, for example, find -name star.txt -exec rm deletes all text files found in the current directory and subdirectories. Find performs recursive searches by default, making it an ideal tool for locating files across entire directory structures without the need to specify subdirectories manually. The FSCK, or File System Consistency Check, command is used to check and repair errors in file systems on Linux. It ensures the integrity of file systems by identifying and fixing potential problems like corruption or inconsistencies. The basic syntax is FSCK options file system, where file system specifies the partition or disk check, such as dev SDA1 for a specific disk partition. The FSCK command can automatically attempt to fix detected issues using the -y option, which answers yes to any prompts for fixing problems during the scan. It's best practice to run FSCK on unmounted file systems, as checking a mounted file system can lead to data corruption. The command may require root privileges to repair the file system issues. Linux systems often schedule FSCK to run automatically during boot for file systems that were not cleanly unmounted or during disk checks at regular intervals, ensuring file system health. The mount command in Linux is used to attach a file system, such as disk, partition, or remote share, to a specific directory, making it accessible to the system and its users. The basic syntax for the mount command is mount device mount point, where device is the file system or partition to be mounted, and mount point is the directory where the file system will be attached. The mount command supports various types of file systems, including ext4, NTFS, and FAT32, and can be used to mount both local and network file systems, such as NFS or SMB CIFS. To automatically mount file systems during boot, users can add entries to the etc fstab file, ensuring devices are mounted without manual intervention. Once a file system is no longer needed, it can be safely removed using the umount command, ensuring that data is not lost and no files are being accessed during the dismount process. The su, or substitute user command in Linux, allows users to switch to another user account, typically the root user, in order to perform administrative tasks with elevated privileges. The basic syntax of su is su username, where username is the account to switch to. If no username is specified, the command defaults to the root user. By switching to the root user, system administrators can execute commands that require full system access, such as installing software, modifying system configurations, and managing user accounts. When using su to switch to the root user, users are prompted to enter the root password for authentication. For security, some systems may restrict access to root, requiring the use of sudo instead. The su command grants temporary administrative privileges during the session, and once the session is complete, the user can exit by typing exit to return to the original user account. The sudo, or superuserdo command in Linux, allows authorized users to execute commands with root privileges or as another user without needing to switch to the root account. The basic syntax of sudo is sudo command, where command is the command the user wants to run with elevated privileges. For example, sudo apt-get update updates the system packages with root permissions. Users granted sudo access via the etc sudoers file can execute administrative commands. The system administrator configures the level of access each user has, providing flexibility and security in a multi-user environment. When running a command with sudo, users are prompted to enter their user password, not the root password, for authentication, ensuring that only authorized users can perform administrative tasks. The sudo command grants temporary administrative access and automatically logs the use of privileged commands, providing an audit trail for security purposes. The apt, or Advanced Package Tool, is a command line tool used in Debian-based Linux distributions, such as Ubuntu, to manage packages or software applications and their dependencies. The apt install package name command allows users to download and install software packages from the system's configured repositories. For example, apt install vim installs the Vim text editor. To keep the system up to date, users can run apt update to refresh the package list and apt upgrade to install the latest versions of all installed packages. The apt remove package name command is used to uninstall software packages, and apt purge package name removes the package along with its configuration files, ensuring a cleaner system. The apt search package name command allows users to search for available packages in the repositories, making it easy to find and install new software. The DNF, or Dandified Yum, is the default package manager for Fedora and other Red Hat-based Linux distributions. It's used for installing, updating, and managing software packages from repositories. The DNF install package name command allows users to install software packages from the system's enabled repositories, such as DNF install Vim to install the Vim text editor. Users can update installed packages using the DNF update command, which checks for newer versions of installed software and applies the updates to the system. To uninstall software, users can use the DNF remove package name command, which removes the specified package and its dependencies that are no longer required. The DNF search package name command helps users search for packages, and the DNF info package name command provides detailed information about a package before installation. The IP command is a versatile tool in Linux for managing networking, including configuring network interfaces, routing, and tunnel devices, offering a more modern and comprehensive alternative to older tools like ifconfig. The command IPADDR displays detailed information about the system's network interfaces, including IP addresses, interface names, and link statuses, making it useful for network troubleshooting and configuration. With IP link, users can configure network interfaces by bringing them up or down, or modifying settings such as MTU, or maximum transmission unit, and interface state. The IP route command allows users to view or modify the system's routing table, including adding or removing routes and defining default gateways to control packet forwarding behavior. The IP command can also handle advanced networking tasks, such as managing IP addresses, setting up network namespaces, and configuring tunnels, making it a powerful tool for administrators. The ping command is used in Linux to test network connectivity by sending ICMP echo request packets to a specified host and measuring the response time, helping to diagnose network issues. The basic syntax of the ping command is ping, hostname or IP address, where the command sends ICMP packets to the target and displays the response time, allowing users to check if a network connection is active. By default, ping continues to send packets indefinitely until the user interrupts it. The -C option allows users to limit the number of packets sent. For example, ping -C 4 hostname to send 4 pings. The output of ping includes the round-trip time, or RTT, which measures the time taken for a packet to travel to the target and back, providing insight into the latency of the network connection. Ping is commonly used to troubleshoot network connectivity issues, identify packet loss, or assess network latency, making it a vital tool for network administrators. The curl, or client URL command in Linux, is used to transfer data from or to a server using various protocols such as HTTP, HTTPS, FTP, and more, making it a versatile tool for network troubleshooting and interaction with web services. The basic syntax of curl is curl, options, URL, where the user specifies the target URL and the desired action, for example, fetching web content or interacting with an API. Curl is often used to download web pages or files. For example, curl http example.com retrieves the content of the specified web page. The -D option allows users to send post requests with data to a web server, making curl useful for interacting with APIs and submitting forms. The -V, or verbose option, enables detailed output, which helps users troubleshoot connection issues by showing headers and the status of the request and response. The dig, or Domain Information Grouper command, is a network tool in Linux used for querying DNS, or domain name system records, to gather information about domain names, IP addresses, and DNS servers. The basic syntax of dig is dig, domain name, which queries the DNS for information about the specified domain. For example, dig example.com retrieves the DNS records for the domain example.com. Dig can query specific types of DNS records, such as A records, MX records, NS records, and text records by specifying the record type in the command, for example, dig example.com MX. Dig provides advanced options like +short to display concise output, +trace to follow the query path, and +stats for detailed query statistics, making it useful for troubleshooting DNS issues. Dig is a valuable tool for DNS troubleshooting as it provides detailed information about DNS resolution, including response times and error messages, helping network administrators diagnose connectivity issues. Traceroute is a network diagnostic tool used to track the route packets take from one system to another. It works by sending packets with progressively higher time to live or TTL values and recording the intermediate hops along the route. Commonly used to identify network delays and routing issues, providing insights into network performance. The Linux command for traceroute is traceroute, which requires installation on some distributions. Traceroute helps in visualizing the path, including the IP address of routers along the way, and diagnosing bottlenecks or failures. The man command is used to display the manual pages for various commands, functions, and system calls in Linux. The syntax is man command, where command is the name of the command you want help with. The manual pages are divided into sections like user commands, system calls, library functions, and more. You can scroll through the manual pages using arrow keys and search within them using / followed by the search term. Additional options like man-k or keyword allow for searching through the man pages for a specific term. The cat or concatenate command is used to display, concatenate, and create files in Linux. It's commonly used to quickly view the contents of one or more files in the terminal. The command can merge multiple files into one, either displaying them on the screen or saving the output to a new file. Cat can be used to create new files by redirecting the output to a file using the greater than sign. Useful options include -n to number the lines and -e to display end-of-line characters. The top command provides a dynamic real-time view of the system's resource usage, including CPU and memory usage. It lists the processes currently running, sorted by resource consumption, allowing users to identify which processes are consuming the most resources. The top command is interactive, allowing users to sort, filter, and send signals to processes directly from the interface. Commonly used by system administrators for monitoring system performance, especially during periods of high resource demand. Various options like -u to filter by user or -p to monitor specific processes provide customization. The ps command is used to display information about active processes on a Linux system. It provides details such as the process ID or PID, CPU usage, memory usage, and the command that launched the process. Common options include -e to show all processes, -f for a full format listing, and -u to filter by user. Unlike top, which offers real-time updates, ps provides a snapshot of processes at the moment the command is executed. Used alongside tools like grep to search for specific processes or by system administrators for debugging or monitoring purposes. The do or disk usage command is used to estimate and display the disk space used by files and directories. Common options include -h, human readable format, -s, summary of total disk usage, and -a, show usage for all files. It provides detailed information about the space usage of individual directories and their subdirectories. It helps system administrators identify large files or directories, assisting in disk cleanup and efficient storage management. While do provides valuable space usage information, running it on large file systems or directories can take time. The df command is used to display the available disk space on mounted file systems in Linux. It shows the total space, use space, available space, and the file system mount points. Common options include -h for human readable format and -t to display the type of each file system. It helps administrators and users quickly assess disk space usage across different partitions or storage devices. The command works for local and network file systems, offering a snapshot of their usage. Nano is a simple, user-friendly text editor for Linux, often used for editing configuration files and scripting. It provides a straightforward interface with basic text editing capabilities, making it ideal for beginners. The editor relies on keyboard shortcuts for actions like saving, Ctrl+O, cutting text, Ctrl+K, and pasting, Ctrl+U. Nano is fully keyboard-driven, offering a fast and efficient way to make text modifications without requiring a mouse. Frequently used by system administrators and users to modify files such as etc fstab or etc hosts. The etc password file stores essential user account information in Linux systems, including usernames, user IDs, group IDs, home directories, and login shells. Each line in the file represents a user account with fields separated by colons. The fields include the username, password placeholder, user ID, group ID, user description, home directory, and default shell. Historically, this file also stored encrypted passwords, but modern systems typically store password hashes in the etc shadow file for security reasons. While the etc password file is readable by all users, only the root user can modify it, ensuring system integrity. Administrators can use the etc password file to manage user accounts and configurations, including adding, modifying, or removing users. The etc shadow file stores secure user account information, specifically password hashes, account expiration details, and other password-related settings. Unlike etc password, which is readable by all users, etc shadow is only accessible by the root user and certain privileged programs, ensuring password security. It contains encrypted passwords, password aging information such as minimum and maximum password ages, and flags that control password expiration. Each line corresponds to a user with fields such as username, password hash, last password change date, and password expiration settings, all separated by colons. System administrators use etc shadow to manage user passwords securely, enforce password policies, and set expiration rules. The etc host file is used to map hostnames to IP addresses, allowing local name resolution without needing to query DNS servers. It contains a series of lines, each mapping an IP address to one or more hostnames, with each entry separated by spaces or tabs. It's primarily used for local network configurations, testing, and overriding DNS lookups for specific domains. System administrators use etc hosts for configuring static hostnames and IP addresses for local systems or network resources. It's commonly used to configure internal network settings, set aliases for commonly used hosts, or resolve domains during development. The etc fstab file defines how disk partitions, storage devices, and remote file systems are mounted into the file system. Each line contains information about a device, the mount point, file system type, mount options, and dump and FSCK options. It allows the system to automatically mount file systems during boot based on the configuration in this file. It includes parameters like read-write permissions, file system checks, and specific mounting behavior for different file systems. Administrators modify etc fstab to add new devices, change mount points, or adjust file system parameters for proper system operation. The etc resolve configuration file is used to configure DNS settings for name resolution on Linux systems. It specifies the DNS servers that the system should query for resolving domain names to IP addresses. The file can also include search domains, which help resolve partial domain names by appending the specified domains to incomplete host names. The file typically includes lines like name server, IP address to list DNS servers, and search domain to specify search domains. Administrators edit etc resolve configuration to configure or modify DNS settings for local network configurations or internet access. Systemd is the default system and service manager for many Linux distributions, responsible for booting the system, managing services, and handling system states. It replaces older init systems like sysv init, providing more efficient service management, parallelization of startup tasks, and dependency handling. Systemd uses unit files to define and manage services, mounts, sockets, and devices, allowing for easy configuration and control over system processes. It speeds up boot times by running multiple services in parallel and tracking dependencies, ensuring optimal performance. Administrators interact with systemd through commands like systemctl to start, stop, enable, disable, and check the status of services. The kernel is the core component of a Linux system that manages hardware resources, including memory, CPU, and device drivers. It provides the necessary interface between the hardware and user-level applications, ensuring smooth system operation. Linux supports monolithic kernels where most core system functions run in a single space, as well as modular kernels that can load and unload modules dynamically. The kernel can be customized for different hardware setups, optimizing performance and functionality based on the system's needs. System administrators manage the kernel through commands like uname to view kernel information and tools like modprobe for handling kernel modules. The bootloader is a critical component in the Linux boot process, responsible for loading the operating system into memory after the system is powered on. Common bootloaders for Linux include Grub, Grand Unified Bootloader, and Lilo or Linux Loader, with Grub being the most widely used. The bootloader allows users to select from multiple operating systems if a multi-boot configuration is set up, providing a menu at startup. Bootloaders are configured through configuration files, for example, etc, default, grub for grub, to control settings like boot parameters, timeouts, and default kernel selection. Modern bootloaders support features like kernel updates, secure boot, and recovery options, making system management more flexible. The root account is the highest level of user in a Linux system with unrestricted access to all files, processes, and system resources. It allows for administrative tasks such as installing software, changing system configurations, and managing user accounts. Because of its powerful privileges, the root account is typically used sparingly to reduce the risk of accidental or malicious system changes. Users can access the root account directly by logging in as root or temporarily using sudo to execute commands with root privileges. It's recommended to disable direct root login and use sudo for executing administrative commands to enhance system security. Moving on from Linux, 32-bit versus 64-bit dependent application requirements. The primary difference between 32-bit and 64-bit systems is the width of the processor's registers, affecting how much data can be processed simultaneously and how much memory can be addressed. 64-bit systems can address more memory than 32-bit systems, which are limited to 4 GB of RAM, making 64-bit ideal for memory-intensive applications. Theoretically, 64-bit systems can use up to 16 exabytes of memory. 32-bit applications can run on both 32-bit and 64-bit systems, but 64-bit applications can only run on 64-bit systems. Some 64-bit systems include a compatibility layer to run 32-bit applications. 64-bit applications can take advantage of larger registers and more memory, leading to better performance in tasks such as video editing, gaming, and scientific computations. 32-bit dependent applications require a 32-bit operating system, while 64-bit applications require a 64-bit operating system and compatible hardware, with 64-bit systems offering better scalability. A dedicated graphics card has its own memory, VRAM, and processing power, offering higher performance for tasks like gaming, video editing, and 3D rendering. Integrated graphics are built into the CPU or motherboard and share system memory, or RAM, making them more cost-effective but less powerful than dedicated graphics. Dedicated graphics cards are typically faster and more capable, providing smoother performance in graphically demanding applications, whereas integrated graphics are suitable for basic tasks like web browsing and office applications. Integrated graphics consume less power, making them ideal for laptops or budget systems, while dedicated cards consume more power, requiring better cooling solutions. Dedicated graphics cards can be upgraded or replaced, offering flexibility for users who need better performance over time, whereas integrated graphics are fixed and cannot be upgraded independently. VRAM, or Video Random Access Memory, is a specialized type of memory used by the graphics card to store images, textures, and video data for rendering graphics. The more VRAM a graphics card has, the better it can handle high-resolution textures, complex scenes, and multiple displays without performance degradation. For casual gaming and standard video editing, 4 GB of VRAM is typically sufficient, while 8 GB or more is recommended for modern gaming, 4K resolution, or professional video editing. VRAM is crucial for handling large high-resolution displays or multi-monitor setups where more memory is needed to store and render content smoothly. Insufficient VRAM can lead to slower performance, texture pop-ins, and stuttering, as the system will need to use the slower main system memory, or RAM, to compensate. RAM, or Random Access Memory, is used by the system to temporarily store data that is actively being used or processed, allowing for quick access by the CPU. For basic tasks like web browsing and office applications, 4 GB of RAM is typically sufficient, while 8 GB is recommended for most general-purpose computing needs. More RAM allows for better multitasking, faster application loading times, and smoother performance in memory-intensive tasks such as gaming, video editing, and virtual machines. For advanced tasks like video production, 3D rendering, or running multiple virtual machines, 16 GB or more of RAM may be required for optimal performance. The maximum RAM supported depends on the motherboard and the operating system, with 64-bit systems generally supporting larger amounts of RAM compared to 32-bit systems. The CPU, or Central Processing Unit, is the primary component responsible for executing instructions and performing calculations in a computer system. Modern CPUs often come with multiple cores, dual-core, quad-core, etc., which allow for better multitasking and faster processing of parallel tasks. More cores are beneficial for applications like video editing, 3D rendering, and gaming. The clock speed, measured in gigahertz, determines how quickly the CPU can process instructions. Higher clock speeds generally lead to better performance, especially in tasks that rely on single-threaded performance. CPU requirements depend on the motherboard socket type and chipset, as well as the operating system support for multi-core processing. Ensure compatibility when upgrading or building a system. Basic tasks like browsing and word processing can run on lower-end CPUs, while gaming, content creation, and virtual machines require high-performance CPUs, such as those with more cores and higher clock speeds. External hardware tokens are physical devices used to provide two-factor authentication, or 2FA, by generating time-sensitive one-time passcodes for secure login. Common types of hardware tokens include USB security keys, smart keys, and key fobs, each providing an additional layer of security beyond just passwords. These tokens generate or store authentication data that must be used in conjunction with a password to access sensitive systems, making unauthorized access more difficult. Hardware tokens are considered more secure than software-based 2FA methods, as they are less vulnerable to phishing attacks and malware. They're often used in environments requiring high security, such as corporate networks, banking, and government services, to protect against unauthorized access. Storage requirements depend on the amount of data that needs to be stored, including files, applications, and system data. Typical consumer systems may require between 250 GB to 1 TB, while more demanding tasks, for example video editing, gaming, or data analysis, may need 2 TB or more. The type of storage, hard disk drive, solid-state drive, or hybrid, impacts both speed and reliability. SSDs offer faster performance for boot times and file access, while HDDs provide more cost-effective, higher capacity options. For systems requiring fast data access, such as gaming or multimedia production, faster storage like SSDs or NVMe drives are recommended. For general computing tasks, a traditional HDD may suffice. For critical data, storage configurations like RAID, redundant array of independent disks, offer redundancy and data protection, ensuring that data is not lost in the event of a drive failure. Consider whether the system allows for future storage upgrades, such as additional internal or external drives, or supports cloud storage solutions for extended capacity. Applications are typically designed to run on specific operating systems, with compatibility depending on the OS architecture. Applications often have specific system requirements, such as minimum OS versions, memory, and processor type, which must be met for them to function properly. Some applications are designed to be cross-platform, meaning they can run on multiple operating systems, while others may require emulators or virtual machines to run on different platforms. Compatibility may vary depending on whether the OS is 32-bit or 64-bit, with some older applications only supporting 32-bit systems or requiring updates for 64-bit compatibility. OS updates or patches can sometimes cause compatibility issues with existing applications, requiring developers to release new versions or patches to address the changes in the operating system. Distribution via physical media such as CDs, DVDs, or USB drives involves transferring software or data using a tangible medium. It's commonly used when internet access is limited or for large-scale distribution. An ISO file is a digital replica of an optical disc, which can be mounted as a virtual drive without the need for physical media. ISO files are widely used for distributing operating systems, software, and tools over the internet. Physical media requires users to insert the disk or USB drive into the system, while ISO files are typically mounted on the system or burned to physical media for installation, offering more flexibility in handling and distribution. Physical media may require shipping or local storage, whereas ISO files can be easily shared, downloaded, and stored on various devices or cloud services, offering more portability and convenience. Physical media may incur costs for manufacturing, packaging, and shipping, while ISO file distribution is cost-effective, particularly for software vendors and accessible to users with reliable internet connections. Downloadable package files are used for distributing software or updates over the internet, allowing users to easily obtain and install applications or system components. Common types of downloadable packages include executable files, compressed archives, and package manager files, for example, deb for Debian-based systems or RPM for Red Hat-based systems. These distribution methods provide a convenient way for users to obtain software, as they only require an internet connection and a compatible device to download and install. It's crucial to ensure that downloadable packages come from trusted sources to avoid malware or malicious software. Secure connections like HTTPS and checksums can verify the integrity of the files. Many package files are designed to be easily updated, either through manual downloads or automated package management systems like apt for Linux or Windows Update, simplifying software maintenance. Image deployment involves distributing a complete system image which contains an operating system, applications, and configurations, allowing for quick installation on multiple systems. Common methods include network-based deployment, PXE or FTP, USB drives, or cloud-based solutions, depending on the scale and environment. Image deployment is highly efficient for deploying identical system setups across many devices, saving time compared to individual software installations. With centralized management, administrators can update the master image and deploy it across multiple systems, ensuring consistency and reducing setup time. Images must be secured and regularly updated to avoid vulnerabilities. Encryption and secure transport methods are recommended for protecting sensitive data during deployment. New applications can impact device performance by consuming significant resources such as CPU, RAM, and storage, potentially slowing down other processes. Ensuring that the new application is compatible with existing hardware and software is critical to avoid conflicts or crashes that can affect device functionality. For mobile devices, new applications that use intensive processes like location services or background tasks can drain battery life quickly, affecting overall usability. New applications may introduce security vulnerabilities, especially if they require excessive permissions or interact with sensitive data, requiring proper vetting before installation. Applications may require regular updates or patches, which could affect device maintenance schedules and compatibility with future operating system updates. New applications can consume significant network bandwidth, potentially slowing down other network traffic, especially if the application involves heavy data transfer, such as streaming or cloud-based services. Applications that rely on real-time communication, such as video conferencing or online gaming, can be sensitive to network latency, causing lag or disruptions in service quality. New applications may introduce security vulnerabilities to the network, especially if they require open ports or access to sensitive data. Proper network security protocols and firewalls should be in place to protect against threats. If many devices are running network-intensive applications simultaneously, it can lead to congestion and degraded performance across the network, affecting other users and services. Applications that require guaranteed bandwidth or low latency may require quality of service settings to prioritize traffic and ensure proper functioning, especially in a congested network environment. New applications may require substantial system resources such as CPU, memory, and storage, which can affect the performance of existing operations and tasks. Introducing a new application may require user training, which can impact operational efficiency in the short term as employees adapt to the new software. New applications often require ongoing support, updates, and troubleshooting, which can increase the workload for IT staff and affect overall system maintenance schedules. Compatibility with existing systems and workflows is essential. New applications may disrupt established processes or require modifications to current infrastructure. Depending on the application's function, there may be an impact on business continuity, especially if the application is mission critical. Downtime during installation or updates must be carefully planned to minimize disruption. New applications often come with licensing fees, installation costs, and potential hardware upgrades, which can impact the overall budget. It's important to evaluate the total cost of ownership, or TCO, over the long term. Well-implemented applications can lead to increased efficiency, automation, and improved productivity, directly benefiting the business by reducing manual tasks and streamlining workflows. The scalability of a new application is crucial for future business growth. Applications that can easily scale with the company's needs help avoid additional costs or disruptions as the business expands. The introduction of new applications may lead to system downtime during installation, configuration, or updates. Minimizing this downtime and ensuring smooth transitions is essential for maintaining business operations. New applications must meet regulatory compliance requirements and adhere to security best practices to prevent data breaches and legal issues that could harm the business reputation. Popular cloud-based email systems like Gmail, Microsoft 365, and Zoho offer flexible solutions for businesses and individuals, providing email hosting, calendars, and collaboration tools. When installing and configuring cloud-based email, users must configure IMAP or SMTP settings, security protocols, and ensure proper authentication methods. Setting up custom domains for business email accounts often requires configuring DNS records to ensure proper email delivery and prevent spam. Cloud-based email systems often integrate seamlessly with other cloud-based applications like file storage, project management tools, and video conferencing software, enhancing collaboration. Proper security measures, including encryption, backup strategies, and spam filtering, must be implemented to protect sensitive data and ensure email continuity. Cloud-based tools often include features for synchronizing folders across devices, ensuring that files are automatically updated and accessible on multiple platforms in real time. Many cloud services allow users to choose specific folders to sync, helping to save storage space by syncing only the necessary files and folders to a device. Sync settings can be configured to create backups of important data in the cloud, offering protection against local data loss and allowing for easy recovery. Cloud-based tools often include folder sharing capabilities, allowing users to share synchronized folders with colleagues, clients, or team members with customizable permissions for viewing or editing. When syncing files, conflicts may arise if changes are made to the same file on different devices. Cloud tools often provide settings to automatically resolve or alert users to conflicts for manual resolution. Popular cloud-based spreadsheet tools like Google Sheets and Microsoft Excel Online allow users to create, edit, and store spreadsheets directly in the cloud for easy access across multiple devices. These tools enable real-time collaboration, allowing multiple users to view and edit the same spreadsheet simultaneously, improving teamwork and productivity. Cloud spreadsheets offer granular access control settings, enabling users to set permissions for viewing, editing, or commenting on documents, ensuring data security and privacy. Cloud-based spreadsheets can integrate with other tools like cloud storage, Google Drive, OneDrive, and project management platforms, providing a seamless experience for managing data. Cloud spreadsheet tools typically feature automatic version tracking, allowing users to revert to previous versions of a document if necessary, providing an easy way to recover data. Popular cloud-based video conferencing platforms like Zoom, Microsoft Teams, and Google Meet enable users to conduct virtual meetings, webinars, and conferences over the internet. To use these tools, users must install the respective software or access web-based apps, configure audio and video settings, and ensure the system meets minimum hardware requirements. These tools often include features like screen sharing, file sharing, chat, and virtual whiteboards, enhancing collaboration and interaction during meetings. Cloud video conferencing platforms provide settings to manage meeting security, such as password protection, waiting rooms, and user authentication to prevent unauthorized access. Cloud video conferencing tools often integrate with calendar apps and email systems, allowing users to schedule and join meetings directly from their calendar invites or emails. Popular tools like Google Slides, Microsoft PowerPoint Online, and Prezi allow users to create, edit, and share presentations directly in the cloud, making them accessible from any device. These tools enable real-time collaboration, allowing multiple users to work on the same presentation simultaneously, improving teamwork and productivity. Cloud-based presentation tools often offer a variety of templates, themes, and customization options to enhance the design and visual appeal of presentations. These tools can integrate with cloud storage services like Google Drive or OneDrive, allowing for seamless access to presentation files for easy sharing across platforms. Users can set specific access permissions, such as view only, or edit access to control who can make changes or view the presentation, ensuring privacy and security. Popular word processing tools like Google Docs, Microsoft Word Online, and Zoho Writer allow users to create, edit, and store documents in the cloud, making them accessible from any device with an internet connection. These tools support real-time collaboration, enabling multiple users to edit the same document simultaneously, leave comments, and track changes, which is especially useful for teams and remote work. Cloud-based word processors offer a wide range of formatting options, templates, and style tools to enhance document presentation, making them suitable for business reports, essays, and other professional documents. Integration with cloud storage solutions like Google Drive or OneDrive ensures seamless access to documents and simplifies sharing, backup, and syncing across devices. Cloud word processors allow users to set permissions for document access, including view-only, comment, or edit permissions, providing secure collaboration options and ensuring sensitive information is protected. Popular tools like Slack, Microsoft Teams, and Google Chat provide cloud-based instant messaging, allowing teams to communicate in real time, regardless of location. Users can install messaging apps on multiple devices and configure them by linking their cloud accounts, setting up channels, and adjusting notification preferences. These platforms offer various collaboration features such as group chats, file sharing, video calls, and integrations with other cloud-based tools, enhancing communication and workflow. Cloud-based messaging tools implement security features like end-to-end encryption, multi-factor authentication, and access control to protect sensitive conversations and ensure privacy. Instant messaging apps sync across devices, allowing users to access conversations, search messages, and receive notifications on any platform, ensuring consistent communication. Identity synchronization ensures that user accounts and credentials are consistent across multiple cloud services, providing seamless access to various applications and systems. SSO, or single sign-on, allows users to log in once to gain access to multiple cloud-based tools and services, improving security and user experience by reducing the need for multiple passwords. Tools like Azure Active Directory or Google Identity can integrate with on-premise directory services such as Active Directory to synchronize user identities and access control across cloud and local environments. Identity synchronization enables automatic updates of user profiles, permissions, and roles across cloud platforms, simplifying user management and reducing administrative overhead. By synchronizing identities, organizations can enforce consistent security policies, such as multi-factor authentication and access controls, across all cloud applications, ensuring compliance with security standards. Licensing ensures that users have the appropriate permissions to access and use cloud-based software with specific terms and conditions based on the type of license purchased. Common licensing models include subscription-based licensing, either monthly or annually, perpetual licenses, which is a one-time purchase, and user-based or device-based licensing, each offering different levels of access and features. Administrators can assign and manage licenses through cloud platforms' admin consoles, ensuring that users have the correct licenses for the applications they need and preventing over or under deployment. Proper licensing helps organizations comply with software usage regulations and avoid legal issues or fines. Regular audits and tracking of license usage can help maintain compliance. As businesses grow, license assignments must be adjusted to accommodate more users or access to additional features. Cloud services often offer flexibility in scaling licenses to match organizational needs. Now we're on to Section 2, Security. Bollards are physical barriers designed to prevent unauthorized vehicle access and protect critical infrastructure or buildings from potential threats such as ram raids or terrorist attacks. Bollards come in various forms, including fixed, removable, and retractable. Each type serves different security needs depending on the area being protected. Bollards are often installed around high security zones, entrances, parking areas, and pedestrian walkways to control vehicle traffic and prevent access to vulnerable areas. Bollards can be made from materials like steel, concrete, or plastic, with reinforced versions offering greater resistance to impact and providing higher levels of security. Bollards can be integrated with other security systems such as surveillance cameras and access control points to enhance overall physical security. An access control vestibule, also known as a man-trap, is a small secure area designed to control and limit access to sensitive or high-security areas typically found in buildings or facilities. The vestibule typically has two sets of doors, where one door remains locked until the other is securely closed. This ensures that unauthorized individuals cannot enter the restricted area without proper identification or credentials. The vestibule serves as a buffer zone, preventing tailgating and ensuring that only one person enters at a time. Access control vestibules are often integrated with security systems such as biometric scanners, card readers, or keypads to verify the identity of individuals before granting access. These vestibules are commonly used in areas such as data centers, government buildings, and other locations that require high levels of security to protect sensitive information or assets. A badge reader is an electronic device used to authenticate access to secure areas by reading credentials embedded in physical badges such as RFID, magnetic stripe, or smart card technologies. Badge readers come in different forms, including proximity readers, which detect RFID badges from a distance, swipe card readers, which read magnetic stripe cards, and smart card readers, which require a chip-based card. Badge readers are commonly integrated with access control systems to ensure that only authorized individuals can gain entry to restricted areas based on their assigned credentials. Badge readers often work in conjunction with logging systems that track entry attempts, providing valuable data for security monitoring, auditing, and compliance purposes. Badge readers streamline access by offering quick, secure entry without the need for passwords, PINs, or physical keys, enhancing both security and operational efficiency. Video surveillance is used to monitor and record activities within or around a facility to deter unauthorized access, detect security breaches, and provide evidence in the event of an incident. Common types of video surveillance cameras include analog, IP or Internet Protocol, and PTZ or pan-tilt-zoom cameras, each offering different features such as resolution, remote access, and mobility. Video surveillance is often integrated with other security measures such as alarms, access control systems, and motion detection sensors to provide a comprehensive security solution. Video surveillance allows for both live monitoring and recorded footage, enabling security personnel to respond to incidents as they happen or review footage later for investigation. Modern video surveillance systems often offer remote access, allowing authorized users to view live or recorded footage from mobile devices or computers, enhancing the flexibility and responsiveness of security operations. Alarm systems are designed to detect unauthorized access or activity within a building or area and alert security personnel or law enforcement to prevent or respond to potential threats. Common alarm systems include intrusion alarms, fire alarms, and environmental alarms, each serving different security needs. Alarm systems are equipped with sensors such as motion detectors, door or window contacts, glass break detectors, and smoke detectors, which trigger the alarm when a breach or hazard is detected. Alarm systems can be integrated with video surveillance, access control, and monitoring services to provide a comprehensive security solution, ensuring a rapid response to incidents. Many modern alarm systems offer remote monitoring, allowing security systems to receive alerts via mobile devices or computers and respond in real time to potential threats. Motion sensors are used to detect movement within a designated area, triggering an alarm or alert to notify security personnel of potential intrusions or unauthorized activity. Common types include passive infrared sensors, ultrasonic sensors, and microwave sensors, each with different detection ranges and sensitivities. Passive infrared sensors detect changes in infrared radiation or heat, while ultrasonic and microwave sensors use sound waves or radio waves to detect movement by measuring reflected signals. Motion sensors are often integrated with alarm systems, video surveillance, and access control systems to provide a comprehensive security solution that can trigger alerts, capture footage, or lock doors automatically. Proper placement and sensitivity settings are critical to minimize false alarms while ensuring accurate detection with sensors commonly placed in entryways, hallways, or open spaces. Door locks are a fundamental component of physical security used to restrict access to buildings, rooms, or secure areas, ensuring that only authorized individuals can enter. Common types of door locks include mechanical locks, electronic locks, and smart locks, each offering different levels of security and convenience. Door locks are often integrated with access control systems to provide secure entry, enabling authorized personnel to unlock doors using keys, codes, or cards, while restricting access for unauthorized users. Door locks must comply with safety regulations that ensure easy exit in case of emergencies, such as panic bars or push-to-open mechanisms that allow people to exit quickly without hindrance. Modern door locks can be integrated with alarm systems, surveillance cameras, and motion sensors to create a comprehensive security system, allowing for real-time monitoring and alerts if unauthorized access attempts are detected. Equipment locks are designed to secure valuable or critical equipment, such as computers, servers, and other electronic devices, to prevent theft or unauthorized access. Common types include cable locks, lockable enclosures, and device-specific locks such as those used for laptops or desktop computers, which provide physical security against tampering or theft. Equipment locks are often portable, allowing devices to be secured in various locations, whether in an office, data center, or public spaces, providing flexible protection for mobile and stationary equipment. Some equipment locks integrate with access control systems, allowing for remote management of access or alerts if tampering is detected, increasing security for high-value devices. By securing equipment with visible locks, the likelihood of theft or unauthorized tampering is reduced, acting as a deterrent to would-be criminals or intruders. Security guards are responsible for maintaining the safety and security of a facility by monitoring premises, checking for unauthorized access, and responding to emergencies or security breaches. Guards often perform duties related to access control, such as verifying identification, issuing visitor passes, and ensuring only authorized personnel enter restricted areas. Security guards conduct regular patrols to deter criminal activity and monitor surveillance systems, ensuring that any suspicious behavior or incidents are quickly addressed. In the event of an emergency, security guards are trained to handle situations such as evacuations, medical emergencies, fires, and criminal activity until law enforcement or emergency responders arrive. The presence of security guards provides a visible deterrent to potential intruders or criminals, enhancing the overall security of the facility by making it less likely for unauthorized activities to occur. Fences are a physical barrier used to secure the perimeter of a property or facility, preventing unauthorized access and providing an initial line of defense against intruders. Common types of fences used in security include chain link fences, wrought iron fences, and security fences with barbed wire, each offering varying levels of strength, visibility, and deterrence. The height and durability of a fence are important considerations, as taller fences with reinforced materials are more difficult to climb or breach, providing better security. Fences are often integrated with other security measures such as motion sensors, surveillance cameras, and alarms to enhance detection and response capabilities. A well-maintained fence acts as a visible deterrent to trespassers, signaling that the property is protected and discouraging potential intruders from attempting to breach the perimeter. Key fobs are small electronic devices used to control access to secured areas by emitting a signal that is recognized by electronic locks or access control systems. Common types include RFID key fobs, Bluetooth-enabled fobs, and infrared fobs, each offering different methods of authentication and security. Key fobs are often integrated with access control systems to grant authorized individuals access to buildings, rooms, or other restricted areas based on the authentication signal from the fob. Key fobs often include encryption or rolling code technology to prevent unauthorized duplication or interception of the signal, enhancing the security of physical access points. Key fobs provide a convenient keyless entry solution, allowing for faster access while eliminating the need for traditional keys, and can easily be deactivated or reprogrammed if lost or compromised. Smart cards are secure, portable devices used to control access to physical spaces, containing embedded microchips that store encrypted data for authentication. Common types include contact smart cards, which require physical insertion into a reader, and contactless smart cards, which can be read by proximity without direct contact. Smart cards are integrated into electronic access control systems, allowing users to unlock doors or gain entry by simply swiping, inserting, or tapping their card on a reader. Smart cards offer enhanced security through encryption, multi-factor authentication, and the ability to store access rights, making them difficult to duplicate or counterfeit. In addition to physical access, smart cards can be used for other functions such as payment systems, employee identification, and time tracking, providing an all-in-one solution. A mobile digital key is a secure, smartphone-based solution that allows users to access physical spaces such as buildings or rooms via their mobile device instead of traditional keys or access cards. Mobile digital keys utilize technologies like Bluetooth, NFC, near-field communication, or QR codes to communicate with access control systems, enabling seamless entry without the need for physical contact. These digital keys are integrated with cloud-based access control systems, allowing administrators to grant or revoke access remotely and providing real-time tracking and monitoring of entries. Mobile digital keys offer enhanced security with encryption, biometric authentication like facial recognition or fingerprint scanning, and the ability to remotely deactivate lost or stolen devices. Mobile digital keys provide greater convenience by consolidating access credentials into one device, the smartphone, and they are easily managed through mobile apps or cloud platforms. Traditional keys are used to secure doors and entry points, providing physical access control by allowing only authorized individuals to unlock and enter specific areas. Common types include mechanical keys, standard metal keys, master keys, which open multiple locks, and electronic keys, which control access to electronically locked doors. Effective key management involves controlling the distribution, duplication, and return of keys, ensuring that lost or stolen keys do not compromise security. Keys are often paired with lock types such as pin tumbler locks, combination locks, or electronic locks, depending on the level of security required. It's essential to maintain backup keys and establish a clear protocol for key issuance and replacement to ensure continuous security in case of lost or compromised keys. A retina scanner is a biometric security device used to verify an individual's identity by analyzing the unique patterns of blood vessels in the retina located at the back of the eye. Retina scanning provides one of the most accurate forms of biometric authentication due to the distinct and permanent nature of retinal patterns, which are difficult to replicate or fake. Retina scanners are commonly integrated with physical access control systems to secure entry points to high-security areas, ensuring that only authorized personnel can gain access. Retina scanners offer enhanced security by providing a high level of accuracy and preventing unauthorized access even if someone possesses knowledge of a user's password or PIN. The scanning process is non-invasive, requiring only a brief moment for the scanner to capture the retina's pattern, and it typically involves little to no discomfort for the user. A fingerprint scanner is a biometric security device that verifies an individual's identity by analyzing the unique patterns of ridges and valleys in their fingerprints. Fingerprint scanners are widely used in various security systems, including mobile devices, door access systems, and computer logins due to their reliability and ease of use. Fingerprint scanning offers a high level of security as each person's fingerprint is unique, making it difficult for unauthorized individuals to replicate or fake. These scanners are often integrated with access control systems, allowing seamless, secure access to physical spaces, networks, and digital devices. The fingerprint scanning process is fast, non-invasive, and requires minimal user interaction, making it a convenient choice for both personal and organizational security. A palm print scanner is a biometric security device that analyzes the unique features of an individual's palm, such as ridges, lines, and vein patterns to verify identity. Palm print scanners offer high accuracy and reliability as the palm's features are unique to each individual and provide a more complex pattern than fingerprints alone. These scanners are often used in access control systems for both physical entry points and digital devices, enhancing security by ensuring that only authorized individuals can access restricted areas. The process of scanning a palm print is non-invasive, quick, and easy, as users only need to place their palm on a scanner for identification. Palm print recognition is difficult to replicate or fake, providing a strong level of security for high-risk or high-security environments. Facial recognition technology analyzes an individual's facial features to verify their identity using key markers such as the distance between the eyes, nose shape, and overall facial structure. This biometric method is non-invasive and does not require physical contact, allowing for quick and seamless identification in security systems. Facial recognition is commonly integrated with access control systems to secure buildings, devices, and networks, ensuring that only authorized individuals can gain entry or access sensitive information. Although facial recognition provides high accuracy, it also raises privacy concerns and challenges around data storage and potential misuse, making it important to ensure that security systems comply with regulations. Modern facial recognition systems are capable of real-time identification, enabling instant verification and enhancing security at entry points such as airports, offices, or smartphones. Voice recognition technology analyzes the unique characteristics of a person's voice, such as pitch, tone, and speech patterns to authenticate identity. It is used in secure access systems such as phone banking, smart devices, and voice-activated security systems, allowing users to perform tasks or access sensitive information using only their voice. Voice recognition is a non-invasive biometric method that enables hands-free authentication, making it convenient for users, especially in environments where physical contact is not ideal. While voice recognition provides a high level of security, its accuracy can be affected by factors such as background noise, voice changes due to illness, or potential spoofing with recorded voice samples. Voice recognition can be integrated with other biometric and security measures, such as multi-factor authentication, for enhanced protection, especially in sensitive or high-risk environments. Lighting plays a critical role in the effectiveness of biometric systems, particularly in facial recognition, iris scanning, and fingerprint scanning, where proper illumination is essential for accurate data capture. For facial and iris recognition systems, even lighting without harsh shadows or glare ensures that the biometric scanners can clearly capture the necessary features for identification. Poor or uneven lighting can lead to inaccurate readings, causing false positives or negatives, particularly in biometric systems that rely on fine detail, such as iris or fingerprint recognition. Lighting systems can be integrated with security measures, such as motion sensors or alarm systems, to improve the performance and reliability of biometric authentication in different lighting conditions. Ensuring adequate lighting in high-security areas can prevent attempts to bypass biometric systems or obscure data, enhancing the overall effectiveness of security measures. Magnetometers are devices used to detect and measure magnetic fields, and in biometrics they are utilized for identifying individuals based on the unique magnetic properties of their bodies or personal items. Magnetometers are commonly used in access control systems to detect concealed metallic objects or unauthorized items, providing an additional layer of security at entry points. In high-security environments, magnetometers can be integrated with other biometric systems, such as fingerprint or facial recognition, to enhance overall security by preventing unauthorized items from being brought into secured areas. Magnetometers can detect a variety of metallic objects such as weapons or electronic devices, which may not be visible through traditional security measures like X-rays or body scanners. While magnetometers are effective at detecting metal objects, they may not offer the same level of individual identification as other biometric methods like fingerprint or iris scanning. The principle of least privilege is a security concept that states users, systems, and applications should be granted the minimum level of access necessary to perform their tasks, reducing the potential of unauthorized actions or data breaches. By limiting access rights, principle of least privilege helps to minimize the risk of accidental or malicious damage, as users cannot perform actions beyond their necessary roles, such as accessing sensitive data or altering system configurations. Principle of least privilege can be implemented through role-based access control, where users are assigned specific roles with predefined permissions, ensuring that each role only has the required access to resources. Regular audits and monitoring are crucial in enforcing the principle, ensuring that access rights remain appropriate and that unnecessary privileges are removed or modified promptly. Principle of least privilege should be continuously adjusted based on the user's evolving role or needs, especially in dynamic environments where responsibilities or projects change frequently. The Zero Trust model is a security approach that assumes no one, whether inside or outside the network, can be trusted by default, and that verification is required for every request to access resources. Under the Zero Trust model, all users and devices must be authenticated, authorized, and continuously validated before gaining access to applications, data, or systems, regardless of their location. The Zero Trust model emphasizes the use of microsegmentation, which divides the network into smaller segments to limit access and minimize lateral movement of potential threats within the network. It's closely aligned with the principle of least privilege, ensuring that users and devices have only the minimum necessary access to perform their tasks. Zero Trust relies on continuous monitoring and real-time threat intelligence to detect and respond to suspicious activities, ensuring that security policies are constantly enforced. Access control lists are a set of rules used to manage permissions for users, devices, or applications, specifying which resources they can access and what actions they're allowed to perform. Access control lists can be implemented at various levels, such as network ACLs, controlling traffic through routers or firewalls, and file system ACLs, defining read, write, and execute permissions for files or directories. ACLs allow for detailed granular control over who can access specific resources and what type of operations they're permitted to execute. Access control lists are enforced by operating systems, network devices, and firewalls to restrict access based on defined security policies, ensuring that only authorized entities can perform specific actions. Proper management of access control lists enhances security by limiting access to sensitive data or network resources and providing an audit trail to monitor unauthorized access attempts. Multi-factor authentication adds an additional layer of security to email or other accounts by requiring more than one form of verification to access the account, reducing the risk of unauthorized access. In email systems, for example, multi-factor authentication typically involves something the user knows, like a password, and something the user has, such as a one-time passcode sent via SMS or authentication app. Email can be used as part of multi-factor authentication through verification codes sent to the registered email address, providing an extra layer of security during login or when changing account settings. Many email providers, including Gmail and Outlook, offer built-in multi-factor authentication features that integrate with third-party authentication apps or SMS services for enhanced security. By requiring an additional authentication factor beyond just the password, MFA helps protect email accounts from phishing attacks and unauthorized access due to stolen credentials. A hardware token is a physical device used in multi-factor authentication to generate a one-time passcode or cryptographic key to verify the user's identity. Common hardware tokens include USB devices, smart cards, and key fobs, which either display a time-based code or require insertion into a reader for authentication. Hardware tokens provide an additional layer of security by ensuring that the authentication factor is physically present with the user, making it difficult for attackers to impersonate the user without the physical token. Hardware tokens are widely used in high-security environments such as banking, government systems, and corporate networks where strong authentication is required to protect sensitive data. Since the hardware token is a physical device separate from the computer or mobile device, it's resistant to phishing attacks and key logging software that can capture passwords. An authenticator application is a software-based tool that generates time-based one-time passcodes or counter-based one-time passcodes for use in multi-factor authentication. The application, often installed on a smartphone, synchronizes with the user's account and generates a new password at regular intervals, for example every 30 seconds, which can be used in conjunction with a password to verify identity. Common authenticator applications include Google Authenticator, Microsoft Authenticator, and Authy, all of which are used for securing accounts across various online services and applications. Authenticator apps provide an added layer of protection against attacks like phishing and credential theft, as the codes are time-sensitive and cannot be reused after they expire. Unlike hardware tokens, authenticator apps do not require a physical device, making them a convenient and cost-effective MFA solution that works across multiple platforms and services. SMS, or Short Message Service, is a communication protocol used in multi-factor authentication to send one-time passcodes to a user's mobile phone for verification during the login process. After entering a password, the user receives a text message containing a time-sensitive code. This code must then be entered into the system to complete the authentication process. SMS-based MFA is easy to implement and widely accessible, as most users have mobile phones capable of receiving text messages, making it a convenient option for securing online accounts. While SMS provides an additional layer of security, it's vulnerable to attacks such as SIM swapping, interception, or phishing, which can compromise the effectiveness of MFA. SMS is commonly used for securing email accounts, online banking, and other services where strong authentication is needed, but where users may not have access to more advanced MFA options like hardware tokens or authenticator apps. Voice call authentication is a form of multi-factor authentication that involves receiving a phone call where the user is asked to verify their identity by entering a one-time passcode or verbally confirming information. After entering a username and password, the system initiates a voice call to the user's registered phone number. The user then either receives a passcode to enter or is prompted to confirm their identity through voice recognition. Voice call authentication is widely accessible as it only requires a phone number, making it a good option for users who may not have access to smartphone-based apps or internet services. While convenient, voice call authentication can be vulnerable to certain attacks, such as call forwarding or SIM swapping, which may compromise security. This method is often used for securing sensitive accounts like banking or email, especially when other MFA options like SMS or authentication apps are not feasible. A time-based one-time password is a security protocol used in multi-factor authentication that generates a unique time-sensitive passcode to verify the user's identity. TOTP generates a one-time passcode based on a shared secret and the current time, which changes at regular intervals, typically after every 30 seconds. The user must enter the correct passcode before it expires. TOTP enhances security by providing dynamic temporary passcodes that are difficult to intercept or reuse, making it more secure than static passwords or PINs. TOTP is commonly used with authenticator apps such as Google Authenticator or Authy, which generate the passcodes on the user's smartphone or other trusted devices. TOTP is resistant to phishing and man-in-the-middle attacks as the passcode is valid only for a short period and cannot be reused once expired. A one-time passcode is a temporary single-use code generated for authentication, typically used as a second factor in multi-factor authentication systems. The OTP is usually sent to the user via SMS, email, or an authentication app, and it must be entered within a limited time frame to successfully authenticate the user. OTPs provide an extra layer of protection by ensuring that even if a password is compromised, an attacker cannot access the system without the OTP, which is unique and time-sensitive. OTPs are commonly delivered through channels like SMS, email, or via apps like the Google Authenticator or Authy, which generate codes on the user's device. Because OTPs are used only once and expire quickly, they are highly effective at preventing replay attacks where intercepted credentials could be reused by an attacker. Security Assertions Markup Language, or SAML, is an XML-based framework used to exchange authentication and authorization data between identity providers and service providers, enabling single sign-on functionality. SAML allows users to authenticate once with an identity provider and then access multiple services or applications without needing to log in again, streamlining the user experience. SAML involves the exchange of security assertions, which contain the user's authentication information and attributes, between the identity provider and service provider to grant access. By centralizing authentication, SAML reduces the risk of password fatigue and the need for multiple credentials, improving security and reducing the potential for weak or reused passwords. SAML is commonly used in enterprise environments for integrating various cloud applications and internal systems with a centralized identity management solution. Single sign-on is an authentication process that allows users to access multiple applications and services with one set of login credentials, streamlining the user experience and reducing login fatigue. By reducing the number of times users need to enter passwords, SSO minimizes the chances of weak or reused passwords, improving overall security and reducing the risk of unauthorized access. SSO often works in conjunction with identity providers like Active Directory or third-party services such as Google or Okta to centralize user authentication and streamline access across multiple platforms. SSO enhances the user experience by reducing the need to remember and enter different credentials for each service, making it easier for users to access necessary applications quickly and securely. While SSO simplifies authentication, it creates a potential single point of failure. If the SSO system is compromised or unavailable, access to all linked services could be jeopardized. Privileged Access Management, or PAM, refers to the practice of managing and monitoring access to critical systems, applications, and data by users with elevated privileges, such as administrators or root users. PAM ensures that privileged accounts have the minimum access necessary to perform their tasks, enforcing the principle of least privilege and reducing the risk of unauthorized access or accidental system changes. PAM tools provide continuous monitoring and auditing of privileged account activity, creating logs of actions taken, which are essential for detecting and investigating potential security breaches. PAM solutions often include session management features allowing security teams to control and record privileged sessions, ensuring that administrative actions are traceable and accountable. PAM integrates with other security measures such as multi-factor authentication and identity and access management to enhance protection for sensitive resources. Mobile device management is a security strategy that allows organizations to manage and secure employees' mobile devices, ensuring they comply with security policies and preventing unauthorized access to corporate data. MDM tools enable administrators to configure mobile devices, enforce security settings such as password policies, encryption, and app management, and remotely wipe or lock devices if lost or stolen. MDM systems provide real-time monitoring of mobile device activity, including app usage, location tracking, and access to corporate resources, helping to detect and respond to potential security threats. MDM ensures secure access to corporate applications and data through technologies such as VPNs, secure email, and authentication methods like multi-factor authentication. MDM helps organizations comply with regulatory requirements and protects sensitive data by enforcing encryption, data backup, and secure communication protocols. Data loss prevention is a security strategy used to prevent the unauthorized access, leakage, or loss of sensitive data from an organization's network, devices, or systems. DLP can be implemented at various levels, including network DLP to monitor and control data in transit, endpoint DLP to protect data on devices, and storage DLP to safeguard data at rest. DLP systems enforce security policies by monitoring and blocking activities such as unauthorized file transfers, email attachments, or access to sensitive information based on predefined rules. DLP solutions provide real-time monitoring and alerting, allowing organizations to detect and respond to potential data breaches or policy violations as they occur. DLP helps organizations comply with regulatory standards such as GDPR or HIPAA by ensuring sensitive data is properly protected and reducing the risk of data exposure. Identity access management is a framework used to ensure that only authorized users can access specific resources, applications, or data within an organization's network, helping to maintain security and compliance. IAM systems manage user identities by implementing authentication methods such as passwords, biometrics, or multi-factor authentication, and defining user roles and permissions for resource access. IAM provides centralized control over user access across various systems, making it easier to manage and enforce security policies, monitor user activity, and audit access. IAM helps organizations comply with regulatory requirements like GDPR and HIPAA by ensuring that sensitive data is accessed only by authorized personnel and that access is properly documented and controlled. IAM systems are scalable and can integrate with other security measures such as single sign-on and multi-factor authentication to provide enhanced security and a seamless user experience. Directory services provide a centralized database to manage and store information about network resources such as users, devices, and permissions, facilitating secure access and efficient management. Popular directory services include Microsoft Active Directory, LDAP or Lightweight Directory Access Protocol, and Novell eDirectory, which help organizations manage authentication, authorization, and user credentials. Directory services are integrated with access control systems to authenticate users and authorize access to specific resources based on their roles and permissions within the directory. Directory services enable the organization of large-scale user and resource information in a hierarchical structure, which makes it easier to scale and manage permissions across an enterprise network. By centralizing user data, directory services ensure consistent enforcement of security policies and provide tools for auditing and monitoring user activity, helping organizations maintain regulatory compliance. Windows Defender Antivirus is a built-in security feature in Windows that provides real-time protection against malware, viruses, and other threats to the system. To activate Windows Defender, go to Windows Security in the Settings menu, then navigate to Virus and Threat Protection and ensure that real-time protection is turned on. Windows Defender can be temporarily deactivated through the same Settings menu, usually by disabling real-time protection. However, it's recommended to have another antivirus solution if you turn it off. In some cases, Windows Defender will automatically deactivate if a third-party antivirus program is installed, as it is designed to prevent conflicts between multiple antivirus tools. Deactivating Windows Defender leaves the system vulnerable to threats, and it's important to re-enable it or install another trusted antivirus program to maintain protection. Updating definitions in Windows Defender Antivirus ensures that the software has the latest information on known threats, allowing it to detect and block new malware, viruses, and other security risks. Windows Defender automatically updates its virus and threat definitions through Windows Update, ensuring that the antivirus is always equipped to handle the latest security threats. Users can manually update definitions by navigating to Windows Security, Virus and Threat Protection, Check for Updates, which is useful if automatic updates have been disabled or if there is a need for an immediate update. Keeping antivirus definitions up to date is crucial for maintaining system security, as malware developers frequently release new threats that can bypass older definitions. If Defender fails to update definitions, users can check the update settings, ensure they have an active internet connection, or use the Windows Update Troubleshooter to resolve any issues. The Windows Firewall is a built-in security feature that helps protect the computer from unauthorized network traffic by filtering inbound and outbound connections based on security rules. To activate the Windows Firewall, navigate to Windows Security, Firewall and Network Protection in the Settings menu, and ensure that Firewall is enabled for the active network profile, whether it's private, public, or domain. The firewall can be temporarily deactivated by toggling off the firewall setting for a specific network profile. However, it's generally not recommended to turn off the firewall unless necessary for troubleshooting or running specific applications. Deactivating the firewall exposes the system to potential security threats such as unauthorized access, malware, and network attacks. Always re-enable the firewall once troubleshooting is complete or an alternate solution is in place. While the firewall is on, users can configure exceptions for specific apps and services, allowing them to bypass the firewall for trusted programs without disabling it entirely. Firewall port security is a method for controlling and securing network ports on a system, restricting which ports can be used for incoming and outgoing network traffic, preventing unauthorized access and potential attacks. In Windows, port security is configured through the Windows Firewall settings, where users can create inbound and outbound rules for specific ports to control access to applications and services. By restricting access to specific ports, Firewall port security helps prevent unwanted or malicious traffic from entering or leaving the system, protecting against common network-based attacks such as port scanning or denial of service. Port security also allows trusted applications to communicate over designated ports, ensuring that necessary network traffic can still occur while maintaining tight security over others. Windows Firewall can log blocked connections and alert administrators to suspicious activities, providing insights into potential security threats related to unauthorized port usage. Firewall application security focuses on controlling and managing network traffic based on the applications or services requesting access, ensuring that only trusted applications can communicate through the firewall. Windows Firewall allows users to configure application-specific rules, enabling or blocking network access for individual applications based on their security profile and associated ports. By setting application-specific rules, Windows Firewall helps prevent malicious software from establishing unauthorized connections, protecting the system from malware, spyware, and other unwanted applications. Firewall application security provides detailed logs of which applications are attempting to access the network, allowing administrators to review and ensure only trusted applications are allowed to communicate. This feature provides granular control over inbound and outbound connections, allowing users to fine-tune security settings for each application, thereby minimizing potential attack vectors. Local accounts are user accounts created and stored directly on a specific computer, providing access to resources and settings for that machine only. They do not rely on cloud-based authentication and can be managed independently of the internet. Microsoft accounts are cloud-based accounts linked to Microsoft services like OneDrive, Outlook, and Windows Store. They allow users to access a wide range of services and sync settings across multiple devices. Both local and Microsoft account users can be assigned to user groups, which define the level of access and permissions they have on the system. Common groups include administrators, standard users, and guests. Local accounts are less vulnerable to online threats but lack the convenience of cloud synchronization and access to Microsoft services. Microsoft accounts, while more integrated with cloud services, pose greater risks if not properly secured with measures like multi-factor authentication. In Windows, administrators can configure account types and group memberships via the user accounts or local users and group settings to control user permissions, ensuring proper access levels and security policies. Standard user accounts are designed to provide basic access to the system while restricting administrative privileges. These accounts are typically used for everyday tasks like browsing the internet or using applications. Standard accounts have limited permissions and cannot make system-wide changes such as installing software, modifying system settings, or accessing other user accounts, ensuring that the system remains secure. Standard users can be assigned to groups such as the Users Group, which defines their permissions and access level on the system. Groups allow administrators to easily manage access controls and permissions for multiple users. By using standard accounts, organizations can reduce the risk of unauthorized changes or malware installation, as users with standard privileges cannot alter critical system configurations. If a standard user needs to perform tasks that require administrative access, they must request permission or enter credentials for an account with higher privileges, such as an administrator account, through user account control. Administrator accounts have full control over the system, allowing users to make system-wide changes, install software, manage other user accounts, and modify security settings. The Administrators Group includes all users with administrative privileges, enabling centralized management of permissions for users who need full access to system resources and settings. Administrator accounts can perform tasks that standard users cannot, such as managing system configurations, creating or deleting user accounts, and accessing all files on the system. Because administrator accounts have elevated privileges, they're a primary target for cyber attacks. It's crucial to secure these accounts with strong passwords and multi-factor authentication to prevent unauthorized access. Administrators can assign or remove users from the administrators group via the local users and groups setting or through the command line to ensure proper management of system access and security. Guest user accounts are designed to provide temporary or limited access to a computer or network for users who do not have a standard or administrative account, such as visitors or short-term users. Guest accounts typically have very limited permissions and can only access certain areas of the system, ensuring that they cannot make changes to system settings, install software, or access sensitive data. The guest group is a predefined user group in Windows that includes all guest accounts, providing a straightforward way to manage permissions and access for temporary users. While useful for providing access to visitors or temporary users, guest accounts can pose security risks if not properly managed. It's important to ensure that these accounts are disabled when not in use to prevent unauthorized access. Administrators can configure and manage guest user accounts through the local users and group settings, controlling access and ensuring the accounts are appropriately restricted to minimize security risks. Power user accounts are a type of user account in Windows that provides more privileges than a standard user, but fewer privileges than an administrator. This role is typically used for users who need access to system settings, but should not have full administrative control. Power users can install and configure certain software and make system changes, like adding printers or changing settings, but they cannot perform tasks like managing other user accounts or altering security settings. The Power Users Group is a predefined group in Windows, and users who are members of this group have additional permissions that allow them to perform more tasks than standard users while maintaining a layer of security. While power users have more control over the system than standard users, their access should be carefully managed to prevent misuse or accidental changes that could affect system security or stability. Administrators can assign or remove users from the Power Users Group through the local users and group settings, ensuring that only those who need additional privileges are given this level of access. Username and password login is the most common method of authentication in Windows, requiring users to enter a valid username and password combination to access the system. Windows provides the option to log in using either a local account stored on the computer or a Microsoft account which is cloud-based, with each offering different levels of integration with online services and security features. Administrators can configure password policies through group policy or local security policy to enforce strong passwords, including requirements for length, complexity, and expiration to enhance system security. To prevent brute force attacks, account lockout settings can be configured to temporarily lock the account after a certain number of failed login attempts, adding an additional level of protection. While not strictly a username and password method, Windows allows integration with multi-factor authentication to further secure login by requiring a second form of verification, such as a code sent to a mobile device. A personal identification number is an alternative authentication method that allows users to log into Windows using a short numeric code instead of a password, providing quicker access while maintaining security. The PIN can be used for logging into a local account or a Microsoft account. However, it's specifically tied to the device it's configured on, adding a layer of security by making the PIN valid only for that particular system. While a PIN is typically shorter than a password, it offers increased security by being device-specific and not transmitted over the network, unlike passwords. However, PINs should still follow guidelines for complexity to ensure they're secure. PIN login is often part of the Windows Hello feature, which also supports biometric authentication like facial recognition or fingerprint scanning, enhancing security and user convenience. Administrators can configure policies related to PIN login, such as limiting retry attempts after multiple failed logins, ensuring that brute force attacks are mitigated. Fingerprint login allows users to authenticate into Windows devices using their unique biometric data, such as a fingerprint, offering a fast and secure method of accessing their accounts without needing a password or PIN. Fingerprint login is part of the Windows Hello feature, which supports multiple biometric methods for authentication, including facial recognition and fingerprint scanning, to enhance both security and user convenience. To use fingerprint login, the device must have a compatible fingerprint scanner. Many modern laptops and desktop devices come with built-in fingerprint sensors, or external USB fingerprint readers can be used. Fingerprint login offers strong security by relying on unique physical features of the user, making it difficult for unauthorized individuals to bypass. Unlike PINs or passwords, fingerprints are not easily replicated or stolen. Fingerprint login can be set up through the Sign-in Options menu in the Settings app, where users can enroll their fingerprints and configure it as a primary or secondary authentication method. Facial recognition login allows users to authenticate their identity by scanning their face, providing a fast, convenient, and secure method of logging into a Windows device. Facial recognition is part of the Windows Hello feature, which supports multiple biometric authentication methods, including fingerprints and PINs, allowing users to securely sign in without entering a password. To use facial recognition, the device must have a compatible infrared camera or a 3D depth sensing camera, which ensures that the system can accurately capture and recognize facial features, even in low light conditions. Facial recognition adds a high level of security by using unique facial features that are difficult to replicate or steal, offering better protection than traditional passwords or PINs. Facial recognition can be set up through the Sign-in Options section in the Settings app, where users can enroll their facial data and configure Windows Hello for password-free sign-ins. Single sign-on logins enables users to authenticate once and gain access to multiple applications or services without needing to re-enter credentials, simplifying the login process and improving user productivity. In Windows, single sign-on can be configured through Microsoft accounts, allowing users to access not only their local system, but also various Microsoft services such as Office 365, OneDrive, and Outlook with a single login. Single sign-on is commonly integrated with Active Directory in enterprise environments, allowing seamless access to both internal and cloud-based applications for users in a corporate network. Single sign-on enhances security by reducing password fatigue, ensuring users only need to remember and manage one set of credentials, and minimizing the risk of weak or reused passwords across multiple applications. Single sign-on can be set up through Windows settings or group policy, and administrators can manage user settings and permissions across various applications and services centrally, improving security oversight. Windows 10 and 11 offer passwordless login options through Windows Hello, which allows users to authenticate using biometric methods such as facial recognition or fingerprint or a PIN, eliminating the need for traditional passwords. Windows Hello is a feature that enables secure login via facial recognition, fingerprint scanning, or PIN, providing a fast and user-friendly alternative to password-based login systems. Passwordless login methods such as Windows Hello enhance security by relying on unique biometric data or device-specific PINs, making it more difficult for attackers to compromise accounts through methods like phishing or brute force. For Windows Hello to function, devices need compatible hardware such as infrared camera for facial recognition or fingerprint scanner. Devices with TPM, Trusted Platform Module, can store biometric data securely. To configure passwordless and Windows Hello login, users can go to Settings, Accounts, Sign-in Options, and choose their preferred login method such as fingerprint, facial recognition, or PIN. New Technology File System Permissions control access to files and folders on local drives in Windows. These permissions can be set for individual users or groups, providing granular control over who can read, write, modify, or execute files. Share permissions control access to files and folders that are shared over a network. They're typically less granular than NTFS permissions and provide basic read, write, and full control options for shared resources. When both NTFS and share permissions are configured, the more restricted permission is applied. NTFS permissions take precedence over share permissions when accessing a shared folder locally, while share permissions are prioritized when accessed over a network. NTFS is ideal for controlling access to sensitive data on local drives, offering advanced options like auditing, encryption, and specific control over file-level permissions. Share permissions are primarily used for controlling access to shared folders over a network, ensuring that users from remote systems can access files with the appropriate level of control. Read-only, hidden, system, and archive are core NTFS attributes you can set on files and folders. They control visibility and basic handling. Compression can reduce disk usage for files and folders, but may add CPU overhead and isn't ideal for already compressed data like videos or zip files. Encryption can encrypt files and folders to protect data. Access is tied to the user's encryption certificate, so if you lose the key or certificate, you can lose access to the file. Attributes are not the same as NTFS security permissions or access control lists. Permissions actually control who can read, write, and modify. Effective permissions can be influenced by inheritance and share permissions over the network. The most restrictive permission typically wins when combining share and NTFS. In NTFS, inheritance allows child files and folders to automatically inherit permissions from their parent folders, simplifying permission management for large structures. This means that permissions set on a parent folder will be passed down to all contained files and subfolders unless inheritance is explicitly disabled. Share permissions do not have inheritance in the same way as NTFS. When files or folders are shared over the network, share permissions must be manually configured for each shared resource, and they apply only when the resources are accessed remotely. Administrators can configure inheritance in NTFS by selecting or deselecting allow inheritable permissions from this object's parent to propagate to this object. This helps ensure consistent security settings across a folder structure. Inheritance in NTFS can be beneficial for ensuring consistent permissions across a directory, but can also pose a risk if not properly managed, as inherited permissions might unintentionally grant excessive access. NTFS allows administrators to override inherited permissions at the file or folder level, providing flexibility in managing permissions for specific resources within a folder structure. Run as administrator grants elevated privileges to a user or application, allowing it to perform tasks that require administrative rights, such as modifying system settings or installing software. A standard user account has limited permissions and cannot make system-wide changes, install software, or modify critical system files, providing a more secure environment by preventing accidental or unauthorized changes. Running applications as an administrator increases the risk of security vulnerabilities because malicious software or unauthorized users can gain elevated access to the system. It's recommended to use standard user accounts for daily tasks and only elevate privileges when necessary. User account control prompts users to confirm actions that require administrative privileges. Even when using a standard user account, UAC ensures that any administrative task requires explicit approval or credentials from an authorized user. For improved security, it's best to use a standard user account for regular activities and only run programs as an administrator when necessary to minimize the risk of malware or unintended system changes. User account control is a security feature in Windows that helps prevent unauthorized changes to the operating system by prompting users for permission or an administrator password before performing tasks that require elevated privileges. When a task that requires administrative rights is initiated, UAC prompts the user with a notification asking for confirmation or credentials. This helps prevent malicious software from making unauthorized system changes without the user's knowledge. UAC has several notification levels ranging from always notifying the user of changes, which is the most secure, to never notifying, which is the least secure. The default setting is to notify when apps try to make changes, but not for Windows system changes. UAC helps limit the impact of malware by ensuring that elevated privileges are only granted with user consent, making it harder for malicious software to gain full system control without user intervention. UAC settings can be adjusted through the control panel or settings menu to fit the desired security level. However, lowering UAC notifications can make the system more vulnerable to attacks. BitLocker is a full disk encryption feature in Windows that protects data by encrypting the entire drive, making it inaccessible without proper authentication, such as a password, PIN, or hardware security module, or TPM, trusted platform module. BitLocker ensures that sensitive data on the system drive and other drives are protected, even if the device is lost or stolen, preventing unauthorized access to the encrypted data. BitLocker often works in conjunction with a trusted platform module, or TPM, a hardware component that securely stores encryption keys, making it more difficult for attackers to bypass encryption. BitLocker can be enabled and configured through the control panel or settings menu. The setup process may require configuring a PIN, password, or using a recovery key for recovery purposes. In case of failure to authenticate or forgotten credentials, BitLocker offers recovery options, including a recovery key stored on a USB drive or cloud account, allowing the user to regain access to the encrypted data. BitLocker To Go is a feature that allows users to encrypt removable drives, such as USB flash drives and external hard drives, to protect data in case the device is lost or stolen. By encrypting removable drives, BitLocker To Go ensures that sensitive information is protected with strong encryption, requiring a password, PIN, or smart card for access to the data. BitLocker To Go can be enabled from the control panel or settings by right-clicking on the removable drive and selecting Turn on BitLocker. Users are then prompted to choose a password or PIN to secure the drive. Once encrypted, the drive can be used on other Windows devices that support BitLocker, though it may require entering the password or PIN to access the data. BitLocker To Go helps secure portable storage devices, which are often at greater risk of being lost or stolen, ensuring that even if the device is accessed by unauthorized users, the data remains protected. The Encrypting File System, or EFS, is a feature in Windows that allows users to encrypt individual files and folders, ensuring that the data remains secure even if the physical device is accessed by unauthorized individuals. Unlike BitLocker, which encrypts the entire disk, EFS provides file-level encryption, allowing users to encrypt specific files or folders while leaving the rest of the system unaffected. EFS is integrated into the file system, making it easy for users to encrypt files directly from the Files Properties menu without the need for additional software or complex configurations. EFS uses a public key infrastructure, or PKI, to manage encryption keys. If a user loses access to their encryption key, they can use recovery keys to regain access to the encrypted files. EFS helps protect sensitive data from unauthorized access, but it requires careful management of encryption keys and passwords to prevent data loss or unauthorized decryption. Active Directory is a directory service used in Windows environments to manage and organize network resources such as user accounts, groups, and computers, providing centralized control over security and access to network resources. AD allows administrators to create, manage, and assign permissions to users and groups, simplifying the management of access to files, applications, and systems within the network. AD enables the enforcement of security policies such as password complexity requirements, account lockout settings, and group-based access controls, ensuring consistent security standards across the network. AD provides authentication and authorization services, ensuring that only authorized users and devices can access network resources by validating credentials and enforcing access rules. Active Directory integrates with other security systems, such as group policy, to apply security settings across all network devices and maintain centralized control over network security. Joining a domain allows a computer to be part of a centralized network controlled by a domain controller, enabling unified management of user accounts, security policies, and resources across multiple devices. The domain controller manages the domain, authenticates users, and enforces security policies across all devices connected to the domain, providing centralized authentication and access control. When a computer joins a domain, users can log in using domain credentials, and administrators can apply security policies, configure access to shared resources, and manage user permissions through Active Directory. Domain-joined devices automatically inherit security settings and group policies from the domain controller, ensuring consistent security configurations, such as password policies, account lockouts, and software installations. To join a domain, navigate to the System Properties in Windows Settings, select Change Settings under Computer Name, and enter the domain name and administrator credentials for authentication. Login scripts are automated tasks that run when a user logs into a Windows system, typically used to configure user environments, map network drives, or enforce security policies. Login scripts can be written in various scripting languages such as Bash, PowerShell, or VBScript, and can perform tasks like launching applications, setting environment variables, or configuring system settings. In a domain environment, login scripts are often assigned through group policy, where administrators define scripts to run for specific users or groups during login. Login scripts can be used to enforce security settings, such as mapping network drives with proper permissions or updating antivirus definitions. However, improper use of login scripts could lead to security vulnerabilities or system misconfigurations. Scripts can be assigned for individual users, groups, or computers, allowing for tailored configurations based on user roles, group memberships, or system requirements. Organizational units are containers in Active Directory used to organize and manage users, groups, and computers within a domain. They provide a way to apply group policies and delegate administrative tasks effectively. Moving objects such as user accounts, groups, or computers between organizational units allows administrators to better structure the directory, improve security management, and apply specific policies to different organizational groups or departments. When objects are moved to a new OU, any associated group policy objects that are linked to the target OU will apply to the moved objects. This ensures that security settings and configurations are automatically updated based on the new location. Moving objects between OUs can also be used to delegate control, allowing specific users or groups to manage only the objects within their assigned OU, providing a more secure and organized administrative structure. Moving an object into an OU with different policies may result in changes to the inheritance of security settings, as GPOs linked to the new OU could override or modify the policies applied to the object. Home folders are dedicated directories on a network or server assigned to individual users for storing personal files and data, often used in enterprise environments to ensure users have a secure centralized location for their documents. Home folders can be assigned through Active Directory by specifying the path to the folder for each user in their account settings, which can either be stored locally on a server or in a network share. Assigning home folders allows administrators to apply specific security settings, such as access permissions, to ensure that only the designated user and authorized personnel have access to their home directory, protecting sensitive information. In many environments, home folders are mapped to a network drive, allowing users to access their files easily from different computers within the organization. This process ensures centralized file management and accessibility across devices. Storing data in a home folder on a centralized server makes it easier to back up users' files, ensuring data protection and compliance with data retention policies. Group policy is a feature in Windows that allows administrators to centrally manage and configure settings for users and computers within an Active Directory environment, ensuring consistent security policies across the network. Group policies can be applied at various levels, including local group policy on a single machine, site, domain, or organizational unit levels, allowing for hierarchical management of security and configuration settings. Administrators can use group policy to enforce security settings such as password policies, account lockout policies, user right assignments, and software restrictions to ensure compliance with organizational security standards. Group policy objects are used to define and apply specific settings and can be linked to different organizational units or domains. Group policy objects can be used to deploy software, configure security settings, and manage user profiles. Group policy can be managed through the Group Policy Management Console, or the GPMC, where administrators can create, edit, and troubleshoot GPOs, ensuring that policies are correctly applied to users and computers across the network. Security groups are used in Windows to organize users and devices based on their roles and permissions, allowing administrators to apply consistent security policies and access control settings to multiple accounts at once. Windows provides different types of security groups, including domain local, global, and universal groups, each serving different purposes in terms of scope and the resources they can manage. By assigning users to specific security groups, administrators can control access to shared resources, assign user rights, and enforce security policies based on group membership rather than individual users. Security groups simplify the management of access control by enabling administrators to apply policies or grant access to resources based on group membership, ensuring a streamlined approach to user management. Properly selecting and organizing security groups helps ensure that users have the appropriate permissions while minimizing the risk of granting excessive privileges and maintaining a secure environment. Folder redirection allows administrators to redirect the location of certain user folders, such as documents, desktop, and app data, to a network location, ensuring that users' data is stored centrally for easier management and backup. Folder redirection is commonly configured using group policy in Windows, allowing administrators to apply settings across multiple computers and users in a domain, ensuring consistent file storage and access. By redirecting user folders to a central server or network location, administrators can ensure that important data is automatically backed up and easily recoverable in case of hardware failure or data loss. Folder redirection simplifies profile management by separating user data from local machine settings, which is particularly beneficial in environments where users log into different machines or use roaming profiles. Folder redirection helps secure sensitive data by storing it in a centrally controlled location with stricter access policies, but requires careful configuration to ensure proper access control and prevent unauthorized access to redirected folders. Wi-Fi Protected Access 2, or WPA2, is a security protocol designed to provide stronger data encryption and secure authentication for wireless networks, replacing the less secure WEP, or Wired Equivalent Privacy, and WPA, or Wi-Fi Protected Access protocols. WPA2 uses AES, Advanced Encryption Standard, for encrypting data, which offers stronger protection against data breaches compared to the older RC4 encryption used by WPA and WEP. WPA2 supports two types of authentication: WPA2 Personal with a pre-shared key or PSK for home networks, and WPA2 Enterprise, which integrates with Radius or Remote Authentication Dial-In User Service servers to provide robust authentication for larger business-level networks. WPA2 is considered highly secure and resistant to most common wireless attacks, such as eavesdropping and man-in-the-middle attacks, when configured properly with strong passwords or enterprise-level authentication. While WPA2 remains widely used, WPA3 is the latest Wi-Fi security protocol, offering improved encryption and security features, though WPA2 is still a common choice for many wireless networks. WPA3, or Wi-Fi Protected Access 3, is the latest wireless security protocol designed to offer enhanced protection over WPA2, addressing vulnerabilities and providing stronger encryption for modern wireless networks. WPA3 uses the more secure AES, or Advanced Encryption Standard, encryption, along with a stronger 192-bit security suite, providing improved protection against brute force attacks and unauthorized access. WPA3 introduces Simultaneous Authentication of Equals, or SAE, replacing the pre-shared key method used in WPA2 to provide more secure authentication for home networks, preventing offline dictionary attacks. WPA3 provides forward secrecy by ensuring that even if an encryption key is compromised in the future, past communications cannot be decrypted, offering stronger protection for stored data. For business networks, WPA3 Enterprise includes 192-bit encryption and is designed to meet the security needs of large organizations, providing robust protections against cyber attacks and unauthorized access. Temporal Key Integrity Protocol, or TKIP, is an encryption protocol used in Wi-Fi networks as part of the WPA, or Wi-Fi Protected Access Standard, to improve security over WEP, or Wired Equivalent Privacy. TKIP uses the RC4 encryption algorithm, but enhances it by generating a unique encryption key for each data packet, which helps protect against attacks like replay attacks and unauthorized decryption. While TKIP was an improvement over WEP, it's now considered less secure than more modern protocols like AES used in WPA2 and WPA3, as it's vulnerable to certain cryptographic weaknesses. TKIP was initially introduced with WPA to replace WEP and provide stronger encryption, but it was later replaced by AES encryption in WPA2, as AES offers better security and performance. With the introduction of WPA2 and WPA3, TKIP is largely deprecated and should not be used in modern networks as it does not meet current security standards and is vulnerable to attacks. Advanced Encryption Standard, or AES, is a symmetric encryption algorithm widely used in modern wireless security protocols such as WPA2 and WPA3 to provide robust encryption for protecting data transmitted over Wi-Fi networks. AES is known for its strong encryption and security, supporting key lengths of 128-bit, 192-bit, and 256-bit, making it significantly more secure than older encryption methods like WEP and TKIP. AES is the primary encryption method used in WPA2 and WPA3 protocols. WPA2 mandates AES for its encryption, while WPA3 strengthens the encryption further, providing a 192-bit security suite for enterprise-level networks. AES provides both strong security and good performance, making it suitable for a wide range of devices from home routers to enterprise-grade network equipment without significant performance degradation. AES is resistant to common attacks like brute force and cryptographic analysis, making it a secure choice for modern wireless networks, especially in high-risk or sensitive environments. Remote Authentication Dial-In User Service, or RADIUS, is a network protocol that provides centralized authentication, authorization, and accounting for users accessing network resources, particularly in wireless networks. Radius authentication verifies a user's credentials, such as username and password, when they attempt to access a network. The request is sent to a Radius server, which checks the credentials against a database and grants or denies access based on predefined policies. Radius is commonly used with WPA2 Enterprise and WPA3 Enterprise for stronger authentication in enterprise wireless networks. It works alongside 8021X to ensure that only authorized users can access the network. Radius provides strong security by centralizing authentication processes and supporting more robust methods like certificates and tokens. It's also highly scalable, making it suitable for large networks that require centralized user management. Unlike WPA2 Personal, which uses a shared password for authentication, WPA2 Enterprise with Radius allows for unique user credentials and supports more advanced security features such as per-user policies and integration with Active Directory. TACACS Plus, or Terminal Access Controller Access Control System Plus, is a network protocol that provides centralized authentication, authorization, and accounting services, or AAA services, primarily used for managing access to network devices like routers, switches, and firewalls. TACACS Plus separates the authentication, authorization, and accounting processes, allowing for more granular control over each aspect. It authenticates users, authorizes their access to specific network resources, and logs their actions for accounting purposes. TACACS Plus uses TCP, or Transmission Control Protocol, for reliable communication, provides stronger encryption for data transmission compared to Radius, and supports more detailed access control and policies, including device-specific configurations. While Radius is typically used for wireless authentication, TACACS Plus can be used in combination with 8021X for network device and administrative access, especially in environments where detailed control over user permissions and logging is needed. TACACS Plus provides greater security and flexibility than Radius, particularly in environments that require more detailed user control and logging, making it ideal for managing administrative access to critical network devices. Kerberos is a network authentication protocol that uses a trusted third-party service, the Key Distribution Center, or KDC, to authenticate users and devices securely over a network, commonly used in enterprise environments for both wired and wireless networks. Kerberos operates using tickets for authentication. A user first authenticates to the KDC, which provides a ticket granting ticket, or TGT. The user then presents the ticket granting ticket to request service-specific tickets for accessing resources, ensuring secure communication without transmitting passwords over the network. Kerberos uses symmetric key encryption to protect sensitive data and prevent unauthorized access. The protocol also supports mutual authentication, ensuring that both the client and the server are verified, reducing the risk of man-in-the-middle attacks. Kerberos is tightly integrated with Active Directory in Windows environments, providing seamless authentication for users and computers in a domain, making it a preferred method for securing network access in large organizations. Kerberos can be used with wireless security protocols, particularly in enterprise environments using WPA2 Enterprise or WPA3 Enterprise in combination with 802.1x for network access control, providing strong centralized authentication. Multi-factor authentication, or MFA, adds an extra layer of security by requiring users to provide 2 or more forms of verification to gain access to a system, making it more difficult for unauthorized users to breach accounts. MFA typically involves 3 factors: something the user knows, like a password or PIN, something the user has, like a security token or mobile device, and something the user is, biometric data like fingerprints or facial recognition. MFA can be integrated with wireless security protocols like WPA2 Enterprise and WPA3 Enterprise to enhance the authentication process for network access, ensuring that only authorized users can connect to the network. By combining multiple authentication factors, MFA reduces the risk of attacks such as phishing, credential stuffing, and password theft, which are common with single-factor authentication methods like passwords. MFA is increasingly adopted in enterprise environments, especially with VPNs, remote access, and wireless networks to safeguard sensitive data and comply with security standards and regulations. Trojan malware is a type of malicious software that disguises itself as a legitimate program or file to trick users into executing it. Once activated, it can steal sensitive data, damage systems, or provide backdoor access for cyber criminals. Trojan malware can be detected using antivirus software, which scans for known malicious signatures, or through behavioral analysis tools that monitor system activity for suspicious actions such as unusual file access or network traffic. To remove a Trojan, antivirus programs with real-time scanning capabilities are used to identify and quarantine or delete the malicious files. In some cases, specialized removal tools or manual intervention, such as booting into safe mode, may be required to fully remove persistent Trojans. Prevention of Trojan infections involves maintaining up-to-date antivirus software, using firewalls, and avoiding suspicious downloads, email attachments, and untrusted websites. Regular patching of software vulnerabilities also reduces the chances of Trojans exploiting system weaknesses. To prevent Trojan infections, users should employ a combination of security practices, including cautious browsing, email filtering, the use of strong passwords, and enabling multi-factor authentication for sensitive accounts. A rootkit is a type of malicious software designed to hide its presence on a system, allowing unauthorized access and control over a computer without being detected by traditional security tools. Rootkits can be detected using specialized security software that scans for hidden processes, files, or system modifications that are not visible to standard antivirus programs. Techniques like behavioral analysis, kernel-level monitoring, and rootkit detection tools can identify suspicious activity indicative of a rootkit infection. Removing a rootkit often requires the use of advanced removal tools, such as rootkit scanners or malware-specific tools, which can identify and delete hidden files or processes. In some cases, a clean system restore or complete reinstallation of the operating system may be necessary for thorough removal. To prevent rootkit infections, users should keep their operating systems and software up to date with the latest security patches, use a reputable antivirus program with real-time protection, and avoid downloading untrusted files or visiting suspicious websites. Regular system scans, use of security suites with anti-rootkit functionality, and monitoring for unusual system behavior, such as unexplained slowdowns or network activity, are essential for identifying and preventing rootkits before they can cause harm. A virus is a type of malware that attaches itself to a legitimate program or file and spreads to other files or systems when executed, often causing damage to files, software, or hardware. Antivirus software plays a key role in detecting viruses by scanning files for known virus signatures or unusual behavior. Heuristic analysis is also used to identify new or unknown viruses by analyzing their actions or structure. To remove a virus, users should run antivirus software to isolate and delete infected files. In some cases, specialized virus removal tools or boot time scanning may be necessary if the virus is deeply embedded or preventing the antivirus from functioning properly. Virus prevention includes maintaining updated antivirus software, using firewalls, avoiding suspicious email attachments and websites, and regularly backing up data to avoid losing information in case of infection. Educating users about safe browsing habits, not downloading untrusted files, and employing secure methods for email and file sharing can further reduce the risk of virus infections. Spyware is malicious software designed to secretly collect information about a user's activities such as browsing habits, personal details, or login credentials without their consent. Spyware can be detected using specialized anti-spyware software, which scans the system for suspicious activities and known spyware signatures. Behavior-based analysis can also identify spyware by monitoring unusual system behavior, like excessive network traffic or unauthorized data collection. Anti-spyware tools such as Malwarebytes or Windows Defender are effective in detecting and removing spyware from the system. In some cases, running a full system scan in safe mode may be necessary to remove persistent spyware. Preventing spyware infections involves using reputable anti-spyware software, avoiding suspicious downloads, and being cautious about clicking on unknown links or email attachments. Keeping software up to date and using strong passwords also help prevent unauthorized access. Regularly updating the operating system and installed software, using a firewall, and educating users on the risks of spyware help reduce exposure. Additionally, reviewing system settings and network traffic for unusual patterns can identify potential spyware infections early. Ransomware is a type of malicious software that encrypts a user's files or locks them out of their system, demanding payment or ransom in exchange for restoring access to the data or system. Ransomware can be detected by antivirus software with real-time protection, which scans for known ransomware signatures or unusual file encryption activities. Behavioral detection methods can also identify ransomware by monitoring system activity for signs of file changes or suspicious processes. To remove ransomware, users should use specialized ransomware removal tools or antivirus software to isolate and remove the infected files. In some cases, decrypting files may require a specific decryption tool provided by the security vendor or authorities. Prevention involves using updated antivirus software, regularly backing up important data, avoiding suspicious email attachments and links, and ensuring that systems are patched with the latest security updates. Enabling firewalls, using multi-factor authentication, educating users on safe browsing habits, and implementing network segmentation are also important strategies for preventing ransomware infections. A keylogger is a type of malicious software or hardware device that records every keystroke a user makes, often without their knowledge, to capture sensitive information such as passwords, personal data, or credit card numbers. Keyloggers can be detected using specialized anti-malware tools which scan for known keylogging software signatures or suspicious activity. Monitoring system behavior for unusual file activity or excessive network traffic can also help identify keylogger infections. To remove a keylogger, users can run a full system scan with updated antivirus or anti-malware software. In some cases, a manual inspection of system files and processes may be required, especially if the keylogger is well hidden. Preventing keyloggers involves using reputable antivirus software, enabling firewalls, avoiding suspicious email attachments or software downloads, and using virtual keyboards or multi-factor authentication for sensitive transactions. Regularly updating software, educating users on phishing risks, and using strong passwords are additional ways to minimize the risk of keylogger infections. It's also important to secure physical devices to prevent hardware keyloggers from being installed. A boot sector virus is a type of malware that infects the master boot record or boot sector of a computer's hard drive, making it active as the system starts up, often before the operating system loads. Boot sector viruses are detected using specialized antivirus software capable of scanning the boot sector and MBR for known malware signatures. Tools like Windows Defender offline and bootable antivirus scanners can help detect infections even when the operating system is not running. Removing a boot sector virus typically requires booting from an external device, such as USB drive or CD, to run antivirus software or a system repair tool. In severe cases, a clean installation of the operating system may be necessary to fully remove the virus. Preventing boot sector viruses includes keeping antivirus software up to date, using secure boot features, and avoiding booting from untrusted external devices or media. Disabling the boot from external media in the BIOS or UEFI settings can also reduce the risk of infection. Regular system backups, enabling secure boot options, and ensuring that antivirus protection is active during startup can provide effective prevention against boot sector viruses. A crypto miner is a type of malware that hijacks system resources to mine cryptocurrency without the user's knowledge, often resulting in performance degradation, overheating, and excessive power consumption. Crypto miners can be detected using antivirus and anti-malware software that scans for suspicious processes or unusual CPU or GPU usage. Monitoring tools that track system performance, like Task Manager or specialized software, can also help identify mining activities based on the resource usage patterns. To remove a crypto miner, users can run a full system scan with updated antivirus or anti-malware software. In some cases, manual removal might be necessary if the miner is deeply integrated into the system or disguises itself under legitimate processes. Preventing crypto miner infections involves keeping antivirus software up to date, avoiding suspicious downloads or email attachments, and being cautious with browser extensions or unverified software. Enabling browser security settings and using ad blockers can also reduce exposure to mining scripts. Regular system updates, strong password management, and ensuring proper firewall configurations help prevent unauthorized mining activities. Additionally, disabling unnecessary services or applications can reduce the attack surface for crypto miner infections. Stalkerware is a type of spyware that secretly monitors and tracks a user's activities, often without their consent, and is typically used to monitor intimate or personal behavior, such as location, communications, and browsing history. Detecting stalkerware often involves using specialized anti-spyware tools or mobile security apps that scan for unauthorized tracking software. System monitoring tools also help identify unusual battery drainage, excessive data usage, or hidden apps that may indicate stalkerware presence. Removal of stalkerware can typically be accomplished using anti-spyware or antivirus software that specifically targets mobile spyware or through factory resets on mobile devices. In some cases, users may need to uninstall suspicious apps manually or reset device settings to clear malware. Preventing stalkerware infections involves being cautious about installing apps from untrusted sources, regularly reviewing app permissions, and enabling security features such as two-factor authentication on sensitive accounts. Using app locks or security software to protect personal data is also an effective deterrent. Keeping devices up to date with the latest security patches, avoiding jailbreaking or rooting devices, and ensuring only trusted apps are installed can significantly reduce the risk of stalkerware infections. Regular audits of device settings and app permissions can also help identify potential security threats. Fileless malware is a type of malicious software that operates without leaving traditional files on the system, often residing in system memory or exploiting legitimate tools and processes to carry out attacks, making it harder to detect using conventional antivirus methods. Detecting fileless malware requires behavioral-based detection techniques such as monitoring suspicious activity in system memory, registry changes, and unusual command line executions. Endpoint detection and response tools and advanced threat hunting software are crucial in identifying fileless attacks. Removing fileless malware often involves using specialized tools that can perform memory scans and analyze system processes for signs of compromise. In some cases, system restoration or reinstallation of the operating system may be necessary if the malware has gained persistent access. Prevention includes keeping all software and systems updated, using application whitelisting to block unapproved applications, and implementing strict user privilege controls to limit access to critical system functions. Using behavior-based security solutions that can detect anomalous behavior is also effective at preventing fileless attacks. Regularly backing up important data, employing multi-layered security solutions, and educating users on safe computing practices such as avoiding phishing and suspicious links help reduce the risk of fileless malware infections. PUP, or potentially unwanted programs, adware includes software that generates unwanted ads, slows down system performance, and can lead to security vulnerabilities. Antivirus and anti-malware tools such as Malwarebytes and Windows Defender can be utilized to detect adware and potentially unwanted programs. Manual removal through the system settings or uninstalling programs can be done alongside using specialized adware removal tools for deep cleaning. You can prevent installation by disabling unwanted third-party software during software installations and using browser extensions to block pop-ups and ads. Users can be educated on recognizing suspicious downloads and enabling real-time protection to block adware. The recovery console provides command line access to troubleshoot and repair a system typically used when Windows fails to boot normally. The recovery console includes modes like Repair Mode, which allows users to access critical system files and repair them, and Safe Mode, which boots Windows with minimal drivers and services. In Recovery Console, you can use commands like check disk for disk error detection and SFC scan now to scan for corrupted system files. Malware and unwanted software can be removed using the del or delete command, or by accessing the system registry with the regedit command. Use the Recovery Console to enable System Restore, manage startup settings, and disable harmful system modifications, reducing the risk of future issues. Endpoint detection and response refers to a set of security tools designed to monitor, detect, and respond to suspicious activities on endpoints such as computers and mobile devices. EDR solutions use real-time monitoring, behavioral analysis, and threat intelligence to detect potential security threats, including malware, ransomware, and advanced persistent threats. EDR platforms provide automated threat removal features such as quarantining malicious files, killing malicious processes, and rolling back harmful changes made by threats. Prevention involves continuous endpoint monitoring, enforcing security policies, and using machine learning to predict and block emerging threats before they execute. EDR systems integrate with security information and event management solutions for centralized logging and incident response, enabling quick and coordinated security actions. Managed Detection and Response, or MDR, is a cybersecurity service that provides continuous monitoring, detection, and response to security threats, often managed by external security experts. MDR services use advanced threat intelligence, behavioral analysis, and endpoint monitoring tools to detect signs of cyber attacks, including malware, ransomware, and network intrusions. MDR services actively respond to detected threats by isolating affected systems, blocking malicious traffic, and performing remediation actions to remove the threat. MDR providers implement proactive security measures such as vulnerability assessments, security policy enforcement, and the application of patches to reduce the risk of future breaches. MDR integrates with existing security infrastructure, often working in tandem with SIEM, EDR, and firewall solutions to enhance threat visibility and accelerate response times. Extended Detection and Response, or XDR, is an integrated cybersecurity solution that provides advanced threat detection, investigation, and response across multiple layers of an organization's IT environment, including endpoints, networks, servers, and cloud services. XDR utilizes a combination of machine learning, behavioral analytics, and threat intelligence to identify suspicious activities and potential security breaches across diverse systems and platforms. XDR platforms offer automated remediation capabilities, such as isolating affected systems, terminating malicious processes, and removing malware from compromised endpoints or networks. By correlating data from multiple sources, XDR solutions help prevent attacks by identifying vulnerabilities, enforcing security policies, and using proactive threat hunting to block emerging threats before they cause damage. XDR enables a unified security approach by centralizing detection, response, and remediation, providing security teams with an integrated dashboard for efficient threat management and incident resolution. Antivirus software is designed to detect, prevent, and remove malicious software or malware such as viruses, worms, trojans, and other harmful programs from computers and networks. Antivirus programs use signature-based detection, heuristic analysis, and behavior monitoring to identify known and unknown malware threats on endpoints and networks. Upon detecting a virus or malware, antivirus software can quarantine the infected files, delete them, or attempt to repair the affected system by restoring files to a clean state. Antivirus solutions continually scan files and processes, monitor real-time traffic, and block potentially harmful activities to prevent infections before they can spread. Frequent updates are essential to ensure the antivirus software can detect the latest threats, including new viruses, zero-day exploits, and ransomware. Much like antivirus software, anti-malware software is designed to detect, prevent, and remove malicious software or malware such as viruses, spyware, ransomware, and trojans from systems and networks. Anti-malware tools utilize a combination of signature-based detection, heuristic analysis, and real-time behavior monitoring to identify both known and unknown threats. Once malware is detected, anti-malware software can isolate the malicious files, quarantine them, or completely remove them to restore system integrity. Anti-malware solutions provide continuous monitoring, scanning, and real-time protection to prevent infections, block malicious downloads, and detect suspicious behavior before it can cause harm. Modern anti-malware software often integrates multiple layers of defense, including web filtering, email scanning, and device protection to offer holistic security. An email security gateway is a solution designed to filter, monitor, and protect email communication from malicious threats such as spam, phishing attacks, and malware. The gateway uses advanced filtering techniques, including pattern recognition, heuristic analysis, and reputation-based scoring to identify and block malicious emails before they reach the inbox. Once a threat is detected, the email security gateway can quarantine or delete harmful messages, preventing them from reaching end users and reducing the risk of a security breach. Email security gateways prevent threats by scanning incoming and outgoing emails for malicious attachments, links, or suspicious content, and enforcing policies like DMARC, Domain-Based Message Authentication Reporting and Conformance. These gateways often integrate with other security measures such as anti-malware and endpoint protection to offer multi-layered defense against email-based attacks. A software firewall is a program installed on a computer or device that monitors and controls incoming and outgoing network traffic based on predetermined security rules. Software firewalls detect unauthorized access attempts, suspicious traffic, and potential threats by analyzing network packets and comparing them against security policies. While firewalls typically do not remove threats, they can block harmful network traffic, preventing malware from reaching the system or stopping malicious communication attempts. Software firewalls prevent attacks by filtering out malicious traffic, blocking suspicious ports, and enforcing rules that prevent unauthorized applications from accessing the network. Users can configure software firewalls to suit their needs, setting rules for specific applications, services, and IP addresses to enhance security based on individual preferences. User education is a key strategy in preventing security breaches by teaching individuals how to recognize, avoid, and respond to common threats such as phishing, malware, and social engineering attacks. Through training, users are taught to recognize suspicious emails, unfamiliar attachments, and unsafe websites, which helps in early detection of potential threats. Educated users are less likely to fall for phishing schemes or unknowingly download malicious software, reducing the chances of an attack on the network or system. Security awareness programs, simulated phishing attacks, and interactive training sessions can be used to teach users about identifying threats and safe online practices. Ongoing education, including regular updates on emerging threats, helps users stay informed and prepared for new tactics used by attackers. Anti-phishing training educates users on recognizing phishing attempts, which are fraudulent attempts to steal sensitive information, often via deceptive emails, websites, or phone calls. Users are trained to identify common signs of phishing, such as suspicious email addresses, poor grammar, and unexpected attachments or links that appear unsafe. Anti-phishing training encourages users to verify the legitimacy of suspicious emails or messages, avoid clicking on links, and report phishing attempts to IT departments. Tools such as simulated phishing campaigns, interactive tutorials, and regular reminders help reinforce learning and test users' ability to recognize phishing attacks. Continuing education is important to keep users aware of evolving phishing tactics, such as spear phishing and whaling, which target specific individuals or organizations. Operating system reinstallation involves wiping the current operating system and reinstalling a fresh copy to fix major system issues, remove persistent malware, or restore system performance. Before reinstallation, tools like antivirus scans and disk cleanup utilities can be used to identify malware or unwanted files that may have contributed to system instability. Operating system reinstallation removes all files, including malicious software, system errors, and corrupt settings, effectively restoring the system to its original state. Reinstallation can be paired with a clean backup strategy where important files are securely backed up and restored to avoid reintroducing issues after the operating system is reinstalled. The process typically involves using bootable media, USB or DVD, running the installation process, and reconfiguring the system with proper drives and software, ensuring a clean slate. Vishing, or voice phishing, is a type of social engineering attack where attackers use phone calls or voice messages to deceive victims into disclosing personal information or performing actions that benefit the attacker. Attackers often impersonate legitimate entities such as banks, government agencies, or tech support, using fear tactics or urgent requests to manipulate victims into providing sensitive information. Phishing exploits human trust and emotions, such as fear or urgency, and preys on people's lack of awareness about security practices. It often targets individuals through caller ID spoofing or automated robocalls. To prevent phishing attacks, users should be trained to verify the identity of callers, avoid sharing sensitive information over the phone, and report suspicious calls to the appropriate authorities. Organizations can use call blocking services, caller ID verification, and employee awareness programs to detect and prevent phishing attempts. Smishing, or SMS phishing, is a form of social engineering where attackers use text messages, or SMS, to deceive victims into disclosing personal information or downloading malicious software. Attackers often send fake alerts or urgent messages that appear to come from legitimate sources, like banks or government agencies, urging recipients to click a link or provide sensitive information. Smishing exploits the trust people have in text messages as they often appear more personal and immediate. It can lead to identity theft, financial loss, or installation of malware if the recipient responds or clicks on a malicious link. To prevent smishing, users should avoid clicking on links or replying to unsolicited SMS messages, especially those requesting personal or financial information. They should verify the sender's authenticity before taking any action. Security apps, spam filters, and carrier-based protections can help detect and block smishing attempts, while security awareness training can help users recognize and avoid such threats. QR code phishing, also known as quishing, is a type of social engineering attack where attackers use malicious QR codes to redirect victims to fake websites or download harmful content. Attackers place QR codes on physical posters, flyers, or emails that, when scanned, lead to fraudulent websites designed to steal personal information, install malware, or promote scams. QR code phishing exploits users' trust in QR codes as a convenient and quick way to access links or information. The lack of visible details about the destination website increases the risk of falling for these attacks. Users should avoid scanning QR codes from untrusted sources, verify the URLs behind QR codes before entering any sensitive information, and use QR code scanning apps that can detect malicious links. Security apps, URL scanners, and mobile security software can help detect and block malicious QR codes, while user awareness can prevent inadvertent scanning of harmful codes. Spear phishing is a targeted social engineering attack where cybercriminals customize fraudulent emails or messages to a specific individual or organization, often leveraging personal information to increase credibility. Attackers use personal details such as job titles, interests, or recent activities gathered from social media or other sources to craft convincing messages that will appear legitimate, often with the intent to steal sensitive information or install malware. Spear phishing exploits the trust between individuals or organizations, making it harder for victims to recognize malicious intent. It's often more successful than generic phishing because it feels more personalized and relevant. To prevent spear phishing, users should be cautious with unsolicited emails, verify the authenticity of requests for sensitive information, and use multi-factor authentication to protect accounts. Anti-phishing software, email filters, and security awareness training can help detect and prevent spear phishing attempts by identifying suspicious content and educating users to recognize tailored attacks. Whaling is a type of social engineering attack that targets high-profile individuals, such as executives or key decision-makers, with the intent to steal sensitive information or access company resources. Attackers often craft emails or messages that appear to come from legitimate sources, such as CEO or trusted business partner, and use them to request large financial transfers, confidential data, or login credentials. Whaling exploits the authority and trust placed in high-level personnel, making it easier for attackers to deceive the victim into performing actions that compromise the organization's security, such as transferring funds or disclosing sensitive information. To prevent whaling, organizations should implement strict verification processes for any sensitive or financial transactions, educate executives on identifying phishing attempts, and use multi-factor authentication for critical accounts. Anti-phishing filters, email authentication systems, and security monitoring tools can help identify and block whaling attacks, while user awareness and vigilance are key to recognizing these targeted threats. Shoulder surfing is a social engineering technique where an attacker observes a person's screen, keyboard, or personal devices in public or semi-public spaces to gather sensitive information such as passwords, pins, or account details. Attackers typically position themselves near victims in crowded places like coffee shops, airports, or public transportation, and use their line of sight to capture private data entered by the victim, often without the victim's knowledge. Shoulder surfing exploits the lack of awareness about physical security in public spaces, potentially exposing personal and confidential information, which can lead to identity theft, unauthorized access, or fraud. To prevent shoulder surfing, users should be aware of their surroundings, use privacy screens, avoid entering sensitive information in public, and position themselves away from prying eyes when working with confidential data. While there are no specific detection tools for shoulder surfing, awareness campaigns and promoting secure work environments can help reduce the risk. Security training on protecting sensitive information in public spaces is also crucial. Tailgating is a social engineering attack where an unauthorized person follows an authorized individual into a restricted or secure area, often by exploiting the victim's politeness or lack of attention. Attackers typically wait for an authorized person to enter a secure area and then tailgate closely behind, using the opportunity to gain access to restricted locations, systems, or confidential information without proper authorization. Tailgating bypasses physical security measures and can lead to unauthorized access to sensitive areas or systems, potentially exposing confidential data, systems, or network vulnerabilities to attackers. To prevent tailgating, organizations should enforce strict access control policies, including the use of ID badges, biometric scanners, and requiring employees to challenge unfamiliar individuals trying to enter secure areas. Surveillance cameras, security personnel, and security training can help deter and identify tailgating attempts, ensuring that unauthorized individuals are detected before they can access sensitive areas. Impersonation is a social engineering tactic where an attacker assumes the identity of a trusted individual or entity to manipulate victims into revealing sensitive information or performing actions that benefit the attacker. Attackers may impersonate employees, tech support, company executives, or even law enforcement to gain trust and trick victims into providing confidential data, such as passwords, account numbers, or access to secure systems. Impersonation exploits the trust people place in known or authoritative figures, making it a highly effective method for gaining unauthorized access to systems or sensitive information. To prevent impersonation attacks, organizations should verify identities through multiple channels, such as phone calls or official emails, and enforce strict security protocols for sensitive transactions. Authentication methods like multi-factor authentication and identity verification systems can help detect and prevent impersonation, while security awareness training can educate employees on how to recognize fraudulent behavior. Dumpster diving is a social engineering attack where an attacker searches through an organization's or individual's discarded materials, such as trash, to find sensitive information that can be exploited for malicious purposes. Attackers often look for documents containing confidential information like passwords, financial details, proprietary data, or personal records, which can be used to gain unauthorized access or commit identity theft. Dumpster diving exploits poor disposal practices and can lead to data breaches, identity theft, or the exposure of sensitive corporate or personal information if not properly managed. To prevent dumpster diving, organizations and individuals should implement secure document disposal practices, such as shredding sensitive materials and using locked bins for waste. Physical security measures, including surveillance cameras and controlled waste disposal, can help detect and prevent dumpster diving attempts, while employee training on proper disposal methods reduces risks. A denial of service or DOS attack aims to overwhelm the system, server, or network with excessive traffic or requests, rendering it unavailable to legitimate users. DOS attacks typically involve flooding a target with traffic to exhaust system resources such as bandwidth, memory, or processing power, causing a service outage. DOS attacks can cause a significant downtime, disrupt business operations, and damage a company's reputation. Distributed denial of service or DDoS attacks, where multiple systems are used, are even more challenging to mitigate. To prevent DOS attacks, organizations can implement firewalls, load balancers, intrusion detection systems, and anti-DDoS services that help filter out malicious traffic and distribute requests more efficiently. Tools like intrusion detection systems and traffic analysis software can help detect abnormal traffic patterns, signaling potential DOS attacks and allowing for a quick response. A distributed denial of service attack, or DDoS attack, is a type of DOS attack where multiple compromised systems, often part of a botnet, flood a target with an overwhelming amount of traffic, rendering the system or network inaccessible. DDoS attacks typically use large-scale networks of infected devices or botnets to generate massive amounts of traffic targeting websites, applications, or entire networks to exhaust resources and disrupt service. DDoS attacks exploit the target's limited ability to handle large amounts of traffic, often causing prolonged outages, financial losses, and damage to an organization's reputation and trust with customers. To mitigate DDoS attacks, organizations can use DDoS protection services, deploy firewalls and load balancers, and maintain traffic filtering techniques that detect and block malicious traffic before it reaches the target system. Tools such as intrusion detection systems or IDS, traffic monitoring, and anomaly detection software can help identify the onset of a DDoS attack by analyzing traffic patterns and flagging abnormal spikes. An evil twin attack occurs when an attacker sets up a rogue Wi-Fi access point that masquerades as a legitimate network, tricking users into connecting to it and exposing their data. Attackers typically name their rogue access point similarly to a legitimate one and use it to intercept sensitive information such as login credentials, credit card details, or other personal data. Evil twin attacks exploit trust in familiar Wi-Fi networks, making it easy for attackers to eavesdrop on communications, inject malicious content, or launch man-in-the-middle attacks. To prevent evil twin attacks, users should avoid connecting to unsecured or untrusted Wi-Fi networks, use VPNs for secure browsing, and verify network names before connecting to public Wi-Fi. Wireless intrusion detection systems and network monitoring tools can help detect rogue access points, alerting users or administrators to suspicious network activity. A zero-day attack occurs when a cybercriminal exploits a vulnerability in software or hardware that is unknown to the vendor or developer and therefore has no available patch or fix at the time of the attack. Zero-day attacks can involve exploiting flaws in operating systems, applications, or hardware that have not been discovered or disclosed yet. These attacks are often used for malware distribution, system infiltration, or data theft. The primary threat of a zero-day attack is the vulnerability is unpatched, leaving systems exposed to exploitation. This makes such attacks highly effective as there is no immediate defense against them until the vendor issues a fix. Preventing zero-day attacks requires a proactive approach, including regular security updates, the use of advanced threat detection tools, and applying security best practices like network segmentation and least privileged access. Intrusion detection systems, behavior-based malware scanners, and endpoint protection platforms can help detect suspicious activity that may indicate a zero-day exploit even before a patch is available. Spoofing is a type of cyber attack where the attacker impersonates another entity, such as a website, email address, or IP address, to deceive victims and gain unauthorized access to systems or data. Common types of spoofing include email spoofing, where the attacker sends emails that appear to come from trusted sources, IP spoofing, disguising the source of the network traffic, and website spoofing, creating fraudulent websites that mimic legitimate ones. Spoofing exploits trust and can lead to unauthorized access, data breaches, identity theft, or the distribution of malware. It's particularly dangerous when attackers impersonate trusted organizations or individuals. Preventing spoofing involves using technologies like email authentication, such as SPF, DKIM, or DMARC, secure DNS, and multi-factor authentication to verify identities and prevent unauthorized access. Anti-spoofing tools, email filters, and network monitoring systems can help identify and block spoofed communications or traffic, alerting administrators to potential attacks. An on-path attack, formerly known as a man-in-the-middle or MITM attack, occurs when an attacker intercepts or alters communication between two parties without their knowledge, typically to steal or manipulate data. On-path attackers can intercept network traffic, redirect communications, or inject malicious content into legitimate data streams. Common methods include session hijacking, packet sniffing, and DNS spoofing. On-path attacks can compromise confidentiality, integrity, and availability of data, leading to identity theft, data breaches, financial fraud, or the spreading of malware. Preventing on-path attacks involves using encryption protocols like HTTPS, VPNs, and SSL over TLS to secure communications, as well as implementing network security measures like firewalls, intrusion detection systems, and secure routing practices. Tools such as network traffic analyzers, anomaly detection software, and certificate validation can help detect unusual activities such as unexpected routing or certificate mismatches that may indicate an on-path attack. A brute force attack is a type of cyber attack when an attacker systematically attempts all possible combinations of passwords or encryption keys until the correct one is found. Brute force attacks typically target weak or easily guessable passwords by using automated software to test a large number of potential passwords. The attack can also be used to crack encryption keys or gain unauthorized access to accounts. Brute force attacks exploit the vulnerability of weak passwords or poor security practices. If the target system does not have protections in place, attackers can eventually gain unauthorized access to sensitive data or accounts. To prevent brute force attacks, use strong, complex passwords including a mix of characters, numbers, and symbols. Enable account lockout mechanisms after a set number of failed attempts, and use multi-factor authentication or MFA for additional security. Intrusion detection systems, log analysis tools, and network monitoring software can help identify brute force attempts by tracking unusual login activities or multiple failed login attempts. A dictionary attack is a type of brute force attack where an attacker systematically attempts passwords from a precompiled list of common words, phrases, and combinations, often based on a dictionary of frequently used passwords. Attackers often use automated tools to try variations of dictionary words, including common passwords, names, and phrases, in an attempt to quickly crack weak passwords without testing every possible combination. Dictionary attacks exploit the vulnerability of weak passwords, particularly those that are based on easily guessable words or common phrases. Systems that do not enforce strong password policies are particularly vulnerable. To prevent dictionary attacks, users should implement complex passwords that include a mix of letters, numbers, and special characters, and avoid using dictionary words or common passwords. Enabling account lockout after several failed login attempts and using multi-factor authentication can also help mitigate the threat. Intrusion detection systems, password management systems, and log monitoring tools can help detect patterns of failed login attempts or unusual access attempts, signaling a potential dictionary attack in progress. An insider threat refers to a security risk posed by individuals within an organization, such as employees, contractors, or partners who misuse their access to systems, networks, or data for malicious purposes. Insider threats can include stealing sensitive data, sabotaging systems, leaking confidential information, or intentionally introducing malware. These actions are typically carried out by the individuals who already have legitimate access to the organization's resources. Insider threats exploit trust and authorized access, making them difficult to detect. They can lead to data breaches, financial losses, intellectual property theft, or system downtime, often causing significant harm to the organization. To prevent insider threats, organizations should implement strict access control policies, enforce the principle of least privilege, conduct regular audits, and use monitoring tools to detect unusual user behavior or data access patterns. Security Information and Event Management Systems, or SIEM systems, User Behavior Analytics, or UBA, and data loss prevention tools can help detect and monitor suspicious activities within the organization, alerting security teams to potential insider threats. SQL, or SQL injection, is a type of attack where an attacker inserts or manipulates malicious SQL code into a web application's input fields, such as search bars or login forms, to execute unauthorized database queries. Attackers typically use SQL injection to retrieve, modify, or delete data from the database, bypass authentication mechanisms, or gain unauthorized access to sensitive information, such as usernames, passwords, or credit card numbers. SQL injection exploits the vulnerability of poorly validated or sanitized input fields in web applications. It can lead to data breaches, loss of data integrity, or unauthorized system access, making it a critical security threat. To prevent SQL injection, developers should use prepared statements and parameterized queries, validate and sanitize user inputs, and implement proper error handling to avoid revealing database structure or vulnerabilities. Web application firewalls, static code analysis tools, and vulnerability scanners can help detect SQL injection vulnerabilities and monitor for unusual database activity, providing early warnings of potential attacks. Cross-site scripting, or XSS, is a vulnerability that allows attackers to inject malicious scripts into web pages viewed by other users, often with the intent to steal information or execute harmful actions on behalf of the victim. Attackers use cross-site scripting to inject malicious JavaScript into forms, URL parameters, or user input fields, which can then execute in the browser of unsuspecting users, allowing attackers to steal session cookies, hijack user accounts, or redirect victims to malicious websites. Cross-site scripting exploits weaknesses in web applications that fail to properly validate or sanitize user input. It can lead to session hijacking, data theft, defacement of websites, or the spread of malware. To prevent cross-site scripting attacks, developers should sanitize and validate all user inputs, use output encoding, implement content security policy or CSP headers, and avoid the use of inline JavaScript. Web application firewalls, static code analyzers, and vulnerability scanners can help detect cross-site scripting vulnerabilities, alerting administrators to potentially malicious scripts that might be injected into the web application. Business email compromise, or BEC, is a targeted cyber attack where an attacker impersonates an executive, employee, or trusted partner to manipulate individuals into transferring money or sensitive information. Attackers often use social engineering tactics such as spoofing email addresses, creating urgent or confidential requests, and exploiting weak email security practices to deceive victims into performing unauthorized transactions. Business email compromise attacks exploit the trust and authority of individuals in the organization, leading to financial loss, data breaches, or unauthorized access to confidential information. To prevent business email compromise, organizations should implement email authentication protocols like SPF, DKIM, and DMARC, educate employees on recognizing phishing attempts, and establish verification processes for wire transfers or sensitive requests. Email filtering systems, anti-phishing tools, and security awareness training can help identify and block suspicious emails, while multi-factor authentication adds an additional layer of security to prevent unauthorized access. A supply chain and pipeline attack targets third-party vendors, service providers, or software components within an organization's supply chain with the goal of infiltrating systems or networks through trusted external sources. Attackers may compromise software updates, manipulate hardware, or infiltrate third-party services to introduce malware, backdoors, or other vulnerabilities into an organization's infrastructure. These attacks exploit the trust organizations place in their suppliers and vendors. A successful attack can lead to data breaches, system compromise, intellectual property theft, or widespread system downtime. To prevent supply chain attacks, organizations should implement strong vendor management practices, conduct regular security audits, enforce the principle of least privilege, and ensure software integrity through cryptographic checks or secure code signing. Network monitoring systems, vulnerability scanners, and intrusion detection systems can help detect anomalies in data transfers or suspicious changes in software or hardware, providing early warnings of potential supply chain compromises. Non-compliant systems are devices or software that do not adhere to organizational security policies, regulatory standards, or industry best practices, making them vulnerable to security breaches and attacks. Attackers exploit non-compliant systems by targeting outdated software, unpatched vulnerabilities, weak configurations, or unauthorized applications that can be leveraged for unauthorized access, malware installation, or data theft. Non-compliant systems present significant security risks because they're more likely to have known vulnerabilities that can easily be exploited by attackers, potentially leading to data breaches, financial loss, or system compromise. To prevent the risks associated with non-compliant systems, organizations should implement strict patch management practices, conduct regular security audits, enforce access controls, and ensure that systems meet security standards and regulatory requirements. Vulnerability scanners, compliance management tools, and network monitoring systems can help detect non-compliant systems by identifying systems that do not conform to security policies or are running outdated software or configurations. Unpatched systems are those that have not been updated with the latest security patches or software updates, leaving them exposed to known vulnerabilities and attacks. Attackers often exploit unpatched systems by targeting known vulnerabilities in outdated software, such as operating systems, applications, or network services, to gain unauthorized access, spread malware, or disrupt services. Unpatched systems are highly vulnerable to attacks like ransomware, data breaches, and denial of service attacks, as they lack the latest security protections designed to prevent exploitation. To mitigate the risks associated with unpatched systems, organizations should implement a regular patch management process, automate patch updates, and ensure timely deployment of critical security patches across all systems. Vulnerability scanners, patch management software, and network monitoring tools can help identify unpatched systems and alert administrators about outdated software or configurations that pose a security risk. Unprotected systems refer to devices or computers that lack essential security tools such as antivirus software or firewalls, making them more susceptible to cyber attacks. Attackers exploit unprotected systems by deploying malware, ransomware, or exploiting open ports or vulnerabilities, taking advantage of the absence of active protection mechanisms like antivirus programs or firewalls. These systems are highly vulnerable to infections, unauthorized access, data breaches, and other malicious activities since there's no software monitoring or blocking potentially harmful traffic or files. To mitigate risks, organizations and individuals should always install and regularly update antivirus software, configure and maintain firewalls, and use network segmentation to protect unprotected systems from external threats. Network monitoring tools, intrusion detection systems, and vulnerability scanners can help detect unprotected systems by identifying missing or outdated security software and alerting administrators to potential risks. End of life refers to software, hardware, or operating systems that are no longer supported or maintained by the vendor, leaving them vulnerable to security risks as they no longer receive updates or patches. Attackers exploit end-of-life systems by targeting known vulnerabilities as no new security patches or updates are released to fix these flaws, making the system an easy target for malware, ransomware, or other cyber attacks. End-of-life systems are particularly vulnerable to exploitation because they do not receive timely patches for newly discovered vulnerabilities, which can lead to data breaches, system compromise, or service disruptions. To prevent the risks associated with end-of-life systems, organizations should upgrade to supported software or hardware, implement additional security measures like firewalls and intrusion detection systems, and limit the use of outdated systems. Vulnerability scanners and network monitoring tools can help identify end-of-life systems in a network and assess their security posture, alerting administrators to the potential risks associated with unsupported technology. Bring your own device, or BYOD, refers to the practice where employees or users bring their personal devices, such as smartphones, tablets, and laptops, to the workplace and use them to access company networks and resources. Attackers can exploit BYOD environments by targeting unsecure devices, utilizing malware or phishing attacks to gain access to sensitive organizational data, or taking advantage of weak or improperly configured security measures on personal devices. BYOD introduces risks like data leakage, loss of control over security, and unauthorized access, especially when employees use their devices for both personal and professional tasks without proper security controls in place. To mitigate BYOD risks, organizations should implement strong mobile device management, or MDM, solutions, enforce security policies such as encryption, multi-factor authentication, and ensure proper monitoring and access controls for personal devices. Mobile device management software, network monitoring tools, and endpoint protection software can help detect and manage BYOD-related security threats by ensuring devices are properly configured and monitored for suspicious activities.
Today we're going to review the CompTIA 7-step malware removal process. This is responsible for probably between 2 and 5, depending on your test because they're all different, between 2 and 5 questions on the A+ exam. So step 1 is to identify the malware systems. We don't know what we're fighting until the first thing we do is identify what exactly it is. Step 2 is to quarantine the infected system. We want to remove it from our network. This way it can't infect any other systems. Step 3 is that we want to disable system restore. Now, an easy way to memorize this is we have 2 steps and then we disable system restore, and then we have 2 more steps, 4 and 5, and then on step number 6, we want to re-enable system restore and create a restore point. So we have 2 steps disable, 2 steps re-enable. Step 4 is to remediate the infected system. So this is the one where we actually fix the virus, and this is the one right in the middle of the 7-step repair process. Step 5, we're going to schedule scans and run updates. Now that the virus is fixed, we're doing preventative maintenance from stopping viruses from infecting our system in the future. and making it easier to deal with them. Step 6, we're going to enable system restore and create a restore point. Again, 2 steps and disable, and then 2 more steps, and now we're on to enable. And step 7 is to educate the end user in order to prevent this from happening again. So again, the 7-step process is IQD RSEE. Identify, quarantine, disable, remediate, schedule, enable, educate. The easiest way I've found to memorize this is just trying to remember that step 4 is the one where it's actually fixed. Step 3 and step 6 are disable, enable, and then you should have most of the rest of it figured out. Educate the user is only done after everything else is done. Identifying needs to be done before anything else can be done. So I hope this was helpful. Again, this is going to be multiple questions on the A+ exam as well as covered briefly on some of the other exams. Let me know if there's anything else you're struggling with, and I will do videos on that as well.
In the newest iteration of the A+ exam, CompTIA has changed the definition of the malware removal process from the 7-step process used in the 1101 and 1102 exams to the 10-step process for the A+, 1201 and 1202 exams. You'll notice the steps are the same, but the number of steps and the layout has shifted. You'll notice that the first 4 steps are exactly the same. The last 3 steps are also exactly the same, and the middle few steps are the only ones that have actually shifted. Malware removal step number 1, investigate and verify malware symptoms. Investigating and verifying malware symptoms involves identifying signs of infection on systems in a small office or home office environment and confirming the presence of malware before initiating removal procedures. Signs of malware infection include slow system performance, unexpected pop-ups, changes in system settings, unknown programs running, or the appearance of unfamiliar files or browsing extensions. To verify malware, use tools like antivirus scans, malware removal utilities, and task managers to inspect running processes and identify any suspicious or unfamiliar activities. Isolate infected systems by disconnecting them from the network to prevent further spread of the malware, and back up critical data before attempting removal. Utilize real-time monitoring tools, system log analysis, and network traffic analyzers to verify malware presence and assess the extent of the infection before proceeding with remediation. Malware removal step number 2, quarantining an infected system. Quarantining an infected system involves isolating it from the network to prevent the spread of malware and protect other devices in the small office or home office environment. To quarantine an infected system, disconnect it from the network, both wired and wireless, disable sharing settings, and ensure that external storage devices are not connected to it. Quarantining ensures that the malware cannot communicate with other systems, either by spreading to network devices or by exfiltrating data over the internet, minimizing the risk of further infection. While quarantining the infected system may disrupt operations, it's essential for stopping the malware from causing more damage and allows for secure removal and investigation. Verify the quarantine status by checking for active connections to external networks and monitoring for any unusual system behavior that could indicate the malware is still active. Malware removal step number 3, disable system restore. Disabling System Restore in Windows Home involves turning off the restore feature to prevent malware from being backed up and potentially reintroduced during system recovery. Malware may hide in System Restore points, and if the System Restore feature is left enabled, it could allow the malware to reappear after a system reset or recovery, defeating the purpose of cleaning the system. To disable System Restore in Windows Home, navigate to the System Properties window, select the System Protection tab, and turn off System Protection for the system drive. Disabling System Restore ensures that malicious files or settings in the restore points are removed completely, preventing them from being reactivated if the system is restored to an earlier state. After malware removal is complete and the system is secure, re-enable System Restore to ensure the feature is available for future recovery needs. Malware removal step number 4, remediate the infected systems. Remediating an infected system involves taking steps to eliminate malware, restore the system to its normal operating state, and ensure that it's secure from future threats. Remediation includes using antivirus or anti-malware software to scan and remove malicious files, running system utilities like disk cleanup tools, and ensuring that any vulnerable software or settings are updated. The process typically involves running full system scans, removing detected malware, updating security patches, resetting passwords, and restoring files from clean backups. After malware removal, verify that all suspicious files and activities have been addressed and conduct a full system check to ensure the system is secure and running optimally. Following remediation, apply ongoing security measures such as enabling real-time protection, using firewalls, and implementing regular updates to protect the system from future infections. Malware removal step number 5, updating anti-malware software. Updating anti-malware software involves ensuring that the software is running the latest definitions and patches, which is crucial for detecting and removing the most recent threats. Malware evolves rapidly, and up-to-date anti-malware software ensures that the system can detect and mitigate new forms of malware that may not be recognized by older definitions. To update anti-malware software, check for updates within the software's settings or interface, and allow the software to download and install the latest definitions and software updates automatically or manually. Regular updates help prevent reinfection by ensuring the software can identify and neutralize emerging threats, keeping the system protected from new types of malware. After updating, perform a full system scan to detect and remove any threats that the updated software may now recognize, ensuring the system is clean and secure. Malware removal step number 6, scan and removal techniques. Scanning and removal techniques such as safe mode and pre-installation environment are specialized methods used to detect and remove malware from a system in a controlled environment, bypassing potential interference from active malicious processes. Safe mode starts windows with minimal drivers and surfaces, allowing anti-malware tools to run and scan the system without the malware actively running in the background, making it easier to remove infections. A Windows PE is a lightweight version of Windows that can be run from a bootable USB or CD. It allows users to access the system for malware removal or repair, even if the operating system itself is compromised or unable to boot normally. Using safe mode or PE helps ensure that the malware does not interfere with the removal process, allowing malware to be removed more effectively and reducing the risk of reinfection. After scanning and removing malware in safe mode or PE, run a system check to verify the integrity of the system, ensure that all malware has been removed, and perform updates to secure the system against future threats. Malware removal step number 7, reimage, reinstall. Reimaging and reinstalling involve restoring a system to its original factory settings by wiping the existing operating system and installing a fresh copy of the operating system, often from a backup or recovery image. This procedure is used when malware cannot be effectively removed by other means, such as antivirus scans or safe mode, or when the system has been severely compromised and requires a complete reset for security. Reimaging ensures that any persistent malware, corrupted files, or system modifications are completely removed, providing a clean start. After reinstallation, the system should be updated with the latest patches and antivirus software to prevent future infections. While quarantining the infected system may disrupt operations, it's essential for stopping the malware from causing more damage and allows for secure removal and investigation. After reimaging and reinstalling the operating system, restore any necessary data from secure backups, reinstall applications, and enable security features like firewalls and real-time antivirus protection to ensure ongoing security. Malware removal step number 8, schedule scans and run updates. Scheduling scans and running updates involves setting up regular antivirus scans and ensuring that the system is kept up to date with the latest software patches to prevent malware infections and system vulnerabilities. Automating regular antivirus scans ensures that potential threats are detected and removed even when the user is not actively monitoring the system, helping maintain ongoing protection. Regularly running system and software updates ensures that all security patches and updates are installed to fix vulnerabilities, reducing the chances of exploitation by malware. Scheduling scans and keeping systems updated prevents the buildup of new threats and ensures that security features are always up to date to protect against emerging malware. Set up both automatic updates and scans to run during off hours or when the system is not in use to minimize disruption to daily work, ensuring continuous protection without manual intervention. Malware removal step number 9, enabling system restore and creating restore points. Enabling system restore and creating a restore point in Windows Home allows users to roll back their system to a previous state in case of malware infection or system issues, providing a safety net for recovery. In Windows Home, you can enable System Restore by accessing the System Properties window, navigating to the System Protection tab, and turning on protection for the system drive. After enabling System Restore, create a restore point by selecting Create within the System Protection tab. This creates a snapshot of your system's current state, allowing you to revert back if needed. Creating a restore point before performing any major changes or malware removal steps ensures you can return the system to a clean state if something goes wrong during the process. Regularly creating restore points ensures that you always have a recent recovery option available in case of system instability, malware infection, or accidental system misconfigurations. Malware removal step number 10, educating the end user. Educating the end user involves teaching individuals how to recognize, prevent, and respond to security threats, including malware, to reduce the risk of future infections in a small home office environment. Users should be trained on identifying suspicious emails, avoiding unsafe downloads, recognizing malicious websites, and practicing safe browsing habits to minimize the risk of malware infections. Educating users on the importance of using strong, unique passwords and enabling multi-factor authentication helps protect against unauthorized access and reduces the likelihood of security breaches. Users should be informed about the risks of installing software from untrusted sources and the importance of verifying the legitimacy of software before installation. Regular security awareness training and updates on new threats ensure that users remain vigilant and are equipped to handle emerging malware tactics. Data at rest encryption refers to the practice of encrypting data stored on a device or storage medium to protect it from unauthorized access in case the device is lost, stolen, or compromised. Encrypting data at rest ensures that sensitive information such as personal files, financial data, or company records is kept secure even if the workstation is physically accessed by an unauthorized user. Common encryption tools for data at rest include BitLocker, FileVault, and third-party software like VeraCrypt, which provide full disk encryption or file-level encryption. As part of workstation hardening, enabling data at rest encryption adds an essential layer of security to protect against data breaches and comply with security regulations such as HIPAA or GDPR. Implementing strong encryption algorithms, requiring passwords or PINs for access, and using TPM or Trusted Platform Module chips can further enhance the security of encrypted data and make unauthorized access more difficult. Password length considerations refer to the importance of using long, complex passwords to strengthen workstation security and protect against unauthorized access. A strong password should typically be at least 12 characters long, incorporating a mix of upper and lowercase letters, numbers, and special characters to enhance complexity and resistance to brute force or dictionary attacks. Longer passwords significantly increase the time and resources required to crack them using automated tools. Short passwords are more vulnerable to attacks like brute force or rainbow table attacks. Implementing password policies that require minimum lengths and complexity, for example using a combination of alphanumeric characters and symbols, helps ensure that passwords are strong enough to protect sensitive data and system access. Along with length, organizations should enforce the use of multi-factor authentication and regular password changes to further strengthen workstation security and reduce the risk of unauthorized access. Password character type considerations refer to the use of a variety of character types, including uppercase letters, lowercase letters, numbers, and special characters to create strong, secure passwords. A strong password should incorporate at least 3 of the following character types: uppercase letters, lowercase letters, numbers, and symbols. This increases the complexity and makes the password harder to guess or crack. Utilizing a mix of character types significantly reduces the likelihood of an attacker successfully guessing a password through brute force or dictionary attacks, as the number of possible combinations increases exponentially. Enforcing password policies that require multiple character types ensures that users create stronger, more secure passwords, protecting sensitive information from unauthorized access. Along with character variety, organizations should also encourage users to avoid common phrases, names, or predictable patterns in passwords to further increase security. Password uniqueness refers to the practice of using different passwords for each account or system to prevent the compromise of multiple systems in the event of a breach. Reusing passwords across multiple accounts or systems increases the risk of widespread damage if one password is exposed. A unique password for each account limits the scope of an attack, containing potential damage to one system or account. Users should create distinct passwords for each system or service and avoid using easily guessable patterns or common phrases. Password managers can help store and generate strong, unique passwords for each account. Organizations should enforce policies that discourage password reuse and encourage the use of password managers or encrypted password storage solutions to help users manage unique passwords securely. Along with enforcing password uniqueness, multi-factor authentication should be implemented to further secure accounts and systems from unauthorized access even if a password is compromised. In Windows, password policies can be enforced through the local security policy or group policy by configuring settings such as account lockout thresholds, password history, minimum password age, and administrative account restrictions. Implementing account lockout policies, preventing password reuse, and securing privileged accounts helps protect systems from repeated login attempts and credential-based attacks. Along with enforcing password policies, enable multi-factor authentication, remove default credentials, and apply stricter controls to administrative accounts to further enhance system security. Password expiration refers to the practice of requiring users to change their passwords after a certain period of time to reduce the risk of long-term exposure in case a password is compromised. Organizations should set reasonable expiration periods to ensure passwords are regularly updated without causing excessive disruption to users. Regular password changes reduce the risk of unauthorized access due to a compromised password, ensuring that old or potentially exposed passwords do not remain in use for extended periods. Implementing password expiration as part of a broader password policy helps ensure that users adhere to best security practices, such as selecting strong, unique passwords with each change. While regular expiration enhances security, overly frequent changes can lead to user frustration and weaker passwords. A balance must be struck between security and usability, and complementary measures like multi-factor authentication should also be considered. BIOS and UEFI passwords are security features that restrict unauthorized access to system firmware settings, helping prevent unauthorized users from altering crucial system configurations. Setting passwords on BIOS or UEFI protects the system from being tampered with by unauthorized users who might attempt to change boot order settings, disable security features, or gain access to sensitive information stored on the device. BIOS and UEFI passwords typically include an administrator password to modify settings and a user password to restrict access to the system during boot, enhancing both configuration security and physical security. By enforcing BIOS and UEFI passwords, organizations can ensure that only authorized users can make system-level changes, such as altering boot sequences that could be exploited for boot-based attacks or installing unauthorized operating systems. While BIOS and UEFI passwords improve security, it's crucial to store these passwords securely. If forgotten, the system may become difficult or impossible to recover without resetting the password, potentially leading to operational downtime. A screensaver lock is a security feature that automatically locks a workstation after a specified period of inactivity, requiring a password to unlock the system and continue use. Screensaver locks prevent unauthorized access to a workstation when the user is away from the computer, reducing the risk of data theft, unauthorized use, or malicious actions in a shared environment. The screensaver lock can be configured to activate after a set period of inactivity, and the password prompt can be customized to enhance security by requiring the user to authenticate before resuming activity. This security feature ensures that even if an employee steps away from their desk or leaves their workstation unattended, no one can access sensitive data or perform unauthorized actions without entering a valid password. Implementing screensaver locks alongside other workstation security measures, such as strong passwords and multi-factor authentication, creates a layered defense to prevent unauthorized access and protect sensitive information. Logging off when a workstation is not in use refers to the practice of fully signing out of a system to prevent unauthorized access while the device is idle or unattended. Logging off ensures that no one can access the system, files, or sensitive information if the workstation is left unattended, protecting against unauthorized actions or data breaches. By logging off, users eliminate the risk of someone gaining access to their session and performing malicious activities such as stealing data or changing system settings without proper authentication. Users should be trained to log off after completing their tasks, especially in shared or public work environments, and organizations can enforce automatic log-off policies after a certain period of inactivity to enhance security. Combining logging off with other security measures such as screensaver locks or password protection provides additional layers of defense to prevent unauthorized access when a workstation is idle. Securing or protecting critical hardware involves physically safeguarding key components of a workstation, such as hard drives, ports, and internal devices, to prevent unauthorized access, tampering, or theft. Protecting critical hardware ensures that sensitive data stored on the device, such as personal files or company records, remains safe from theft or damage, even in the event of a physical breach. Use physical locks, enclosures, or cable locks to secure desktops, laptops, or external drives. Disable unused ports to prevent unauthorized connections, and implement BIOS and UEFI passwords to restrict access to critical hardware settings. Encrypting data stored on hard drives ensures that even if the physical hardware is stolen, the data remains unreadable without the correct decryption key, adding an additional layer of security. Secure hardware by placing workstations in controlled, access-restricted environments to minimize physical theft risks, and regularly back up critical data to prevent data loss in case of hardware failure or theft. Securing personally identifiable information and passwords involves protecting sensitive data such as social security numbers, account credentials, and other personal details from unauthorized access, theft, or misuse. Encrypt sensitive files containing PII and passwords to ensure that even if they are accessed by unauthorized users, they remain unreadable without the correct decryption key. Use strong, unique passwords for all accounts and implement multi-factor authentication whenever possible to add an additional layer of security beyond just the password. Store PII and passwords in secure encrypted locations such as password managers or secure cloud storage services, and limit access to authorized personnel only using role-based access controls. Regularly update passwords, educate users on secure password creation, and perform routine security audits to ensure sensitive data is protected from emerging threats. A password manager is a tool designed to store, generate, and manage passwords securely, allowing users to use strong, unique passwords for each account without the need to remember them all. Password managers reduce the risk of password reuse and weak passwords, which are common vulnerabilities in workstation security. They also help protect against brute force attacks by generating complex passwords. Choose a reputable password manager, ensure it's encrypted with a strong master password, and enable features like autofill and two-factor authentication for added security. Store all passwords securely in the password manager, avoiding the use of easily guessable passwords or writing them down. The manager can also securely store PII, credit card information, and other sensitive data. Regularly update the password manager software and ensure that any stored passwords are refreshed periodically, keeping them secure against evolving threats like phishing and credential stuffing. Restricting user permissions involves limiting users' access to files, applications, and system settings based on their roles and responsibilities, ensuring they only have access to the resources necessary for their work. This principle ensures that users are granted the minimum level of access required to perform their tasks, reducing the risk of accidental or malicious changes to system configurations and data. Set up different user roles, for example, standard user or administrator or others, to control access to sensitive data and system settings, ensuring that only authorized users can install software or modify critical configurations. Regularly review user permissions, avoid giving administrative privileges unless absolutely necessary, and implement strong access control policies to ensure sensitive resources are protected. Use tools like group policy in Windows or access control lists to manage user permissions, enforce restrictions, and audit user activity. Restricting login times involves configuring user accounts to only allow access during certain hours, preventing unauthorized logins outside of designated work periods. By limiting login times, organizations can reduce the opportunity for unauthorized access to workstations, especially during off hours when there may be less oversight or monitoring. Implement login time restrictions through user account settings or group policy on Windows systems to define specific hours during which employees can access their workstations. Restricting login times can help prevent unauthorized individuals from accessing sensitive information or systems during non-business hours, particularly in high-risk environments. Regularly review and adjust login time settings based on business needs, ensure that users have appropriate access to work systems when required, and combine this measure with other access control policies for enhanced security. Disabling the guest account refers to turning off the default non-privileged user account that typically allows limited access to a system, preventing unauthorized users from accessing the workstation. Guest accounts are often not password protected and may offer minimum security controls, making them vulnerable to misuse or exploitation by unauthorized individuals attempting to gain access to sensitive data or system functions. An active guest account can be a potential point of entry for attackers who may use it to bypass security measures or access resources without proper authentication. Disable the guest account through system settings or group policy to ensure that only authorized users with appropriate permissions can access the workstation. Additionally, ensure that all user accounts have strong, unique passwords. If temporary or restricted access is required, create user accounts with limited permissions rather than leaving the guest account active, and apply access control measures to ensure security. The failed attempts lockout feature restricts access to a system after a set number of unsuccessful login attempts, helping prevent brute force attacks by limiting the number of guesses an attacker can make. After a predefined number of incorrect login attempts, usually 3 to 5, the system will lock the user account or temporarily block further login attempts for a specified period, thwarting automated or manual attempts to crack passwords. This feature mitigates the risk of unauthorized access by preventing attackers from continuously guessing passwords, thereby enhancing overall workstation security. Failed attempts lockout can be configured in system settings, often through group policy in Windows, allowing administrators to define the threshold for failed attempts and the lockout duration. While implementing failed attempts lockout, balance security and usability by setting an appropriate threshold for failed attempts and considering additional security measures such as CAPTCHA or multi-factor authentication to further reduce the risk of unauthorized access. Timeout or screen lock refers to the practice of automatically locking a workstation or device after a period of inactivity to prevent unauthorized access when the user is away from their computer. After a specified period of inactivity, for example 5 or 15 minutes, the system automatically locks the screen, requiring the user to re-enter their password or use another authentication method to regain access. This feature reduces the risk of unauthorized access in shared or public environments, and it prevents others from interacting with the system when the user is not present. Timeout or screen lock settings can be configured in the operating system's power or security settings, allowing administrators to adjust the lock time based on organizational or user preferences. Enforce timeout or lock screen settings with a short inactivity period, ensure that all workstations use strong passwords or multi-factor authentication, and educate users to lock their screens when leaving their devices unattended. Account expiration dates involve setting a specific time frame during which a user account is active, after which the account is automatically disabled or locked, ensuring that only active, authorized users can access the workstation. Expiring accounts helps prevent unauthorized access by ensuring that users who no longer need access to a system, such as former employees or contractors, cannot use outdated accounts to access sensitive data. Account expiration dates can be configured through system settings, such as Active Directory or local user management tools, where administrators can set a specific date for account deactivation or termination. This technique minimizes the risk of orphaned accounts, inactive accounts that are still enabled, which can be exploited by malicious actors to gain unauthorized access to the system or network. Regularly review account expiration settings, ensure timely removal or disabling of accounts when employees leave, and automate expiration dates for temporary or contract-based users to enhance overall workstation security. Changing the default administrator user account and password involves modifying the system's default administrative credentials to unique and complex ones to reduce the risk of unauthorized access. Default administrator accounts are often widely known, making them a common target for attackers. Changing these credentials ensures that unauthorized individuals cannot easily gain administrative access to the workstation. Create a strong, unique password for the administrator account, and consider renaming the default administrator account to something less obvious to further obscure access points. Update the administrator account credentials through the system's user management settings or command line tools, ensuring that the new credentials are securely stored and not shared unnecessarily. By changing default admin credentials, you make it more difficult for attackers to exploit common knowledge of default accounts, adding an essential layer of protection against brute force and password guessing attacks. Disabling auto run prevents devices such as USB drives, external hard drives, and CDs or DVDs from automatically executing programs when connected to a workstation, reducing the risk of malware execution. Auto-run functionality is commonly exploited by malware to spread quickly across systems. By disabling this feature, you prevent the malware from automatically running when a device is plugged into the workstation. In Windows, auto-run can be disabled through Group Policy, System Settings, or the Registry Editor. This can be done by disabling the Turn Off Autoplay feature or setting Do Not Execute any auto-run commands in the policy settings. Disabling auto-run helps protect workstations from malicious programs that may be installed via infected external devices or media, ensuring that only authorized programs are executed. Along with disabling auto-run, ensure that antivirus software is up to date and always scan external devices before accessing their contents to further enhance workstation security. Disabling unused services involves turning off unnecessary or non-essential system services that are not required for the workstation's core functionality, reducing potential attack vectors. Each active service can present a security risk as it may have vulnerabilities that could be exploited by attackers. Disabling unused services minimizes the attack surface by ensuring only essential services are running. Unused services can be identified and disabled through the system's Service Management Console or by using command line tools like services.msc in Windows or systemctl in Linux-based systems. By disabling services that are not needed, organizations reduce the risk of unauthorized access, information leakage, or the exploitation of unpatched vulnerabilities associated with these services. Regularly audit and review the list of active services, ensuring that only necessary services are enabled. Use security tools like vulnerability scanners to identify services that can be safely disabled. Device encryption involves converting the data stored on a mobile device into a secure format that can only be accessed with the correct authentication key, ensuring that sensitive information remains protected if the device is lost or stolen. Encryption prevents unauthorized access to personal and business data, including emails, documents, passwords, and other sensitive information even if the device is physically compromised. Full disk encryption or file-based encryption is typically used to encrypt the entire device or specific files, respectively, using algorithms like AES or Advanced Encryption Standard to secure the data. Device encryption ensures that the data on mobile devices remains secure, complying with industry regulations such as HIPAA or GDPR, which mandate data protection standards. Always enable device encryption on mobile devices, use strong authentication methods like PINs or biometrics to access encrypted data, and ensure that encryption settings are applied by default on all enterprise devices. Facial recognition screen lock is a biometric security feature that uses facial recognition technology to authenticate a user and unlock a mobile device, offering a convenient and secure way to protect the device. The system uses the device's front-facing camera to capture and analyze unique facial features, comparing them to a stored template to verify the user's identity before granting access. Facial recognition provides a fast and user-friendly method of securing mobile devices, making it harder for unauthorized users to access the device, especially if combined with additional security layers like PINs or passwords. While convenient, facial recognition can sometimes be vulnerable to spoofing, for example using a photo or video, or may struggle with recognition in low lighting or if the user's appearance changes significantly, for example with heavy makeup or a change in hairstyle. Enable facial recognition in combination with other authentication methods like a PIN or fingerprint to enhance security. Ensure that the system is properly trained to recognize the user's face and consider using advanced features like 3D facial recognition for more robust security. A PIN code screen lock is a security feature that requires the user to enter a numeric code, usually 4 to 6 digits, to unlock their mobile device, providing a simple but effective method for protecting the device. The PIN code is easy to set up and remember, providing a basic level of security that prevents unauthorized access to the device if it's lost or stolen. While effective, PIN codes can be vulnerable to brute force attacks or can be guessed by individuals who observe the user entering the code. Short PIN codes are especially easy to crack. Use longer PIN codes of 6 digits or more to enhance security and avoid using easily guessable numbers like 1234 or personal information like, for example, birth dates. Additionally, combining the PIN with other security features like facial recognition or a fingerprint scanner can improve protection. Some devices offer a timeout or screen lockout feature after a certain number of failed PIN attempts, which can prevent unauthorized users from continuously trying to guess the code. A fingerprint screen lock is a biometric security feature that uses the user's fingerprint to authenticate their identity and unlock their mobile device, offering a quick and secure method of access. Fingerprint authentication provides a high level of security as it uses unique biometric data, making it significantly more difficult for unauthorized users to access the device compared to traditional PINs or passwords. The system captures and stores fingerprint template upon setup, and each time the user attempts to unlock the device, the fingerprint is scanned and compared to the stored data to grant access. While highly secure, fingerprint locks can be bypassed in some cases, such as with high-quality replicas of a fingerprint or if the device's fingerprint sensor is compromised. Additionally, it may have issues recognizing fingerprints in certain conditions, like wet or dirty fingers. Use fingerprint authentication in combination with other security measures, like a PIN or password, to create a layered defense. Regularly update device security settings and ensure the fingerprint data is securely stored. A pattern screen lock is a security feature where users draw a specific pattern on a grid of dots to unlock their mobile device, offering a visual and convenient method of authentication. Pattern locks are easy to remember and can be faster to use than typing a PIN or password, providing a decent level of security for mobile devices. Pattern locks can be vulnerable to shoulder surfing, where someone observes the user drawing a pattern. Additionally, patterns that are too simple or follow predictable paths, for example L-shaped or diagonal lines, are easier to guess or crack. Use a complex and unique pattern that does not follow common shapes or predictable paths, and combine the pattern lock with additional security measures like a PIN or biometric authentication for stronger protection. Regularly change the pattern to avoid it being discovered over time, and avoid using patterns that are easily recognizable, such as simple shapes or common gestures. A swipe lock typically involves swiping a finger across the screen to unlock the device, often in a simple manner. It's used as a quick method to unlock a mobile device without the need for entering a password or drawing a pattern. This method is most commonly found in older devices or as an option alongside other unlocking methods like PINs or biometrics. Swipe locks are generally less secure than other authentication methods as the swipe gesture can be easily replicated or observed. Modern devices may not use swipe locks as frequently as newer security features like fingerprint recognition and facial recognition have become more prevalent. Configuration profiles are sets of predefined settings used to configure and enforce security policies on mobile devices, typically implemented in managed environments like businesses or educational institutions. These profiles allow administrators to control device settings remotely, including network configurations, security protocols, application restrictions, and password policies, ensuring consistent security across multiple devices. Configuration profiles can enforce password complexity, set device encryption, restrict access to certain apps or features, and enable remote wipe capabilities to protect data in case the device is lost or stolen. These profiles are commonly used in conjunction with mobile device management or MDM solutions to streamline the process of managing security settings across large numbers of devices in a secure and automated way. Ensure that configuration profiles are regularly updated to address emerging security threats and use them in combination with encryption, device locking, and remote wipe features to enhance overall mobile device security. OS Update Patch Management refers to the process of regularly updating and applying patches to the operating system of mobile devices to fix known vulnerabilities, improve functionality, and enhance security. Regular OS updates help protect devices from security threats by addressing vulnerabilities that could be exploited by attackers to gain unauthorized access or cause damage to the system. Mobile devices automatically download and install security patches, bug fixes, and system updates as part of the OS update process. However, users can also manually initiate updates or configure automatic updates based on preferences. Ensure that mobile devices are set to receive updates automatically, and regularly check for updates to ensure that no critical patches are missed. In managed environments, mobile device management solutions can enforce update policies across all devices. While updates are essential for security, it's important to test updates in a controlled environment before widespread deployment, especially in a business setting, to prevent compatibility issues or disruptions. Application update patch management involves regularly updating mobile apps to fix security vulnerabilities, improve functionality, and ensure compatibility with the latest operating system features. Just like OS updates, application updates are essential for protecting mobile devices from threats. Patches often address security flaws in apps that can be exploited by attackers to gain access to sensitive data or execute malicious code. Apps on mobile devices typically offer automatic update functionality, which ensures that the latest patches are downloaded and installed. However, users should also manually check for updates in the App Store to ensure that no critical patches are missed. Enable automatic updates for all apps to ensure timely installation of security patches. In enterprise environments, mobile device management solutions can enforce app update policies to maintain security across all managed devices. Regularly review the apps installed on mobile devices and remove any outdated or unnecessary apps, as they may no longer receive updates or patches, potentially leaving the device vulnerable. Antivirus endpoint security software is a type of software designed to detect, prevent, and remove malicious software or malware on mobile devices, protecting them from threats such as viruses, spyware, ransomware, and phishing attacks. As mobile devices become a prime target for cyber attacks, antivirus software provides real-time protection, scans for malware, and blocks harmful apps or files from infecting the device. Antivirus software runs in the background of the mobile device, scanning for malicious files, behaviors, and apps. It uses signature-based detection, heuristic analysis, and cloud-based databases to identify and block new threats. Install reputable antivirus software from trusted sources, enable real-time protection features, and regularly perform scans to ensure the device remains free from malware. Additionally, keep the antivirus software up to date with the latest virus definitions. In enterprise environments, mobile device management solutions can enforce antivirus policies to ensure all devices are properly protected. It's also important to balance security with performance, as overly aggressive antivirus software can impact device functionality. Anti-malware endpoint security software is designed to detect, block, and remove malicious software, including viruses, trojans, spyware, ransomware, and adware from mobile devices, ensuring a layer of defense against security threats. Mobile devices are frequent targets for malware, and anti-malware software helps safeguard personal data and prevent attacks that could lead to data breaches, unauthorized access, or device malfunction. Anti-malware software uses signature-based detection, heuristic analysis, and behavioral monitoring to identify and stop malware before it can infect the device. It also continuously scans for threats in real time and provides updates to counter new malware strains. Regularly update the anti-malware software to ensure the latest definitions are in use, enable real-time scanning for continuous protection, and perform periodic scans to detect any potential threats that might be missed by real-time protection. In enterprise settings, anti-malware software can be managed via mobile device management systems to ensure uniform protection against all devices. It's essential to choose a lightweight anti-malware solution that doesn't impact the device's performance. Content filtering endpoint security software restricts access to certain types of online content, such as harmful websites, inappropriate material, or known malicious sources to protect mobile devices from browsing threats. This software monitors internet activity and uses blacklists, whitelists, or real-time threat databases to block harmful or non-compliant websites, preventing users from accessing malicious or risky content that could lead to malware infections or phishing attacks. By filtering content, it helps prevent users from unknowingly visiting sites that host malware, scams, or phishing attempts, reducing the likelihood of device compromise or data theft. Implement content filtering as part of a comprehensive security strategy, ensure the filtering settings are customized based on the organization's needs, and regularly update filtering databases to block emerging threats. Content filtering can be managed centrally using mobile device management solutions in enterprise environments, providing administrators with the ability to enforce policies across all mobile devices and prevent risky behavior. Locator applications, often referred to as Find My Device apps, help track and locate a mobile device if it's lost or stolen, providing an additional layer of security and enabling the remote management of the device. These applications use GPS, Wi-Fi, or cellular networks to pinpoint the device's location, allowing the user or administrators to view the device's whereabouts in real time. Some apps also offer remote actions, such as locking the device, erasing data, or sounding an alarm. Locator apps are crucial for mitigating the risk of data theft in case a mobile device is misplaced or stolen, as they provide the ability to remotely secure or wipe the device to protect sensitive information. Enable the Locator app on all mobile devices, ensure location services are activated, and set up remote management features like remote locking and data wiping for increased security. Some mobile device management solutions include Locator app functionality, allowing organizations to track and secure all managed devices, enhancing security across the workforce. A remote wipe is a security feature that allows users or administrators to remotely erase all data on a mobile device in case it's lost, stolen, or compromised, ensuring that sensitive information is not accessible to unauthorized users. Remote wipes are typically initiated through a Find My Device app, mobile device management solution, or cloud service. Once activated, the device will erase all personal data, apps, and settings, returning the device to its factory state. Remote wipe is a critical tool for preventing data breaches by ensuring that confidential or sensitive information is erased from the device if it falls into the wrong hands, minimizing the risk of identity theft or data leakage. Enable remote wipe functionality on all devices, ensure it's integrated with MDM or cloud-based services, and use strong authentication methods to prevent unauthorized initiation of the wipe. While remote wipe can protect data, it can be a drastic measure since it erases all device data. Therefore, it should be used only when necessary, and users should regularly back up important data to ensure recovery. Remote backup applications allow users to back up the data on their mobile device to cloud storage or remote servers, ensuring that important information is securely stored and can be recovered if the device is lost, stolen, or damaged. Remote backups help protect against data loss due to device theft or failure by ensuring that critical files, contacts, and settings are stored off-site and can be restored to a new device or after a system reset. Remote backup apps automatically sync data to cloud storage, providing regular updates and backups to ensure the latest information is securely stored. These apps often encrypt data to protect it during transfer and storage. Set up automatic backups to ensure data is consistently saved and up to date. Use encrypted cloud storage services and require strong authentication for added security. While remote backup applications are critical for data protection, it's important to regularly test the backup process and ensure that the data can be recovered efficiently in case of a device failure or security incident. Failed login attempt restrictions are security measures that limit the number of incorrect login attempts on a mobile device before further access is denied or the device is locked for a period of time, reducing the risk of unauthorized access through brute force attacks. After a set number of incorrect password or PIN entries, the system may lock the device temporarily, require additional verification steps, or trigger a remote wipe to protect sensitive data. This restriction prevents attackers from repeatedly guessing passwords or PINs, thus minimizing the chances of successful unauthorized access and enhancing overall device security. Set reasonable limits for failed login attempts to balance user convenience with security and ensure that the device prompts for additional security measures such as CAPTCHA or two-factor authentication after multiple failed attempts. Ensure that users are educated about password security and the potential consequences of repeated failed attempts to avoid accidental lockouts and potential frustration. Mobile device management policies and procedures refer to the guidelines and practices used to manage and secure mobile devices in an organization, ensuring that devices comply with security requirements and organizational standards. MDM solutions enable centralized management of mobile devices, including enforcing password policies, remote device wiping, device encryption, and app management, helping secure devices from unauthorized access or data breaches. By enforcing MDM policies, organizations can ensure that all mobile devices meet security standards, prevent unauthorized apps or services from being installed, and provide remote control in case a device is lost or compromised. Set clear security policies within the MDM platform, including strong password requirements, data encryption, and limitations on app usage. Regularly monitor devices to ensure compliance and update policies as needed to address emerging threats. MDM solutions should be combined with other security measures like VPNs and endpoint protection to provide a comprehensive security framework for managing and securing mobile devices across the organization. BYOD, or Bring Your Own Device, refers to policies that allow employees to use their personal devices for work purposes, while corporate-owned device policies require the organization to provide and control all devices used by the employees. In BYOD environments, managing and securing a diverse range of personal devices can be challenging, as employees may install unauthorized apps or use weak security measures. To mitigate risks, organizations typically enforce MDM or mobile device management and security policies like encryption and app whitelisting. Corporate-owned devices offer more control, allowing organizations to enforce strict security measures such as standardized configurations, mandatory security updates, and comprehensive monitoring, making them easier to secure and manage. For BYOD, companies should implement robust MDM solutions, require strong password policies, enforce device encryption, and use remote wipe capabilities in case of theft or loss. Additionally, establish clear guidelines for acceptable use and app management. For corporate-owned devices, organizations should ensure proper configuration, regular security updates, and full device encryption. Consider implementing policies for app management and data segregation between personal and work data to avoid potential conflicts or risks. Profile security requirement policies define the security standards that must be met for mobile device profiles, such as password strength, encryption, and application control, ensuring that devices are configured securely before accessing corporate resources. These policies can enforce settings like strong password complexity, multi-factor authentication, data encryption, and restrictions on app installations to prevent unauthorized access and reduce vulnerabilities. By applying these policies, organizations can ensure that all mobile devices meet minimum security standards, protecting sensitive data from unauthorized access or leakage, and maintaining compliance with industry regulations. Set clear security policies within the mobile device management system or profile configuration tools, regularly update them to address emerging threats, and monitor devices for compliance with these standards. Customize profile security requirements based on user roles and device types, ensuring that high-risk devices or users with access to sensitive data have stricter security measures in place. Drilling refers to the physical destruction of hard drives by drilling holes into the device, rendering it inoperable and ensuring that the data stored on it cannot be recovered. Drilling involves using a power drill to puncture the hard drive's platters, effectively damaging the drive's internal components, making it impossible to retrieve data even with specialized data recovery tools. This method provides a high level of security, especially when combined with other data destruction techniques, as it ensures the hard drive is permanently destroyed and data cannot be recovered. When performing drilling, ensure that the drive is punctured in multiple locations, including the platters, to increase the likelihood of data destruction. Follow proper safety precautions to avoid injury from flying debris. Drilling is a cost-effective and efficient method for destroying hard drives, but it may not be suitable for all situations, such as when a drive needs to be recycled or reused in an environmentally responsible manner. Shredding involves physically breaking down a hard drive into small pieces using industrial shredding machines, making the data stored on it completely irretrievable. The hard drive is placed into a specialized shredder that crushes the device into small fragments, destroying the platters and other internal components, ensuring that the data is permanently inaccessible. Shredding provides a high level of security as it physically renders the hard drive unusable and prevents any chance of data recovery, even with advanced forensic tools. When shredding hard drives, ensure that the process is done through certified services that meet industry standards for data destruction and verify that the shredded components are disposed of properly. Shredding is an effective method for data destruction, but can be costly and may not be suitable for drives that need to be recycled or repurposed. Additionally, it is essential to use certified shredding services to ensure compliance with data protection regulations. Degaussing is a method of data destruction that uses strong magnetic fields to disrupt the magnetic properties of the hard drive's platters, rendering the data on the drive unreadable. Degaussing machines generate powerful electromagnetic fields that erase or scramble the data stored on the hard drive, making it impossible to recover even with specialized tools. Degaussing provides a secure and effective way to destroy data on magnetic storage devices without the need for physical destruction. It's particularly useful for large volumes of drives when the data needs to be securely wiped. When degaussing hard drives, ensure the use of certified high-powered degaussing equipment that meets industry standards to guarantee data destruction. It's important to follow up with physical destruction such as shredding for additional security. Degaussing only works on magnetic storage devices and is ineffective for solid-state drives. Additionally, it permanently damages the drive, rendering it unusable for reuse or recycling. Incineration is a data destruction method that involves burning hard drives at high temperatures to completely destroy the device and its stored data. Hard drives are placed in an industrial furnace or incinerator where they are subjected to extreme heat, causing the components to melt, burn, or disintegrate, making data recovery impossible. Incineration is an effective and thorough method of destroying hard drives, ensuring that no readable data remains. It's particularly useful for drives containing highly sensitive or classified information. Ensure that incineration is performed by a certified e-waste disposal facility that follows proper environmental and regulatory standards, as improper incineration may lead to harmful emissions. Incineration permanently destroys the hard drive, preventing any further use or recycling of the device. Additionally, it may not be suitable for environmentally conscious organizations due to potential environmental impacts. Erasing or wiping refers to the process of securely deleting all data on a storage device, making it unrecoverable in preparation for recycling or repurposing the device. Data wiping software uses algorithms to overwrite the data multiple times, ensuring that the original information is permanently erased. This can be done using tools like dban, Darix, Boot, and Nuke, or built-in utilities such as Windows Disk Cleanup or MacOS Disk Utility. Wiping a device before repurposing or recycling it ensures that no personal or sensitive information can be retrieved, protecting the user from data breaches or identity theft. Use reliable and certified data wiping software that meets industry standards for secure deletion and verify that the data is unrecoverable before disposing of the device or repurposing it for other uses. While erasing or wiping data is effective, it may not fully prevent recovery in some cases, especially with specialized forensic tools. Physical destruction methods like shredding or degaussing may be required for highly sensitive data. Low-level formatting is a data destruction method that involves resetting the storage device to its factory state by erasing all data on the hard drive, including the file system and partitioning information. During low-level formatting, the device's storage sectors are overwritten and the structure of the disk is reset, making it harder for data recovery tools to retrieve any of the original data. This method provides a higher level of security than simple file deletion or formatting, as it removes the file system and other metadata that might allow data recovery. Low-level formatting should be used alongside other data destruction methods like data wiping or physical destruction to ensure the device is securely cleared before recycling or repurposing. Low-level formatting may not fully render modern SSDs and flash memory devices unrecoverable, as they use different storage mechanisms than traditional HDDs. It's also irreversible and can permanently damage a drive if not done correctly. Standard formatting is a method of preparing a storage device for reuse or recycling by deleting files and creating a new file system, which makes the data inaccessible but doesn't fully erase it. During standard formatting, the device's file system is wiped and the data is marked as deleted. However, the data is not fully overwritten and it can potentially be recovered using specialized recovery tools. While standard formatting is a quick and easy method of erasing data, it's not sufficient for securing highly sensitive information, as traces of the deleted data remain on the device. Standard formatting should be used only when the data on the device is not sensitive or when it's combined with other methods, such as data wiping or encryption, for added security before recycling or repurposing. For devices containing confidential or sensitive data, standard formatting is not recommended. Instead, more secure methods like low-level formatting, data wiping, or physical destruction should be used to ensure complete data destruction. Third-party vendor outsourcing involves delegating the responsibility of data destruction and disposal to external vendors that specialize in secure data handling and compliance with legal and regulatory standards. Outsourcing data destruction to certified vendors ensures that the process follows industry best practices using secure methods like degaussing, shredding, or certified wiping to guarantee complete data removal. Reputable third-party vendors are often certified under standards like NAID or ISO 27001, which ensures that they adhere to legal, environmental, and security regulations when disposing of or destroying data. Ensure that the third-party vendor provides a certificate of destruction or a detailed report documenting the data destruction process, including methods used and confirmation that the data is irrecoverable. When outsourcing, it's essential to thoroughly vet the vendor's security practices in compliance with relevant data protection laws, like GDPR or HIPAA, to minimize the risk of data breaches during the disposal process. Certification of destruction or recycling outsourcing refers to the process where third-party vendors provide formal documentation confirming that data has been securely destroyed or recycled according to industry standards and regulations. A certification of destruction ensures the data destruction process was thorough, compliant with legal requirements, and performed using secure methods, reducing the risk of data leakage or unauthorized access. Outsourcing data destruction with certification helps organizations meet regulatory requirements such as GDPR, HIPAA, and other data protection laws by ensuring that sensitive data is properly disposed of. Always request and retain a certificate of destruction from the vendor, which should include details of the methods used and the final disposition of the hardware. When outsourcing data destruction, ensure the vendor has the appropriate certifications and follows the proper security procedures to mitigate the risks associated with data breaches during disposal. Regulatory and environmental requirements refer to the laws, regulations, and standards that govern how data must be securely destroyed and how electronic waste should be disposed of in an environmentally responsible manner. Various regulations such as GDPR, HIPAA, and the Fair and Accurate Credit Transactions Act, or FACTA, mandate specific data destruction practices to protect sensitive data and ensure privacy, requiring organizations to securely erase or destroy data before disposal. E-waste disposal must comply with environmental regulations such as the Waste Electrical and Electronic Equipment Directive and the Resource Conservation and Recovery Act, which aim to reduce the environmental impact of discarded electronics and ensure proper recycling of electronic components. Organizations should partner with certified e-waste recycling vendors that comply with regulatory requirements for data destruction and environmentally responsible disposable methods. Ensure that vendors provide certification of destruction and follow guidelines for safe recycling. Failing to adhere to data destruction regulations can lead to legal consequences, including fines, lawsuits, or damage to an organization's reputation. It's essential to stay updated on changing laws and ensure that all data disposal activities meet the required standards. Changing default passwords in router settings. Default router passwords are often publicly known and pose a major security risk. Accessing the router's web interface allows the users to change the default login credentials. Leaving default credentials unchanged can lead to unauthorized access and network compromise. Strong passwords should include a mix of uppercase, lowercase, numbers, and symbols. It's also recommended to document new credentials securely for future access. IP filtering in router settings. IP filtering allows administrators to permit or block traffic based on specific IP addresses. It enhances network security by restricting access to trusted devices or networks. IP filtering can be applied to both incoming and outgoing traffic for granular control. Misconfigured filters may accidentally block legitimate traffic or services. This feature is commonly used in small office or home office networks to control device access. Firmware updates in router settings. Firmware updates enhance router performance, fix bugs, and patch security vulnerabilities. Updating firmware is typically done through the router's web interface or manufacturer's website. It's important to back up router settings before performing a firmware update. Interrupting the update process can corrupt the firmware and render the router unusable. Regular firmware updates help ensure compatibility with new devices and protocols. Content filtering. Content filtering blocks access to specific websites or categories based on keywords, URLs, or IP addresses. It's commonly used to restrict inappropriate or non-work-related content on a network. Filters can be applied globally or to specific devices using IP or MAC address rules. Some routers support schedule-based filtering to limit access during certain hours. Effective content filtering enhances security and productivity by reducing exposure to malicious or distracting sites. Physical placement and secure locations for routers. Placing a router in a central, elevated location helps ensure strong and even wireless signal coverage. Avoiding placement near walls, Metal objects or electronic interference improves network performance. Routers should be kept in secure, restricted access areas to prevent unauthorized physical tampering. Physical security reduces the risk of someone pressing the reset button or stealing the device. Locking network equipment in cabinets or rooms is a best practice in both home and business environments. Universal plug-and-play in router settings. Universal plug-and-play allows devices on a network to automatically discover and communicate with each other. It simplifies tasks like gaming, media streaming, and device configuration by opening ports dynamically. While convenient, universal plug-and-play can pose a security risk if exploited by malicious applications. Disabling universal plug-and-play is recommended on networks where security is a higher priority than ease of use. Universal plug-and-play settings can be managed through the router's web interface under Advanced or Security Settings. Screen subnet in router settings. Screen subnet, also known as a DMZ or demilitarized zone, isolates public-facing services from the internal network. It adds an extra layer of security by placing servers like web or email outside the trusted LAN. Routers can forward specific traffic to the DMZ while keeping the rest of the network protected. Misconfiguring a DMZ can expose sensitive data or allow unauthorized access to internal systems. Screen subnets are commonly used in small businesses to safely host internet-accessible services. Configuring secure management access in router settings. Secure management access restricts who can configure the router by requiring authentication in encrypted connections. Using HTTPS or SSH instead of HTTP or Telnet helps protect credentials from being intercepted. Limiting access to specific IP addresses prevents unauthorized devices from reaching the management interface. Changing the default management port can reduce exposure to automated attacks. Regularly updating admin credentials and disabling remote access when not needed enhances overall router security. Changing the SSID in wireless router and network settings. The SSID, or Service Set Identifier, is the broadcast name of a wireless network that users see when connecting. Changing the default SSID helps differentiate your network and can deter casual attackers. A custom SSID should avoid personal information to prevent identification or targeted attacks. Hiding the SSID adds a minor level of obscurity but does not provide real security. SSID settings can be adjusted through the router's wireless configuration page in the web interface. Disabling SSID broadcast in wireless routers and networks. Disabling SSID broadcast hides the network name from appearing in the list of available Wi-Fi networks. This setting provides minimal security through obscurity, as the SSID can still be discovered with network tools. It can help reduce casual connection attempts by non-authorized users. Devices must manually enter the SSID to connect, which can be inconvenient for some users. This option is configured in the wireless settings section of the router's web interface. Encryption settings in wireless routers and networks. Encryption protects data transmitted over wireless networks from being intercepted or read by unauthorized users. WPA2 and WPA3 are the most secure and recommended encryption protocols for modern networks. WEP, or Wired Equivalent Privacy, is outdated and insecure and should never be used on current wireless setups. Encryption settings are configured in the router's wireless security or network settings menu. Using strong encryption ensures privacy, data integrity, and compliance with security best practices. Configuring guest access in wireless routers. Guest access allows visitors to connect to the internet without accessing the main network or its devices. It's typically set up through the router's web interface under wireless or guest network settings. Guest networks should use WPA2 or WPA3 encryption and a separate password for secure access. Isolating guest traffic from the primary network prevents unauthorized access to shared files and printers. Enabling time limits or bandwidth restrictions can help manage guest usage and preserve network performance. Disabling unused ports in router firewall settings. Disabling unused ports reduces the network's attack surface by blocking unnecessary entry points. Open ports can be exploited by hackers or malware if left unmonitored and unsecured. Router firewalls allow manual port management to close or restrict specific ports. Regular port scans can help identify and disable unused or unexpected open ports. This practice is a key step in hardening network security and preventing unauthorized access. Port forwarding and mapping in router firewall settings. Port forwarding directs incoming traffic on specific ports to designated devices within a local network. It enables external access to internal services like web servers, gaming consoles, or surveillance systems. Each forwarded port must be carefully configured to avoid exposing sensitive systems to threats. Port mapping associates external ports with different internal ports to provide flexibility and security. These settings are typically found in the router's firewall or NAT, Network Address Translation section. Hashing is a cryptographic technique that converts data such as passwords or files into a fixed-length string of characters, which is typically used to verify data integrity and ensure secure communication between trusted sources. Hashing ensures that sensitive information, such as passwords or authentication tokens, is stored and transmitted securely by generating a unique hash value that is nearly impossible to reverse or guess. When configuring browser security settings, hashing is used in the process like SSL or TLS encryption, where it ensures the integrity of data being transmitted between the browser and trusted websites, preventing data tampering or interception. Hashing is commonly employed in trusted sources such as certificates or public keys to verify the authenticity of the source, ensuring that the data received by the browser is from a legitimate, trusted origin. Enable strong hashing algorithms like SHA-256 or better in browser security settings, ensure that SSL and TLS certificates are properly configured, and use secure connections like HTTPS to prevent potential attacks like man-in-the-middle. Untrusted sources refer to websites, servers, or online content that have not been verified or do not meet established security standards, posing potential risks such as malware, phishing, or data theft. Browsing untrusted sources can expose users to a variety of threats, including malware downloads, phishing attacks, and man-in-the-middle attacks, as these sites may lack encryption or proper verification. To safeguard against untrusted sources, browsers should be configured to block pop-ups, disable insecure content, enable HTTPS-only mode, and use features like safe browsing or phishing protection. Ensure that SSL or TLS certificates are properly validated and that warnings are displayed when connecting to untrusted sites without valid security certificates, as these sites may not properly encrypt data or prove their identity. Regularly update the browser and security settings to protect against evolving threats and avoid visiting untrusted sources or clicking on suspicious links, especially when using sensitive personal or financial information. Browser patching refers to the process of updating and applying security patches or updates to a web browser, addressing vulnerabilities and improving the browser's security features. Regular browser patching is essential for protecting against known security threats, such as malware, phishing, and zero-day exploits, by ensuring that the browser is equipped with the latest fixes and improvements. Browser vendors release updates that fix bugs, patch vulnerabilities, and introduce new security features. These updates typically address issues like insecure plugins, unpatched flaws, or vulnerabilities that could be exploited by attackers. Enable automatic updates in your browser settings to ensure timely installations of security patches. Additionally, regularly check for manual updates, especially for enterprise or legacy browsers that may not have automatic patching enabled. While patching browsers is important, also ensure that other related software such as plugins or extensions is kept up to date to prevent vulnerabilities from being exploited through outdated components. Extensions and plugins are additional software components that enhance a browser's functionality by adding features such as ad blocking, password management, or video playback capabilities. While extensions and plugins can improve user experience, they also pose security risks, as malicious or outdated versions can access sensitive data, track browsing activity, or introduce vulnerabilities to the browser. Disable or remove unnecessary extensions and plugins, and only install them from trusted sources like official browser stores or reputable websites. Regularly review and update installed extensions to ensure they're safe and up to date. Configure your browser to limit or block the use of third-party extensions or plugins from untrusted sources. Enable features like Click to Play for plugins to prevent automatic execution of potentially harmful content. Use browser settings to manage permissions for extensions and plugins, such as limiting access to sensitive data and controlling what information they can read or modify. Trusted sources for extensions and plugins refer to well-known reputable vendors or official browser stores, while untrusted sources are third-party sites or developers that may pose a security risk by providing malicious or outdated software. Extensions and plugins from untrusted sources can introduce malware, track users' browsing activity, or steal sensitive information. They may also bypass security measures or exploit vulnerabilities in the browser. Always download extensions and plugins from official browser stores or trusted developer sites to reduce the risk of installing malicious software. Avoid third-party download sites unless thoroughly vetted. Configure browser security settings to block or limit the installation of extensions and plugins from untrusted sources. Enable settings to review permissions and control what data extensions can access. Regularly review installed extensions and plugins, removing any that are unnecessary or from untrusted sources. Ensure that updates are applied promptly to keep extensions secure and compatible with the latest browser security patches. Password managers are tools that securely store and manage passwords, automatically filling in login credentials on websites and encrypting sensitive data to prevent unauthorized access. Password managers generate strong, unique passwords for each account and store them in an encrypted vault, ensuring that users don't need to remember or manually enter passwords, which reduces the risk of using weak or reused passwords. Using a password manager enhances security by ensuring that users adopt complex, unique passwords for every account and prevents phishing attacks by automatically filling in correct credentials only on trusted sites. Enable two-factor authentication for the password manager to provide an added layer of protection. Regularly update the password manager and ensure the master password is strong and unique. Most modern browsers offer built-in password managers that can be enabled to securely store and autofill credentials. Ensure that browser settings are configured to encrypt stored passwords and synchronize them across devices securely. Secure connections refer to the use of encryption protocols such as HTTPS to establish secure communication between a browser and a website, ensuring that data transmitted is protected from interception. Valid certificates are digital certificates that authenticate the identity of a website and enable encryption. Websites with valid SSL or TLS certificates use encryption to protect user data, such as passwords and credit card information, from being intercepted by malicious actors during transmission. When connecting to a secure site, the browser verifies the website certificate against trusted certificate authorities. If the certificate is valid and matches the website's identity, the browser establishes a secure connection. If the certificate is invalid, the browser typically warns the user about the potential security risk. Always ensure the browser is configured to warn users when visiting sites with invalid or expired certificates. Enable the HTTPS only mode to force secure connections whenever possible and avoid visiting sites with certificate errors. Regularly update the browser's list of trusted certificate authorities and ensure that websites using SSL or TLS encryption are correctly configured to avoid security breaches. A pop-up blocker is a browser feature that prevents unwanted pop-up windows, which are often used for advertisements, from appearing while browsing websites. Pop-up blockers help protect users from potentially malicious pop-ups that may contain phishing attempts, malware, or other harmful content. They also improve the user experience by reducing intrusive advertisements. Pop-up blockers use predefined rules to identify and block pop-ups. Users can configure the browser to allow pop-ups from trusted sites while blocking those from untrusted sources. Ensure that the pop-up blocker is enabled in the browser settings to prevent automatic opening of potentially harmful windows. Configure exceptions for trusted sites that may require pop-ups for legitimate purposes like login forms or payment gateways. While pop-up blockers are effective in preventing most unwanted content, users should remain cautious and avoid interacting with suspicious pop-ups or links, as some may bypass the blocker. Clearing browser data refers to the process of removing information that the browser stores while users interact with websites, such as cookies, cached images, browsing history, and saved passwords. Regularly clearing browsing data helps protect user privacy by preventing unauthorized access to sensitive information like saved passwords, personal browsing history, or stored session data. Browsers provide settings to clear various types of browsing data, including cookies, cache, and browsing history. Users can configure the browser to delete this data either manually or automatically after each browsing session. Enable automatic clearing of browsing data after each session or periodically clear it manually, especially when using shared or public computers. Pay particular attention to clearing cookies and cache to prevent tracking and preserve privacy. Be mindful that clearing browsing data may log you out of websites and remove saved preferences, so consider using a password manager or saving essential data securely for future sessions. Clearing cache involves removing temporary files stored by the browser such as images, scripts, and web pages that are cached to improve load times and browsing speed. Over time, cache data can accumulate and potentially store sensitive information, such as login credentials or session data, which can be accessed by unauthorized users if the device is compromised. Browsers store cached content to speed up page loading, but this cached data can be cleared manually or automatically through browser settings to enhance privacy and prevent data leakage. Regularly clear the browser cache, especially when using shared or public computers, to ensure that sensitive information is not stored and to free up space. Consider configuring the browser to clear cache automatically after each session. While clearing cache can improve security and privacy, it may slightly slow down browsing speeds initially as the browser will need to reload content from websites. Users should balance convenience with security needs. Private browsing mode, also known as incognito mode in some browsers, allows users to browse the web without saving browsing history, cookies, site data, or temporary files on the device. Private browsing helps prevent websites from tracking user activity and prevents the browser from storing personal information, such as login credentials or visited pages, which can help maintain privacy in shared or public environments. In private browsing mode, the browser does not save session data once the window is closed. This means that cookies, history, and cache are automatically deleted when the session ends, ensuring a clean slate for future sessions. Use private browsing for tasks that involve sensitive information, such as online shopping or banking, especially on shared or public computers. However, be aware that private browsing does not protect against all forms of tracking, such as IP tracking or fingerprinting. While private browsing provides privacy from other users on the same device, it does not provide complete anonymity. Users should use additional security tools like VPNs for enhanced online privacy and protection against tracking. Sign-in and browser data synchronization involve logging into a browser with an account to sync bookmarks, passwords, browsing history, and other settings across multiple devices. Synchronization allows users to seamlessly access their saved data, passwords, and browsing history from any device, ensuring a consistent browsing experience across devices. While convenient, synchronization can expose sensitive data if the account is compromised. Unauthorized access to these synchronized data can lead to security risks, especially if strong authentication methods are not in place. Use strong unique passwords for the account associated with browser synchronization and enable multi-factor authentication for added security. Regularly review synced data to ensure no sensitive information is unintentionally shared across devices. For heightened security, consider using password managers or encrypted cloud services for sensitive information, and be cautious when syncing on public or shared devices to avoid data leakage. Ad blockers are browser extensions or settings that prevent ads from displaying on websites, helping to improve browsing speed, user experience, and security. Ad blockers protect users from potentially harmful advertisements, such as malvertising or ads containing malware, and phishing attempts, which are used often to exploit vulnerabilities in browsers and websites. Ad blockers work by blocking requests to known ad servers or filtering out elements of a web page that are identified as advertisements. This prevents malicious ads from loading and reduces the risk of infection. Install reputable ad blocker extensions from trusted sources and ensure they're regularly updated to stay effective against new threats. Consider using ad blockers in combination with other security measures like HTTPS and anti-malware software. While ad blockers improve security, they may break certain website functionalities, such as displaying content or accessing some features. Users can configure the ad blocker to whitelist trusted sites or disable it selectively when needed. A proxy is an intermediary server that sits between a user's device and the internet, forwarding requests for resources from the browser to websites, often used to enhance privacy and security. Using a proxy can mask the user's IP address, making it more difficult for websites and hackers to track or identify the user. It can also help block access to malicious websites and monitor or filter traffic for security purposes. When configured in a browser, the proxy server routes internet traffic through itself, allowing the user to browse anonymously and access region-restricted content by making it appear as though the traffic is coming from a different location. Configure the browser to use a trusted proxy service, ensuring it supports secure encryption protocols like HTTPS. Regularly check proxy settings to confirm they haven't been altered by malware or unauthorized users. While proxies offer enhanced privacy, they can slow down browsing speeds, and some proxies may log user activity, so choosing a reliable no-logs proxy service is important for maintaining security and privacy. Secure DNS, or Domain Name System, refers to using DNS services that encrypts DNS queries to protect users' browsing activities from being intercepted or tampered with, typically through protocols like DNS over HTTPS or DNS over TLS. Secure DNS helps prevent attacks like DNS spoofing and man-in-the-middle attacks by encrypting the communication between the browser and DNS servers, ensuring that users' DNS requests cannot be easily intercepted or altered by malicious actors. When enabled, Secure DNS routes DNS queries over an encrypted connection, ensuring that the addresses of websites a user visits are not exposed in plain text, thus preventing eavesdropping and tampering. Configure the browser or operating system to use a trusted secure DNS provider that supports DOH or DOT. Popular secure DNS providers include Cloudflare and Google DNS, which offer encrypted DNS services to enhance privacy. While secure DNS provides enhanced privacy and security, it's also important to ensure that DNS provider is trustworthy and does not log personal browsing data. Users should also monitor for potential slowdowns, as encrypted DNS may introduce some latency. Enabling and disabling plugins refers to managing browser plugins, which are small software components that extend browser functionality, such as Flash, Java, or PDF readers. Plugins can introduce security vulnerabilities if they're outdated or exploited by attackers, as they may run outside the browser's security sandbox, exposing the system to threats like malware or exploits. Disable unnecessary or unused plugins and only enable trusted ones from reputable sources. Regularly update plugins to ensure they're patched against known vulnerabilities. Modern browsers typically allow users to enable or disable specific plugins through browser settings or preferences, providing control over which plugins can run during browsing sessions. Consider using HTML5 or native browser features instead of older plugins like Flash, which are often insecure and unsupported in newer browsers. Use browser sandboxing features to isolate plugins from the rest of the system for added security. Enabling and disabling extensions refers to managing browser extensions, which are small software add-ons that extend browser functionality, such as ad blockers, password managers, or productivity tools. Extensions can introduce security risks if they're poorly designed, outdated, or sourced from untrusted developers. Malicious extensions may compromise privacy, steal data, or expose the browser to malware. Only enable extensions from trusted sources and regularly review and disable those that are unnecessary. Keep extensions updated to ensure they have the latest security patches and enhancements. Most modern browsers provide a management interface where users can enable, disable, or remove extensions. Configure these settings to ensure only required extensions are active and disable those that are outdated or unused. Be cautious with extensions that request excessive permissions, such as access to all web pages or sensitive data, and consider using a separate profile for less trusted or experimental extensions to limit their impact. Enabling and disabling features involves managing the various built-in functionalities of a browser, such as JavaScript, pop-ups, cookies, and location services to enhance security and privacy. Disabling unnecessary or potentially risky features like JavaScript on untrusted sites or location tracking can reduce the attack surface and prevent exploits such as drive-by downloads or cross-site scripting attacks. Disable features that are not required for normal browsing, such as unnecessary plugins, third-party cookies, and autoplay media to minimize security risks. Only enable features on trusted websites where necessary. Browsers provide settings that allow users to control which features are enabled or disabled. This can be configured for increased privacy and security, such as blocking pop-ups or preventing third-party cookies. While disabling certain features improves security, it may affect the functionality of some websites. It's important to balance security settings with usability and enable features on trusted sites when needed. Now we're on to Section 3, Software Troubleshooting. Blue screen of death troubleshooting. Blue screen of death can be caused by hardware failure, corrupt system files, incompatible software or drivers, or overheating. Specific error codes can provide clues as to what is causing the blue screen of death. You can boot into safe mode to isolate the problem or perform troubleshooting steps. Ensure all device drivers are up to date to prevent conflicts that might cause blue screen of death. You can also use the Windows Memory Diagnostic tool to check for faulty RAM, which is a common cause of the blue screen of death. Degraded performance troubleshooting. High CPU, memory, or disk usage can slow down system performance. Too many running applications and services can also impact performance. Fragmented hard drives can cause slower file access and overall system lag. Incompatible or outdated drivers and software can lead to system instability or slowdowns. Malware infections or unnecessary software can consume system resources and degrade performance. Boot issue troubleshooting. Use Windows' built-in startup repair tool to fix common boot problems. Corrupted system files or boot sectors can prevent Windows from starting. Incorrect BIOS or UEFI configurations or boot order may also cause boot failures. Booting into safe mode can help isolate the problem, especially with conflicting software or drivers. Faulty hard drives, RAM, or power supplies can also be causing boot issues. Frequent shutdown troubleshooting. Excessive heat can cause automatic shutdowns to protect system components. A failing or insufficient power supply unit can lead to random shutdowns. Corruption in system files can cause instability and result in unexpected shutdowns as well. Incompatible or outdated drivers may trigger system crashes or shutdowns. Infections can cause unexpected behavior, including forced shutdowns as well. Services not starting troubleshooting. Some services rely on others to start, and missing dependencies can prevent them from launching. Corrupt files or misconfigurations in system settings can cause services to fail to start. Lack of proper permissions or incorrect user accounts may also block services from starting. Services can be manually or automatically disabled, preventing them from starting. Sometimes security software can interfere with or block certain services from starting as well. Application crashing troubleshooting. Incompatible or outdated software can lead to crashes. Corrupted application files or system files can cause instability and crashes. Insufficient RAM or memory leaks can result in application crashes as well. Faulty or outdated drivers may cause certain applications to crash unexpectedly. Malicious software can interfere with applications, leading to crashes or erratic behavior. Low memory warnings troubleshooting. Running too many applications or processes can lead to low available memory. Poorly coded applications or background processes that do not release memory properly can lead to low memory warnings. Incorrect or insufficient virtual memory or paging file settings can cause low memory issues. Excessive or unnecessary background processes can consume memory, causing warnings. Incompatible drivers or software may cause memory-related problems, leading to warnings as well. USB controller resource warnings troubleshooting. Outdated or incompatible drivers can cause USB controllers to malfunction. Multiple devices competing for the same system resources can trigger USB controller warnings. Incorrect power supply settings can lead to issues with USB controllers, particularly in laptops. A malfunctioning USB device connected to the system can cause resource conflicts. Misconfigured BIOS or UEFI settings may affect how the system allocates resources to USB controllers. System instability troubleshooting. Incomplete or outdated drivers can cause system crashes or instability. Failing hardware components such as RAM or hard drives can lead to system instability as well. Corruption in Windows system files can cause frequent crashes and erratic behavior. Malware infections or excessive unnecessary software can destabilize the system. Low memory or CPU overuse can cause slow performance and crashes also. No operating system found troubleshooting. The system may be trying to boot from the wrong device, such as a network or USB drive. Essential boot files may be missing or corrupted, preventing the operating system from loading. A damaged or disconnected hard drive can result in the no operating system found error also. Misconfigured BIOS or UEFI settings can prevent the operating system from being recognized or booted correctly. Problems with the master boot record or GPT partitioning scheme can prevent the system from finding the OS also. Slow profile load troubleshooting. A corrupted user profile can lead to delays in loading the desktop environment. Too many programs can set to launch at startup, and that can slow down the profile load time as well. Slow or unreliable network connections can delay the loading of networked profiles, especially in domain environments. A large user profile, including excessive files and settings, can increase loading times. Misconfigured or outdated group policies may cause delays when applying settings during profile load. Time drift troubleshooting. An incorrect time zone setting can cause the system clock to drift from the correct time. A failing CMOS battery can cause the system to lose time, especially after rebooting. Issues with the Windows time service can prevent synchronization with network time servers. Misconfigured network settings may interfere with time synchronization over the network. Some software, such as virtualization tools or poorly configured system utilities, can also alter the system clock. Application fails to launch troubleshooting. Application files may become corrupted, preventing the app from opening properly. Lack of available storage space can prevent apps from launching or cause them to crash immediately. An outdated app may be incompatible with the current version of the operating system, causing it to fail. Compatibility issues between the app and the mobile operating system can also lead to launch failures. Insufficient permissions or incorrectly set app permissions can prevent the app from launching also. Application fails to close or crash troubleshooting. High memory usage or memory leaks can cause an app to freeze or crash. Conflicting apps or background processes can interfere with the app's functionality, also causing it to crash. An outdated app or mobile operating system can cause compatibility issues, leading to crashes or the app failing to close properly. Corrupted app files or installation issues may prevent the app from closing or cause it to crash unexpectedly also. Lack of resources such as CPU power or storage space can cause apps to fail to close or crash. Application fails to update troubleshooting. Lack of available storage space can prevent an app from updating. Additionally, slow or unstable internet connections can disrupt the update process. An outdated mobile operating system may be incompatible with the latest app updates. Restricted app permissions, such as access to storage, can prevent updates from completing also. Corrupted app data or a full cache can interfere with the update process. Application fails to install troubleshooting. Lack of available storage space on the device can prevent app installation. Slow or unstable internet connections may interrupt the download and installation process. The app may not be compatible with the current version of the mobile operating system. Incorrect or missing permissions may block the installation process, or installation issues may arise if the app is not being downloaded from a trusted source or official app store. Slow to respond troubleshooting. Excessive memory usage by apps or background processes can cause the device to respond slowly. Low storage space can affect the device's performance, leading to slow response times. Running outdated versions of the operating system or apps can cause lag due to compatibility issues. Additionally, too many apps running in the background can use up system resources, causing delays in responsiveness. Malware infections or excessive unnecessary apps can slow down the device's overall performance as well. Operating system fails to update troubleshooting. Lack of available space can prevent the operating system update from downloading or installing. A weak or unstable internet connection may also interrupt the update process. Low battery levels or power-saving modes can prevent the device from completing the update. Corrupted or incomplete update files may also prevent the operating system from updating properly. Additionally, the device may not be compatible with the latest operating system version, especially if it's too old or not supported. Battery life issues troubleshooting. Power-hungry apps running in the background can significantly drain battery life. High screen brightness settings can consume more power than necessary. Degraded battery health due to age or wear can result in shorter battery life, and features like GPS and background app refreshing can drain the battery quickly. Running outdated versions of the operating system or apps can cause inefficiencies that negatively impact battery performance. Random reboots troubleshooting. Excessive heat can cause the device to automatically reboot to prevent damage. Incompatible or malfunctioning apps can lead to system instability and trigger random reboots. Running outdated versions of the mobile operating system or apps can introduce bugs that cause system crashes, or a faulty degraded battery can cause power fluctuations, leading to unexpected reboots. Malfunctions in internal hardware components, such as the motherboard or memory, can also cause the device to reboot. Connectivity issues troubleshooting. Weak or unstable Wi-Fi or cellular connections can cause connectivity problems. If airplane mode is enabled, it disables all wireless communication, leading to connectivity issues. Incorrect network settings, such as wrong IP addresses or DNS settings, can also prevent proper connectivity. Certain apps or system bugs may interfere with connectivity, causing disruptions in network access. An outdated operating system or network driver can cause connectivity issues by preventing the device from properly accessing networks. Bluetooth connectivity troubleshooting. Issues with pairing the mobile device to Bluetooth accessories can prevent proper connections. Wireless interference from other devices can disrupt Bluetooth signals and cause connection failures. Outdated or corrupted Bluetooth drivers may prevent devices from connecting or functioning properly. Power-saving settings can disable Bluetooth functionality to conserve battery life, leading to connectivity issues. Bluetooth has a limited range, and physical obstructions between devices can affect connectivity. Wi-Fi connectivity troubleshooting. Poor Wi-Fi signal strength can lead to slow or dropped connections. Incorrect Wi-Fi settings, such as wrong passwords or IP configurations, can prevent successful connections as well. Other electronic devices like microwaves or cordless phones can interfere with Wi-Fi signals. Problems with the Wi-Fi router or modem, such as outdated firmware or hardware malfunctions, can disrupt the connection. An outdated operating system or app may cause compatibility issues with the Wi-Fi network. Near-field communication troubleshooting. NFC functionality may be disabled in the device settings, preventing the connection. Not all devices support the same NFC standards, leading to some connection failures. Other wireless technologies such as Bluetooth or Wi-Fi can interfere with NFC signals as well. An outdated mobile operating system or app may cause compatibility issues with NFC functionality. Physical barriers like cases or covers can block NFC signals, preventing successful pairing. Screen does not auto-rotate troubleshooting. The auto-rotate feature may be disabled in the device settings, preventing screen rotation. Some apps do not support auto-rotation, causing the screen to remain in a fixed orientation. A malfunctioning accelerometer or gyroscope may prevent the screen from detecting orientation changes. An outdated operating system or app can also cause issues with screen rotation due to compatibility problems. Physical damage or obstructions around the device's sensors can also interfere with auto-rotation functionality. Apps from unofficial sources may contain malware or malicious code, compromising device security. Unofficial apps may not adhere to privacy standards, risking unauthorized access to personal data. Apps in unofficial stores may not undergo the same vetting process as official App Store apps, increasing the likelihood of security vulnerabilities. Apps from third-party stores often lack automatic updates, leaving them vulnerable to known exploits and bugs. Apps from unverified developers may not follow security best practices, exposing the device to potential attacks. Enabling developer mode may expose the device to security risks by allowing access to system files and settings. Developer mode can allow installation of apps from unknown sources, which may contain malware or vulnerabilities. Developer mode may disable or bypass certain security features, such as app permission checks or encryption. Developer tools such as ADB or Android Debug Bridge can be exploited to access sensitive data or control the device remotely. Enabling developer mode increases the attack surface of the device, making it more susceptible to unauthorized access. Rooting or jailbreaking a device removes built-in security features, exposing it to vulnerabilities. Devices with root access or those that are jailbroken are more susceptible to malware and unauthorized apps that can exploit system vulnerabilities. Rooting or jailbreaking a device often voids the warranty, leaving the user with no support in case of issues. Rooted or jailbroken devices allow the installation of apps from untrusted sources, increasing the risk of malicious software. Root access can grant unauthorized apps or individuals access to sensitive data, compromising user privacy. Malicious apps can spoof legitimate apps to deceive users into downloading and granting permissions. Spoofed applications may attempt to steal sensitive information, such as login credentials, through fake login screens. Application spoofing can hide malware within seemingly legitimate apps, allowing it to run undetected on the device. Malicious apps may request unnecessary or excessive permissions, such as access to contacts or location, to exploit the device. Spoofed apps may collect personal data and transmit it to remote attackers, leading to data breaches or identity theft. Malicious application spoofing involves creating apps that mimic legitimate ones to trick users into installing them. These fake apps often steal sensitive data, install malware, or gain unauthorized access to device functions. Spoofed apps can appear on unofficial app stores or even slip through poorly regulated official platforms. Users can protect themselves by downloading apps only from trusted sources and checking developer credentials. Mobile operating system security features like app permissions and verification help detect and block spoofed applications. High network traffic on mobile devices can indicate background data usage by malicious or poorly designed apps. Unusual spikes in data usage may signal spyware, adware, or unauthorized data exfiltration. Constant high traffic can drain battery life, increase costs, and degrade device performance. Users should monitor data usage through system settings and identify apps with excessive background activity. Limiting app permissions and using mobile security tools can help detect and prevent suspicious traffic behavior. Degraded response time may be caused by malicious apps consuming excessive CPU, memory, or network resources. Malware running in the background can slow down system performance and impact user experience. Frequent lag, freezing, or crashing may indicate compromised applications or system vulnerabilities. Users should regularly review running apps and remove those that are unnecessary or suspicious. Keeping the operating system updated and using trusted security software helps prevent performance issues from security threats. Data usage limit notifications alert users when mobile apps consume excessive network bandwidth. Unexpected data spikes may indicate background activity from malware, trackers, or poorly optimized apps. Monitoring data usage helps identify apps that may be violating privacy or running unauthorized tasks. Users can set data limits and warnings through mobile operating system settings to prevent overages and detect anomalies. Responding to these alerts promptly can protect device performance, data plans, and personal information. Limited internet connectivity can result from misconfigured network settings or malicious app interference. Malware may disrupt connections to prevent security updates or enable unauthorized control. Users might experience issues like app sync failures, slow browsing, or inability to access online content. Resetting network settings and checking app permissions can help restore proper connectivity. Regular updates and trusted security tools help prevent connectivity issues caused by security threats. No internet connectivity can be caused by malware, corrupted network settings, or unauthorized configuration changes. Malicious apps may disable network access to avoid detection or restrict device functionality. Users may be unable to browse, update apps, or sync data when connectivity is lost. Troubleshooting steps include restarting the device, resetting network settings, and removing suspicious apps. Keeping the mobile operating system updated and installing apps only from trusted sources helps prevent connectivity-related security issues. An unusually high number of ads may indicate the presence of adware or a compromised application. Adware generates revenue by displaying excessive or intrusive ads, often without user consent. These ads can slow down device performance, drain battery, and lead to malicious websites. Users should identify and uninstall suspicious apps or use trusted mobile security software to scan for threats. Downloading apps only from official stores and checking user reviews helps avoid adware infections. Fake security warnings are deceptive alerts designed to trick users into installing malicious apps or providing personal data. These warnings often mimic legitimate system notifications to appear trustworthy. Tapping on fake alerts can lead to phishing sites, unwanted subscriptions, or malware downloads. Users should avoid interacting with suspicious pop-ups and instead run scans with trusted security software. Keeping the operating system and apps updated helps defend against vulnerabilities exploited by fake warnings. Unexpected app behavior, such as crashes, freezing, or unauthorized access requests, may indicate malware or corruption. Malicious apps can modify system settings, access sensitive data, or perform actions without user consent. Sudden changes in app behavior should prompt users to investigate permissions and recent installations. Clearing app data, uninstalling suspicious apps, and updating the operating system can help resolve issues. Using trusted security tools and downloading apps from official sources reduces the risk of abnormal behavior. Leaked personal files and data often result from malicious apps accessing storage without proper authorization. Data breaches can expose sensitive information like contacts, photos, messages, and financial details. Poor app permissions management and unsecured connections increase the risk of data leaks. Users should regularly review app permissions and avoid granting access to unnecessary data. Encrypting data and using reputable security apps can help protect against unauthorized data exposure. Incorrect IP settings, DNS configurations, or proxy settings can prevent access to the network. Overly restrictive firewall or antivirus settings can block network access or specific network services. Outdated or corrupt network adapter drivers can cause connection failures or prevent access to the network. Faulty cables, routers, or switches can interrupt the connection and prevent network access. Malware infections or ransomware attacks can alter network configurations, block access, or interfere with network communications. Malware or adware can generate unwanted desktop alerts, often mimicking legitimate security warnings to trick users. High CPU or memory usage can cause system instability, triggering false desktop alerts. Conflicting software or outdated drivers may result in frequent misleading desktop alerts. Fake alerts may be used as part of a phishing attack to steal sensitive information by convincing users to click on malicious links. Incorrect security software settings may trigger unnecessary or false alerts about threats or system issues. Malicious software may generate fake antivirus alerts to deceive users into downloading more malware or paying for fake services. Outdated antivirus software or virus definitions can result in false positives, triggering unnecessary alerts about non-existing threats. Incorrectly configured antivirus settings may cause the software to incorrectly identify harmless files or actions as threats. Conflicts between antivirus programs or other security software may lead to false alerts or errors regarding system protection. Adware or potentially unwanted programs can trigger misleading alerts claiming the presence of a threat that doesn't exist. Malicious software can delete, rename, or encrypt files, making them inaccessible to the user. Files may be unintentionally renamed or moved by users, leading to difficulties in locating them. Corruption of the file system or hard drive can cause files to disappear or be renamed. Infected backups or cloud syncing services may inadvertently overwrite or delete files. Unauthorized changes to file permissions can make files appear missing or inaccessible. Corruption of the file system or storage device can make files inaccessible or unreadable. Malware or ransomware can lock or encrypt files, rendering them inaccessible without a decryption key or ransom payment. Incorrect file or folder permissions may restrict access, preventing users from opening or modifying files. Files may have been accidentally deleted, renamed, or moved, making them hard to locate or access. Physical issues with the hard drive or storage media, such as bad sectors, can also lead to inaccessible files. Unwanted notifications may be generated by adware or malware designed to bombard the user with misleading or intrusive alerts. Incorrect or overly permissive notification settings in the operating system can lead to an influx of unnecessary notifications. Some apps or background services may send constant notifications even when they're not needed. Third-party apps or utilities may include unwanted notifications as part of their functionality, often for advertising purposes. Some security software may over-respond to minor issues or misconfigurations, causing frequent notifications as well. Corruption in the update files can prevent the operating system from successfully applying updates. Lack of free storage on the device may cause updates to fail, as they require space to be installed. Poor or unstable internet connections can interrupt the update process, causing it to fail. Outdated or incompatible drivers and software can conflict with operating system updates, preventing them from being installed. Overly aggressive security software such as antivirus programs may block or interfere with operating system updates as well. Malicious software such as adware can cause frequent pop-up ads or fake alerts to appear on the screen. Pop-ups may originate from the browser, often due to malicious browser extensions or settings that allow intrusive ads. Unofficial or poorly designed software may generate unwanted pop-ups, often for advertising or promotional purposes. If the browser or operating system pop-up blocker is misconfigured or turned off, it may allow excessive pop-ups to appear. Pop-ups may be part of phishing scams designed to trick users into providing personal information or clicking on malicious links. Certificates with expired validity dates can cause security warnings when accessing websites or applications. If a certificate is issued by an untrusted or unknown certificate authority, it may trigger a security warning. If the system's date and time are incorrect, valid certificates may appear expired or invalid. Certificates that are self-signed rather than issued by a trusted certificate authority can cause warning messages due to the lack of third-party validation. In some cases, certificate warnings can indicate a potential man-in-the-middle attack where attackers are intercepting data between the user and the server. Malicious software can cause redirection by altering browser settings or modifying the system's network configurations. Redirection is often used in phishing scams where users are sent to fake websites that steal personal information. Some browser extensions or add-ons can hijack search results and redirect users to unwanted or malicious websites. Incorrect DNS settings can lead to redirection of legitimate web traffic to fraudulent websites. Routers or network devices compromised by attackers may redirect traffic to malicious sites, even for legitimate URLs. Malicious software such as adware can cause browsers to slow down by injecting ads or altering settings. Too many or poorly configured browser extensions can lead to slower performance and increased resource usage. Running outdated browsers or plugins can cause compatibility issues, leading to degraded performance. A full or corrupted browser cache or outdated cookies can cause sluggishness and unexpected behavior in web browsing. Slow or unstable internet connections can contribute to poor browser performance, making pages load slowly or not at all. Section 4 Operational Procedures. Ensuring that user information such as contact details and system configurations is correctly recorded in the ticketing system will facilitate efficient support. Properly associating user issues with their profiles allows for better tracking of recurring problems and resolutions. Protecting sensitive user information, including passwords and personal data, to ensure compliance with security and privacy standards. Maintaining a comprehensive ticket history that includes past issues and resolutions helps support teams resolve future problems faster. Using user information to assign tickets to the appropriate support personnel based on expertise or priority improves response times. Documenting detailed device information, including make, model, and configuration, helps support teams quickly identify potential issues. Maintaining a history of device issues, repairs, and resolutions enables support teams to recognize recurring problems and track device status. Properly recording device information assists with asset tracking, ensuring that hardware lifecycle and warranty data are readily available. Including device-specific details in tickets enables faster troubleshooting by providing context and narrowing down potential causes. Ensuring that device information is securely stored in compliance with organizational security policies prevents unauthorized access. Providing clear and concise descriptions of issues helps support teams understand the problem quickly and accurately. Including detailed, reproducible steps to replicate the issue ensures that the support team can consistently identify and troubleshoot the problem. Documenting the severity and impact of the issue on users or systems helps prioritize tickets and allocate resources effectively. Including relevant error codes or system logs in the issue description can provide crucial technical insights and aid in faster resolution. Using consistent formats for issue descriptions ensures that tickets are easy to read and analyze, reducing ambiguity and improving efficiency. Categorizing issues into specific groups, such as hardware, software, network, or security, helps streamline troubleshooting and resolution. Assigning categories based on issue severity ensures that resources are allocated efficiently, addressing urgent issues first. Categorizing by user impact, such as single user versus multiple users, helps prioritize tickets that affect business operations or many users. Identifying recurring issues through categorization can help develop long-term solutions and improve overall system stability. Using predefined categories ensures consistency in ticket creation and aids in reporting, making it easier to analyze trends and track performance. Assigning severity levels such as critical, high, medium, or low helps prioritize issues based on their impact on operations or security. Critical issues affecting business continuity should be prioritized, while lower severity issues can be addressed later. Properly assessing severity ensures that IT resources are allocated effectively, focusing on the most urgent problems first. Different severity levels often come with predefined response and resolution time goals to ensure timely and efficient support. Accurately describing the severity in the ticket helps ensure clear communication among IT teams and stakeholders, avoiding delays in resolution. Ticketing systems typically include multiple escalation levels, Tier 1, Tier 2, or Tier 3 for example, based on the complexity and urgency of the issue. Defining clear criteria for when and how to escalate tickets ensures issues are addressed by the appropriate level of expertise. Escalation levels help ensure timely responses to critical issues by moving them up the chain to more specialized support when needed. Documenting the escalation history within the ticketing system provides transparency and helps identify patterns of recurring problems. Proper escalation helps allocate the right resources to high-priority issues, improving the efficiency of the support team. Providing an accurate description of the issue ensures that the support team can quickly understand and address the problem. Using clear, straightforward language prevents confusion and ensures that the details of the issue are easily understood by all team members. A concise issue description helps avoid unnecessary information, making it easier for the support team to focus on resolving the core problem. Including steps to reproduce the issue helps the support team replicate the problem, leading to faster troubleshooting and resolution. Ensuring the issue description includes only the most relevant information, such as error codes or system behaviors, aids in quicker identification of the cause. Progress notes should clearly document the steps taken to address the issue, including troubleshooting methods and any fixes applied. Regular updates in progress notes ensure that all team members are aware of the current status of the ticket and any changes in the situation. Use straightforward, clear language to ensure that progress is easily understood by both technical and non-technical team members. Including timestamps and key milestones in the progress notes helps track the timeline of issue resolution and any important actions. If applicable, progress notes should include recommendations for future actions or preventative measures to avoid recurrence. The resolution should be clearly documented, explaining the steps taken to resolve the issue, including any fixes, workarounds, or system changes. When possible, document the root cause of the issue, as understanding the cause helps prevent future occurrences and improves troubleshooting accuracy. Include any test results or validation steps that confirm the issue has been resolved, ensuring the solution works as intended. Document the time taken to resolve the issue and help track service levels and identify opportunities for process improvement. If necessary, outline any follow-up actions such as further monitoring, user education, or system checks to ensure the issue remains resolved. Maintain detailed and up-to-date records of all IT assets, including hardware, software, and licenses, to ensure accurate tracking and management. Track the lifecycle of each asset from procurement to disposal to ensure proper maintenance and timely upgrades or replacements. Perform regular audits of assets to verify their location, condition, and usage, ensuring that inventory lists remain accurate and complete. Use asset tags or labels with unique identifiers to make it easier to track and manage devices, reducing the risk of loss or misplacement. Ensure that inventory lists are securely stored and comply with relevant regulatory requirements to protect sensitive data and ensure legal compliance. A CMDB, or Configuration Management Database, stores detailed information about IT assets, configurations, and relationships, providing a single source of truth for all assets within the organization. The CMDB helps track changes to configurations, enabling IT teams to understand the impact of modifications on systems and services. With detailed asset and configuration data, a CMDB allows support teams to quickly identify issues by understanding the relationships between hardware, software, and network components. CMDBs assist in managing the entire lifecycle of assets, from acquisition to retirement, helping to ensure timely updates and replacements. A well-maintained CMDB supports compliance by providing accurate records for audits and helping to generate reports on asset usage, status, and performance. Asset tags and IDs provide unique identifiers for each asset, making it easier to track, manage, and retrieve information about hardware and software. By labeling assets with tags and IDs, organizations can quickly locate and monitor their assets, reducing the risk of loss or misplacement. Asset tags and IDs help manage the entire asset lifecycle, from acquisition through maintenance to retirement, ensuring accurate records throughout. Having properly tagged assets ensures that an organization can easily conduct audits, providing clear visibility of the assets in use and their current status. Asset tags and IDs enhance security by providing a way to track who is using or responsible for each asset, helping to prevent theft or unauthorized access. Carefully selecting vendors and negotiating contracts ensures the acquisition of high-quality, cost-effective IT assets that meet organizational needs. The procurement process involves acquiring assets, such as hardware and software, in alignment with the organization's requirements and budget. Once assets are acquired, proper documentation and inventory tracking should be established to ensure each asset is logged and assigned correctly. The procurement lifecycle includes monitoring the asset through its useful life, ensuring regular maintenance, updates, and compliance with policies. As assets reach their end of life, secure disposal or recycling processes should be implemented to protect data and comply with environmental regulations. Documenting the warranty periods for hardware and software assets ensures that support and repair services are utilized within their coverage period. Ensuring all software assets are properly licensed and documented helps avoid legal and financial penalties for non-compliance. Keeping track of license renewals and warranty expirations allows for timely renewals, preventing service interruptions or loss of support. Maintaining a centralized record of warranties and licenses allows IT teams to easily access and manage asset-related documentation. Properly managing warranties and licenses helps control costs by ensuring that assets are supported appropriately and that software licenses are up to date. Assigning specific users to assets ensures clear ownership and accountability for each device or software within the organization. Properly documenting assigned users helps enforce access controls, ensuring that only authorized personnel can use or modify assets. Keeping track of which users are assigned to which assets allows for up-to-date inventory management, helping with asset recovery or reassignment. When users are clearly associated with specific assets, it becomes easier to provide targeted support, resolve issues, and manage maintenance schedules. Assigning users to assets helps meet security and compliance requirements by ensuring that the right individuals are responsible for handling and safeguarding assets. Incident reports should provide a clear, detailed account of the issue, including symptoms, potential causes, and actions taken to resolve it. Incident reports should be created promptly after an issue occurs to ensure accuracy and prevent the loss of critical details. Including a thorough root cause analysis in the report helps identify underlying problems, reducing the risk of reoccurrence. Documenting the impact of the incident on users or business operations helps prioritize response efforts and allocate resources effectively. Including follow-up actions, recommendations, and final resolutions in the incident report helps ensure the issue is fully addressed and prevents future incidents. SOP, or Standard Operating Procedures documents, should include detailed step-by-step instructions for the custom installation of software tailored to the organization's environment and requirements. Clearly outline any specific system requirements, including hardware, operating system versions, and dependencies to ensure compatibility during installation. Document any customizable configuration options such as installation paths, settings, and preferences that need to be selected during the setup process. Include procedures for post-installation testing to ensure that the software functions as expected and any custom configurations are correctly applied. Provide guidance on common issues that may arise during installation and outline troubleshooting steps to resolve these problems effectively. The new user onboarding checklist should include steps for creating user accounts, configuring user profiles, and ensuring proper permissions and access control. Document the process for setting up hardware and installing necessary software, ensuring compatibility with company systems and security policies. Ensure that email accounts, messaging systems, and collaboration tools are properly configured and accessible to the new user. Include steps for setting up security features such as multi-factor authentication, antivirus software, and data encryption, ensuring the user's environment is secure from the start. Provide resources for user training and access to internal documentation, helping the new user get familiar with the systems and tools they will be using. The user offboarding checklist should include steps for deactivating user accounts, including email, network, and system logins to prevent unauthorized access. Document the process for collecting and inspecting returned hardware, such as laptops, phones, or access cards, ensuring all assets are accounted for. Ensure that the user data is backed up or transferred to appropriate team members or systems before access is revoked. Include steps to revoke or reassign any software licenses, ensuring compliance and proper license utilization. Verify that security protocols such as resetting passwords and revoking access to sensitive systems are followed to safeguard organizational data. Internal service level agreement documents should clearly define the expected response and resolution times for various types of support requests within the organization. Include specific performance metrics such as ticket resolution time, system uptime, and incident response time to measure and track service quality. Service level agreement documents should outline how different types of incidents and requests are prioritized based on severity, impact, and urgency. Clearly define escalation paths for tickets that are not resolved within the agreed-upon timeframes to ensure timely resolution. Include procedures for monitoring SLA adherence, reporting performance, and making adjustments to improve service delivery. Ensure that third-party vendor documentation such as user manuals, installation guides, and support agreements is accessible and up-to-date for troubleshooting and support. Maintain copies of external contracts and service level agreements to clearly define expectations, timelines, and responsibilities with third-party service providers. Ensure that external compliance or regulatory documents are properly documented and accessible to meet industry standards and legal requirements. Integrate third-party knowledge base articles, frequently asked questions, and troubleshooting guides into internal systems to enhance team efficiency and support accuracy. Periodically review external and third-party documentation to ensure that information is current, relevant, and aligned with internal policies and practices. Maintain a centralized knowledge base where support articles, troubleshooting steps, and solutions to common issues are easily accessible by the IT team. Organize knowledge base documents in a consistent, easy-to-follow format to enhance readability and usability for both new and experienced team members. Ensure knowledge base articles are regularly reviewed and updated to reflect the latest information, solutions, and best practices. Use categories, tags, and search functionality to make it easy to find relevant information based on issue type, product, or service. Encourage feedback from IT staff and users to continuously improve knowledge base articles and keep them aligned with actual user needs. A rollback plan should outline specific step-by-step procedures for reverting to a previous system state in the event of a failed change. Ensure that backups of critical data, configurations, and systems are taken before implementing changes to facilitate recovery if needed. Clearly define the roles and responsibilities of team members involved in executing the rollback plan, ensuring quick and coordinated action. Regularly test the rollback procedures in a controlled environment to ensure they are effective and can be executed successfully when required. Document the rollback plan in detail and ensure it is communicated to all relevant stakeholders to ensure preparedness and minimize downtime during execution. A backup plan should include a strategy for backing up all critical data, configurations, applications, and system states before implementing any changes. Use automated backup systems to ensure that backups are taken regularly and consistently, reducing the risk of human error. Store backups off-site or in the cloud to protect against data loss from physical damage, such as hardware failure or natural disasters. The backup plan should document clear procedures for restoring systems to their previous state in the event of a failure during or after a change. Regularly test and validate backup systems and restoration processes to ensure they work correctly and can be executed quickly when needed. Sandbox testing involves creating a controlled, isolated environment where changes can be tested without affecting live systems or users. Conducting tests in a sandbox reduces the risk of introducing bugs, security vulnerabilities, or system failures into the production environment. Use sandbox testing to evaluate how changes impact system performance and compatibility with existing software or hardware before implementation. Properly document the testing outcomes, including any issues encountered, fixes applied, and overall system behavior to ensure transparency and readiness for production deployment. Regular use of sandbox testing ensures that changes are consistently evaluated and any potential issues are identified early, improving the overall quality and reliability of updates. Assign specific roles and responsibilities to staff members involved in the change management process to ensure accountability and smooth execution. Identify key individuals, such as change approvers or stakeholders who are responsible for reviewing and approving changes before implementation. Differentiate between technical roles such as system administrators or developers and non-technical roles such as project managers or business analysts, ensuring all perspectives are considered. Ensure that responsible staff members communicate effectively with each other to track progress, share updates, and address issues during the change process. Designate individuals to monitor the progress of changes and report on their outcomes, ensuring that post-implementation reviews are conducted. Request forms should clearly document the details of the proposed change, including the scope, objectives, and potential impact on the systems or users. Establish an approval process within the request form to ensure that necessary stakeholders review and approve changes before they're implemented. Include sections for assessing the potential risks and benefits of the proposed change, helping to evaluate its impact on security, performance, and business operations. Use request forms to create a record of all requested changes, which aids in tracking progress, ensuring accountability, and providing an audit trail. Standardize request forms to streamline the process, ensure consistency in data collection, and improve the efficiency of the approval and implementation process. Clearly defining the purpose of change helps ensure that the desired outcomes are understood and achievable by all involved parties. The purpose of change should be aligned with the organization's overall business objectives, ensuring that changes contribute to operational efficiency and growth. Identifying the purpose of the change helps assess potential risks and ensures that any negative impacts are minimized or avoided. A well-defined purpose facilitates clear communication about the change's goals and benefits, fostering transparency and collaboration across teams. Clearly stating the purpose allows for effective measurement of the change's success or failure, providing data for future improvements. Defining the scope of the change outlines the specific areas affected, ensuring that all involved parties understand the extent of the change and its impact. Understanding the scope helps in allocating the appropriate resources such as personnel, time, and equipment to successfully implement the change. Clearly defining the scope allows for a detailed assessment of the potential impacts on systems, users, and business operations, ensuring that no aspect is overlooked. A well-defined scope helps prevent scope creep by setting clear limits on what is included in the change, keeping the project focused and on track. The scope of the change provides a reference point for communicating with stakeholders, ensuring transparency and alignment throughout the change process. Standard changes are pre-approved and involve low risk, often with predefined processes for implementation. These changes are typically routine and have minimal impact on users or business operations, making them easier to manage. Standard changes follow a defined process, allowing for faster implementation and ensuring consistency across similar changes. Proper documentation of standard changes helps maintain records of approved procedures, making it easier to track and manage recurring changes. Common examples include software updates, routine hardware replacements, or password resets, which occur frequently and are well understood. Normal changes typically involve moderate to high risk and require a formal risk assessment before approval. These changes must go through a structured approval process, including assessment by relevant stakeholders or a change advisory board. The impact of normal changes on systems, users, and business operations must be carefully evaluated and documented. Normal changes are planned and scheduled to minimize disruption, often requiring detailed implementation and rollback plans. Examples include software upgrades, configuration changes, or adding new features to existing systems, which may require downtime or system modifications. Emergency changes are unplanned, high-priority changes that need to be implemented immediately to resolve critical issues or security threats. Due to their urgency, emergency changes typically bypass the usual approval process, but they still require minimal documentation and post-change review. These changes carry a higher risk of impact due to their rushed nature, and the potential for disruption is considered during the implementation. After an emergency change is implemented, a thorough review is required to assess its effectiveness and ensure it does not cause further issues. Common examples include addressing security vulnerabilities, system outages, or critical service failures that require rapid intervention. A change freeze is a defined period during which no non-emergency changes are made to systems to avoid disruptions during critical times, such as system upgrades or high-traffic periods. Change freezes are typically implemented during high-risk periods, such as before major project launches, holidays, or financial reporting periods, to ensure system stability. Only emergency changes such as critical security patches or urgent system fixes are permitted during a change freeze. It's important to communicate the change freeze period to all relevant teams and stakeholders, ensuring they're aware of the restrictions. After a change freeze ends, a review should be conducted to evaluate the effectiveness of the freeze and ensure that any necessary changes are properly scheduled. Maintenance windows are predefined time periods during which planned changes, updates, or system maintenance can be safely performed with minimal impact on business operations. These windows help minimize disruption by scheduling changes during off-peak hours or times of low system usage to avoid interfering with users or critical processes. It's essential to notify all stakeholders about the maintenance window in advance to ensure that users are prepared for potential downtime or interruptions. During the maintenance window, IT teams should closely monitor the changes and provide support to quickly resolve any unexpected issues. After the maintenance window ends, a review should be conducted to evaluate the success of the changes and ensure that the systems are functioning as expected. A key part of change management is identifying which systems, applications, or processes will be directly impacted by the proposed change. Assess the potential impact on users, business operations, and system functionality to determine the scope and severity of the change. Understanding the potential impact helps in planning risk mitigation strategies to minimize disruptions during the implementation of the change. Communicating which systems will be affected and how it will impact users ensures transparency and helps stakeholders prepare for potential disruptions. After implementing the change, monitoring the affected systems helps ensure that the expected improvements are achieved and no unforeseen issues arise. Risk level analysis involves identifying potential risks associated with a proposed change, including technical, operational, and security risks. The analysis should evaluate both the potential impact of the change on systems and operations and the likelihood of negative outcomes occurring. Risks should be categorized into different levels, such as low, medium, or high, to help prioritize mitigation efforts and responses. Based on the risk level analysis, appropriate mitigation strategies should be developed to reduce the chances of failure or disruption. Risk level analysis should be an ongoing process with continuous review and monitoring throughout the change implementation to address emerging risks. A change board, change advisory board, or CAB, reviews and approves significant changes to ensure they align with organizational goals and minimize potential risks. The change board typically includes representatives from various departments such as IT, security, and business units to assess the broader impact of proposed changes. The change board evaluates the risk and impact analysis of proposed changes, ensuring that any potential disruptions are thoroughly considered and mitigated. The board ensures that changes comply with internal policies, security standards, and regulatory requirements, reducing the chance of compliance violations. All decisions and discussions during the approval process are documented to provide transparency, track approvals, and maintain accountability. Implementation is the phase where the approved changes are executed according to the documented plan with careful attention to scope, timeline, and resources. Effective coordination among team members and clear communication with stakeholders are essential during implementation to ensure smooth execution and minimize disruptions. During implementation, risks identified earlier in the change management process should be actively managed and mitigated to prevent issues from arising. Ongoing monitoring is necessary during the implementation process to ensure that the change is applied correctly and to address any emerging issues promptly. After the change is implemented, validation steps should be performed to ensure that the change has achieved the desired outcomes and that systems are functioning as expected. Peer review involves having multiple team members review proposed changes and identify potential issues, validate the approach, and provide alternative solutions. By having a diverse set of perspectives, peer review helps uncover risks or oversights that may not have been initially considered, improving the overall change process. Peer review ensures that the change follows best practices, aligns with organizational standards, and meets the necessary quality benchmarks before implementation. Peer reviews often contribute to clearer, more comprehensive documentation, ensuring that all aspects of the change are well documented and easily understood. Peer review fosters a sense of shared responsibility among team members, improving accountability for the success or failure of the change. Engaging end users early in the change process helps ensure their needs and expectations are understood and addressed during the planning and implementing stages. Regular communication about the upcoming change, its benefits, and potential impacts ensures that users are prepared and comfortable with the transition. Providing adequate training and support to end users helps them understand and adapt to the changes, increasing their acceptance and minimizing resistance. Implementing a system for collecting user feedback during and after the change helps identify areas for improvement and ensures any concerns are addressed. A post-change review involving end users allows the organization to assess the success of the change from the user's perspective and make necessary adjustments. A full backup copies all data from the workstation, including system files, applications, and user data, ensuring comprehensive protection. With a full backup, restoring the system is straightforward since it contains everything needed to return the workstation to its exact state at the time of the backup. Full backups require more storage space compared to incremental or differential backups, as all data is copied every time the backup is performed. While full backups are typically scheduled less frequently due to their size, they should be done regularly to ensure that all critical data is backed up. Full backups serve as the baseline for other types of backups, such as incremental or differential, helping ensure that only new or changed data is backed up. An incremental backup only saves changes made since the last backup, minimizing storage requirements compared to full backups. Since only new or modified files are backed up, incremental backups are faster to perform than full backups. To fully restore a system, all incremental backups since the last full backup must be applied, which can increase the recovery time. Incremental backups can be done more frequently, for example daily or weekly, due to their smaller size and faster execution. Incremental backups are typically used in conjunction with full backups as they build on the full backup to capture only changes. A differential backup saves all changes made since the last full backup, ensuring that any new or modified files are backed up. While smaller than a full backup, differential backups can grow in size over time as they accumulate all changes since the last full backup. To restore a system, only the last full backup and the most recent differential backup are needed, simplifying the recovery process compared to incremental backups. Differential backups offer a balance between storage efficiency and recovery speed, as they're faster to perform than full backups, but less storage intensive than incremental backups. Differential backups are typically scheduled between full backups, often on a weekly or bi-weekly basis, to provide comprehensive protection without excessive storage use. A synthetic full backup is created by combining the most recent full backup with all subsequent incremental backups, effectively creating a new full backup without performing a full backup process. While it combines full and incremental backups, it does not require a full backup every time, reducing backup time and storage usage compared to performing a full backup regularly. Synthetic full backups simplify the recovery process by providing a complete backup that can be restored without needing to apply multiple incremental backups. Because the backup is synthesized after the fact, there's minimal impact on the system and network during the process, making it a more efficient option for organizations with limited resources. Synthetic full backups allow for flexibility in backup scheduling as they can be created periodically, reducing the need for frequent full backups while maintaining a high level of data protection. In-place or overwrite recovery restores data directly to its original location, replacing the current files with those from the backup. This method is often the fastest and simplest recovery option as it doesn't require transferring files to a new location or reorganizing data. Since it overwrites existing data, there is a risk of losing any changes made since the backup was taken, making it less suitable for scenarios where data updates are frequent. Overwrite recovery typically requires less storage space since the restoration process replaces existing data rather than duplicating it. This method is effective in situations where a complete system failure occurs and the objective is to restore the system to its exact previous state without maintaining any interim changes. Alternative location recovery involves restoring data to a different directory or storage device rather than overwriting the original files. Since the recovery doesn't overwrite existing data, it reduces the risk of losing any recent changes or files that might not be included in the backup. This method is particularly useful when recovering from system corruption or failure, as it allows for restoring data without disrupting the current system. It requires additional storage space for the recovery process as the data is restored to a different location rather than replacing the existing files. After recovery, the user can manually transfer data from the recovery location to the original system, allowing for selective restoration of needed files. Establishing a routine schedule for backup testing, such as monthly or quarterly, ensures that backup systems are functioning properly and can be relied upon in case of failure. Regular testing verifies that the data being backed up is accurate and complete, ensuring that files can be restored without corruption or loss. Backup testing should include validating the recovery process itself to ensure that it can be performed efficiently and correctly when needed. By testing backups frequently, IT teams can identify potential issues such as failed backups or corrupted data before they impact operations. Many organizations follow compliance regulations that require regular backup testing, ensuring that data recovery processes meet industry standards and regulatory requirements. On-site backups are stored within the same physical location as the workstation, allowing for quick access and fast recovery times in case of failure. Off-site backups are stored in a remote location, such as a cloud service or secondary facility, providing protection against local disasters like fires or theft. Both on-site and off-site backups should follow a defined rotation schedule, ensuring regular backups are performed and that backup copies are rotated effectively to maintain data security. On-site backups are generally less costly in terms of storage and infrastructure, but off-site backups, especially cloud-based solutions, offer enhanced disaster recovery and business continuity. A combination of on-site and off-site backup schemes, known as a hybrid approach, offers a balance between fast recovery and disaster recovery, providing a comprehensive solution for data protection. The Grandfather Father Son or GFS backup rotation scheme organizes backups into three tiers: Son or daily backups, Father or weekly backups, and Grandfather or monthly or long-term backups. This rotation scheme provides multiple levels of backup redundancy, ensuring that data is protected with both recent and historical copies. GFS minimizes storage requirements by keeping a limited number of backups at each level, with older backups being overwritten as new ones are created. The Grandfather tier holds long monthly or quarterly backups, which are crucial for long-term retention, disaster recovery, and compliance. With multiple backup levels, this scheme allows IT teams to quickly restore from recent backups while also providing access to older data if needed. The 3-2-1 backup rule recommends keeping 3 copies of data, 1 primary copy, and 2 backups to ensure redundancy. Store backups on at least 2 different media types, such as the hard drive and cloud storage, to provide against failure of a single medium. At least 1 backup should be stored off-site, either in the cloud or a remote physical location, to safeguard data against local disasters like fire, theft, or hardware failure. This rule ensures data redundancy and increases the reliability of backup systems by diversifying storage methods and locations. The 3-2-1 rule can be adapted with different backup schemes, full, incremental, and differential, depending on the needs of the organization or individual. ESD straps are used to safely discharge any static electricity buildup from a technician or equipment, preventing damage to sensitive electronic components. Wearing an ESD strap ensures that static electricity does not affect critical components like motherboards, memory, or processors during installation or repair. ESD straps are connected to a ground, allowing static charges to be safely directed away from the user and into the ground, reducing the risk of ESD-related damage. ESD protection, including using straps, is essential for meeting industry safety standards and maintaining equipment integrity. ESD straps are an inexpensive and easy-to-use tool that provides significant protection to both technicians and electronic devices. ESD mats provide a safe surface for handling electronic components, preventing electrostatic discharge that could damage sensitive equipment. ESD mats are designed to be grounded, allowing static charges from both the technician and the components to be safely discharged into the ground, preventing static buildup. Using an ESD mat minimizes the risk of damaging critical components such as CPUs, memory modules, and circuit boards by providing an ESD-safe working environment. ESD mats are an essential part of maintaining compliance with safety standards for electronics handling, ensuring proper static protection in IT and repair environments. ESD mats are a durable, reusable solution for ensuring a safe workplace and are relatively inexpensive compared to the potential costs of ESD-related damage. Proper equipment grounding ensures that any stray electrical current is safely directed into the ground, reducing the risk of electrical shock to technicians. Grounding helps prevent damage to sensitive electronic components by safely discharging any unwanted electrical charges, including static electricity. Equipment grounding is often a requirement for meeting safety regulations and standards such as OSHA and NFPA guidelines to maintain a safe working environment. Proper grounding protects both the equipment and the user by preventing power surges or electrical faults from causing damage to devices or hardware. Grounding helps to eliminate the buildup of stray electrical currents, which can potentially cause overheating and increase the risk of fires. Proper handling and storage of components in anti-static bags or on ESD mats helps protect sensitive electronic parts from electrostatic discharge or ESD that could cause damage. Keeping components organized in labeled containers or drawers ensures easy access and prevents accidental damage from mishandling or dropping. Storing components in climate-controlled environment away from extreme temperatures or humidity preserves their longevity and performance. When handling components like circuit boards or hard drives, care should be taken to avoid physical stress, bending, or exposure to excessive force that could result in damage. Using the appropriate tools such as precision screwdrivers and ESD-safe tweezers prevents damage to delicate components during installation, removal, or repair. Proper cable management keeps cables organized and secured, reducing the risk of tripping over loose or tangled cords in the workplace. Organizing cables and avoiding sharp bends or twists prevents physical damage to cables, extending their lifespan and ensuring reliable performance. Properly routed cables help maintain airflow in computer cases or workstations, preventing overheating and improving system efficiency. Proper cable management prevents cables from being tangled or crossing paths in a way that could cause electromagnetic interference, ensuring optimal performance of network and power cables. Adhering to cable management guidelines ensures compliance with safety regulations, reducing fire risks and improving overall workplace safety. Anti-static bags are designed to protect electronic components from electrostatic discharge or ESD, which can damage sensitive circuitry and hardware. These bags provide a safe method for storing and transporting components, reducing the risk of static buildup during handling or shipping. Made from conductive or static dissipative materials, Anti-static bags neutralize static charges, providing a safe environment for sensitive components. Unlike regular plastic bags, anti-static bags are often marked with clear labeling, ensuring technicians can easily identify them for use with ESD-sensitive parts. Many anti-static bags are reusable, offering a cost-effective way to protect components over multiple uses, especially in repair or maintenance environments. Compliance with government regulations ensures that organizations meet the necessary safety and operational standards set by governing bodies, protecting both employees and customers. Different industries may have specific regulations, for example, HIPAA or OSHA, that govern data protection, equipment safety, and employee welfare. Regular audits and inspections are essential for verifying compliance with relevant laws and ensuring that safety procedures are consistently followed. Compliance reduces legal and financial risks by ensuring that organizations avoid penalties, fines, or legal action due to non-compliance with government regulations. By following government regulations, companies create safer work environments, ensuring employee health and safety, and reducing the likelihood of accidents or injuries. Disconnecting power ensures that there's no live current running through the system, significantly reducing the risk of electrical shock while working on internal components. Turning off the power prevents damage to sensitive components, such as the motherboard or RAM, caused by accidental short circuits or power surges during repairs. Disconnecting power ensures that the system is safely powered down, avoiding potential data corruption or loss during hardware or software changes. Power disconnection minimizes the risk of electrostatic discharge, affecting the system's internal components, especially when handling parts like memory or processors. Adhering to the practice of disconnecting power is often a requirement in safety regulations, ensuring safe work conditions in IT environments. When lifting heavy objects, bend at your knees and use your leg muscles to lift rather than straining your back. Hold the object as close to your body as possible to reduce strain on your back and maintain better balance. When carrying heavy items, avoid twisting your body. Instead, turn with your feet to maintain proper posture and prevent injury. For larger, heavier objects, always enlist the help of others to distribute the weight and prevent strain or injury. Supportive shoes with non-slip soles can help improve stability and prevent falls when lifting heavy items. Familiarize yourself with the different types of fire extinguishers and know which one to use for specific types of fires. Ensure that all exits, fire doors, and escape routes are unobstructed and easily accessible to allow for quick evacuation in case of a fire. Participate in regular fire drills to practice evacuation procedures and ensure all personnel know how to respond in an emergency. Avoid overloading electrical outlets and ensure that power cords and wires are in good condition to prevent electrical fires. Store flammable materials such as cleaning supplies and paper in safe, designated areas away from heat sources. Safety goggles provide protection against flying debris, dust, and other particles that can cause serious eye injuries during maintenance or repair tasks. Wearing goggles safeguards the eyes from harmful chemicals, solvents, or cleaning agents commonly used in IT environments, preventing burns or irritation. In some work environments, goggles protect against harmful exposure to intense light or lasers, which can damage vision. Using safety goggles ensures adherence to workplace safety regulations, such as those outlined by OSHA for preventing eye-related accidents. Safety goggles provide a clear protective shield that allows technicians to focus on their tasks without worrying about environmental hazards. Air filter masks provide protection against inhaling dust, debris, and particles commonly found in IT environments, preventing respiratory issues. In environments where chemicals, solvents, or cleaning agents are used, air filter masks help protect the lungs from harmful fumes or vapors. Using an air filter mask in certain environments ensures compliance with workplace safety standards, such as those set by OSHA to protect workers' health. By filtering out airborne particles, air filter masks help maintain a cleaner environment, allowing workers to focus on tasks without exposure to irritants. Air filter masks are particularly important when working in confined spaces with limited ventilation, where airborne hazards may be concentrated. Proper battery disposal prevents harmful chemicals such as lead, mercury, and cadmium from leaching into the environment and contaminating soil and water sources. Following the guidelines in the Material Safety Data Sheets, or MSDS, ensures compliance with local and international environmental regulations for the safe disposal of batteries. MSDS documentation provides safety instructions for handling and disposing of batteries, helping prevent accidents such as leaks, fires, or explosions due to improper disposal. Proper battery disposal supports recycling efforts, ensuring that valuable materials like lithium, nickel, and cobalt are recovered and reused in new products. Correct disposal minimizes the risk of exposure to toxic substances in batteries, protecting both workers and the public from potential health hazards. Proper disposal of toner cartridges prevents the release of harmful chemicals such as heavy metals and volatile organic compounds, or VOCs, into the environment. The Material Safety Data Sheet, or MSDS, for toner provides detailed instructions on safe handling, storage, and disposal procedures to avoid exposure to hazardous substances. Following MSDS guidelines for toner disposal ensures compliance with environmental regulations, such as those set by the EPA for the safe disposal of electronic waste and chemicals. Many toner cartridges are recyclable, and proper disposal supports the recovery of materials such as plastic and metal, which can be reused in new products. Correct toner disposal reduces the risk of exposure to potentially toxic substances found in printer toner, protecting both workers and the general public. Proper disposal of electronic devices, including computers, printers, and phones, ensures that hazardous materials like lead, mercury, and cadmium do not contaminate the environment. The MSDS documentation for electronic devices provides guidelines for handling, storage, and disposal, detailing the necessary precautions to avoid exposure to harmful substances. Following proper disposal procedures reduces the environmental impact of electronic waste, minimizing pollution and promoting recycling of valuable components like metals and plastics. Proper disposal ensures compliance with local and international environmental regulations, such as those set by the EPA, to prevent legal penalties and environmental damage. Adhering to MSDS guidelines for disposal protects both workers and the public from exposure to hazardous chemicals or physical risks associated with device breakdowns during improper disposal. Proper placement of equipment in well-ventilated areas ensures that devices can operate at optimal temperatures and prevents overheating due to restricted airflow. Regular dust cleanup is essential to prevent the accumulation of particles on equipment, which can cause overheating, hardware damage, and system failures. Compressed air is an effective tool for cleaning dust and debris from hard-to-reach areas, such as vents and fans, helping maintain proper airflow and cooling efficiency. Maintaining an environment with stable temperature and humidity levels prevents condensation, static electricity buildup, and hardware malfunctions. Ensuring that cooling and ventilation systems are properly functioning helps maintain air quality and prevents equipment from overheating, especially in areas with high equipment density. A UPS, or uninterruptible power supply, provides backup power during outages or power losses, allowing for safe shutdown of equipment and preventing data loss or hardware damage. Surge suppressors protect equipment from voltage spikes caused by lightning or power surges, which can damage sensitive components. UPS systems can also regulate and protect against undervoltage events, ensuring that equipment receives consistent, reliable power to avoid malfunction. Both UPS and surge suppressors contribute to minimizing downtime by ensuring that equipment continues to operate during power interruptions and protecting against unexpected surges or drops in power. Properly using UPS and surge suppressors in a controlled environment helps prevent damage to critical systems and reduces the environmental impact of equipment failures or downtime. Chain of custody ensures that physical or digital evidence collected during an incident response remains secure, unaltered, and traceable from the point of discovery to presentation in court or for review. A detailed chain of custody log tracks every individual who handles the evidence, the times of handling, and the method of storage, preventing claims of evidence tampering. By maintaining a strict chain of custody, organizations can ensure compliance with privacy regulations such as GDPR or HIPAA by demonstrating proper handling and protection of personal data during an incident. Chain of custody documentation is often required to meet legal and licensing requirements, ensuring that evidence is admissible in court or can be used to substantiate policy violations or breaches. Proper chain of custody procedures help prevent unauthorized access or data loss, maintaining the privacy of individuals and protecting organizational assets during the response process. During an incident, it's crucial to promptly inform management so they can assess the impact and allocate resources for response and recovery. Certain incidents, especially those involving personal data breaches, may require notifying authorities and affected individuals to comply with privacy laws like GDPR or HIPAA. When the incident involves criminal activity such as hacking or data theft, involving law enforcement is necessary to investigate, prosecute, and prevent further damage. Notifying law enforcement helps ensure proper documentation and collection of evidence, which can be crucial for legal actions or regulatory compliance. Having a clear and structured communication plan for informing management and law enforcement ensures a coordinated, efficient response, minimizing confusion and delays. Creating an exact copy or a forensic image of a drive during an incident response preserves the original data in its untouched state, ensuring that evidence is not altered or tampered with. A duplicate drive is essential for complying with privacy laws and regulations such as GDPR or HIPAA, as it allows for proper handling of personal data during investigations. By preserving a copy of the drive, investigators can analyze the data without compromising the integrity of the original drive, which is critical for any legal proceedings. A copied drive allows for safe recovery and analysis of the data, enabling incident responders to identify the cause and impact of the incident while maintaining the original evidence. Properly documenting the copying process and chain of custody ensures the drive's integrity is maintained and that it can be used as admissible evidence in court or during audits. Incident documentation provides a thorough record of all actions taken during an incident, from detection to resolution, ensuring that the response process is transparent and accountable. Proper documentation of incidents involving personal data helps organizations meet regulatory requirements like GDPR or HIPAA, ensuring privacy protection and legal compliance. Well-maintained documentation ensures that evidence is preserved for investigations, audits, or potential legal actions, protecting the integrity of the incident's response process. Incident documentation helps in identifying the root cause of the incident, allowing organizations to implement corrective actions and improve future security practices. Documented incidents serve as a valuable reference for future incidents, helping to streamline response procedures and support continuous improvement of security policies and practices. The order of volatility refers to the principle of collecting data based on how easily it can be lost or altered, with more volatile data being collected first. Examples of volatile data include system memory or RAM, active network connections, running processes, and CPU cache, all of which can change or be lost when a system is powered down. Adhering to the order of volatility ensures that the most transient and easily lost data is collected before any system shutdown or alterations, preserving critical evidence. Properly following the order of volatility is essential for ensuring that evidence is collected in a legally sound manner, which can be crucial for compliance with privacy laws like GDPR or HIPAA. Documenting the collection process according to the order of volatility helps maintain the integrity of the evidence, ensuring it can be used in investigations or legal proceedings. DRM technologies, or digital rights management technologies, ensure that software and digital content are used only according to the terms of the license agreement, preventing unauthorized distribution or usage. A valid license is granted when users agree to the terms of a EULA or End User License Agreement, which outlines how software can be used, restrictions, and any rights to updates or modifications. Valid licenses ensure compliance with legal and industry standards, such as copyright law, both protecting the creator and the end user from legal liabilities. A valid license ensures that software adheres to privacy policies and regulations, safeguarding personal data and preventing misuse. Without a valid license, users may be prohibited from accessing software features, receiving updates, or using the software legally, potentially leading to service interruptions or legal consequences. A perpetual license agreement grants the user the right to use the software indefinitely without the need for renewal or subscription, as long as the terms of the license are met. While perpetual licenses provide lifetime access, they're typically subject to the original end-user license agreement, which may impose restrictions on usage, updates, or modifications. Digital rights management, or DRM, is often used with perpetual licenses to enforce the terms of the agreement and prevent unauthorized use or distribution of the software. With perpetual licenses, updates and support may be limited or provided for a specific period, requiring users to purchase extended support or upgrades after a certain period. A perpetual license ensures that the user complies with licensing laws, protecting both the software developer's intellectual property and the user from legal risks related to unauthorized use. A personal use license permits an individual to use the software for personal, non-commercial purposes, often with restrictions on sharing or distributing the software. A corporate use license allows organizations to install and use the software across multiple devices within the company, typically with more extensive rights for distribution and modification. The End User License Agreement, or EULA, clearly outlines the rights and restrictions for both personal and corporate use, including the scope of installation, number of users, and how the software can be used. DRM tools are often applied to enforce the restrictions in both personal and corporate licenses, preventing unauthorized distribution or use beyond the allowed scope. Understanding the differences between personal and corporate licenses is essential for ensuring compliance with privacy laws, corporate policies, and licensing regulations. Open source licenses allow users to freely use, modify, and distribute the software, often with fewer restrictions compared to proprietary licenses. Common open source licenses such as the GNU General Public License or GPL or MIT license have different terms regarding modification, redistribution, and commercial use. Open source software typically allows users to modify the source code and create derivative works, but some licenses may require these changes to be shared under these same open source terms. Open source software often comes with no warranty, and users typically have limited or no access to official support, making community forums and documentation crucial. Although open source licenses offer freedom, users must still comply with specific licensing requirements, such as providing attribution or sharing source code when redistributing software. An NDA is a legally binding contract that ensures confidentiality between parties, preventing the sharing of sensitive or proprietary information with third parties. An MNDA, or a mutual non-disclosure agreement, is a two-way agreement in which both parties agree not to disclose each other's confidential information, often used in business partnerships or collaborations. Both NDAs and MNDAs are used to protect intellectual property, trade secrets, and other confidential information that could harm an organization if leaked. Violating an NDA or MNDA can lead to legal action, including financial penalties or termination of the business relationship, depending on the terms outlined in the agreement. NDAs and MNDAs are critical for ensuring that sensitive information related to licensing, software development, or business processes remains protected in accordance with privacy regulations and company policies. Credit card payment information is classified as sensitive data and must be protected in accordance with data privacy regulations such as the Payment Card Industry Data Security Standard, or PCI DSS. Organizations are required to encrypt credit card data, both in transit and at rest, to prevent unauthorized access, ensuring that payment information is stored securely. Only authorized personnel should have access to credit card payment information, and access must be monitored to detect any potential breaches or misuse. Regulations like PCI DSS and GDPR require organizations to implement strict controls around the collection, processing, and storage of credit card payment information to protect consumer privacy. Payment information should only be retained for as long as necessary for business purposes and must be securely disposed of when no longer needed to prevent unauthorized access. Personal government-issued information such as social security numbers, driver's license numbers, and passport details is considered highly sensitive and is subject to strict privacy regulations. Organizations handling government-issued personal information must comply with laws like the GDPR, HIPAA, or the Privacy Act, which mandate secure handling, storage, and sharing of this data. Protecting personal government-issued information requires encryption during transmission and at rest, along with strict access control to ensure that only authorized personnel can access it. Government-issued personal information should only be retained for the minimum necessary period, and secure disposal procedures must be followed when the data is no longer required. Improper handling of government-issued personal information can lead to identity theft or fraud, making it critical to implement robust security measures to protect this data. Personally Identifiable Information, or PII, refers to any data that can be used to identify an individual, such as names, addresses, phone numbers, email addresses, and government-issued identification numbers. Organizations must comply with privacy regulations like GDPR, HIPAA, and CCPA when handling PII, ensuring it's protected through secure storage, encryption, and controlled access. Under privacy laws, PII should only be collected for legitimate business purposes and retained for no longer than necessary, minimizing the risk of exposure or misuse. To protect PII, encryption must be applied both during transmission and while stored, and access should be restricted to authorized personnel only. Secure disposal of PII is required when it's no longer needed to prevent unauthorized recovery and access to sensitive personal data. Healthcare data, particularly protected health information or PHI, includes any personal data related to an individual's health status, care, or payment for healthcare services, and is strictly regulated. The Health Insurance Portability and Accountability Act, or HIPAA, sets privacy and security standards for healthcare data, requiring healthcare organizations to implement safeguards to protect PHI. Healthcare data must be encrypted during transmission and at rest, with access limited to authorized personnel to ensure privacy and prevent unauthorized disclosures. Healthcare data must be retained for the legally required duration, and secure methods must be used for its disposal once it's no longer needed to prevent unauthorized access. A breach of healthcare data can result in severe legal consequences, financial penalties, and damage to an organization's reputation, highlighting the importance of maintaining compliance with privacy laws. Data retention requirements are defined by laws and regulations such as GDPR, HIPAA, and CCPA, specifying how long personal and sensitive data must be kept and when it should be disposed of. The retention period for different types of data varies depending on the legal or business needs, with some data needing to be kept for a minimum number of years for compliance or audit purposes. Once the retention period expires, organizations are required to securely dispose of data to prevent unauthorized access or misuse, adhering to data minimization principles. Proper documentation of data retention practices and regular audits ensure that the organization is in compliance with these set retention requirements and can provide evidence of compliance if needed. Failure to adhere to data retention policies can result in legal consequences, financial penalties, and damage to the organization's reputation. An acceptable use policy, or AUP, outlines the rules and guidelines for how employees or users are permitted to access and use an organization's network, devices, and data. AUPs help protect organizational data, intellectual property, and other resources by setting boundaries on activities such as downloading unauthorized software, accessing inappropriate content, or sharing sensitive information. An AUP ensures that users adhere to privacy and licensing regulations such as GDPR, HIPAA, or software licensing agreements, preventing legal violations and potential penalties. By defining acceptable behaviors, an AUP fosters a culture of security awareness, ensuring that users understand the importance of safeguarding organizational assets. The policy specifies the consequences for non-compliance, helping organizations enforce appropriate use and protect their systems from misuse or abuse. Splash screens are often used to inform users about privacy policies, licensing terms, and compliance regulations before they can access software or services, ensuring that users provide informed consent. In many jurisdictions, such as the European Union under GDPR or in healthcare under HIPAA, businesses are required to display terms related to data privacy and user rights before the collection or processing of personal data. Splash screens typically display end-user license agreements or terms of service, ensuring that users acknowledge and accept licensing conditions before using the software. By clearly displaying relevant compliance information on splash screens, companies help build transparency and trust with users, ensuring they're aware of their data usage rights and responsibilities. Splash screens help organizations demonstrate they have taken necessary steps to meet regulatory requirements, protecting against legal risks and potential penalties from non-compliance. Formal attire is typically required in traditional or corporate settings, while business casual is more common in creative or tech-oriented industries, providing a balance between professionalism and comfort. The way individuals dress can impact how they're perceived in professional settings, with formal attire generally conveying authority, respect, and attention to detail, while business casual attire offers a more approachable, relaxed image. Different organizations have varying expectations regarding attire. Understanding and adhering to these norms ensures that individuals remain professionalism and avoid being out of place. Business casual attire allows for greater comfort and flexibility, which can positively impact productivity and morale, while formal attire may promote a more serious, structured environment. Regardless of the dress code, both formal and business casual attire should be neat, well-fitted, and appropriate for the context, demonstrating respect for the workplace and colleagues. Using clear, simple language ensures that messages are understood by all audiences, regardless of their background or expertise, enhancing professional communication. While jargon and acronyms may be familiar within specific industries, they can confuse those outside the field. It's important to explain or avoid them to ensure clarity in communication. Professional language reflects respect and consideration for colleagues and clients, helping to foster positive relationships and a productive work environment. Avoiding slang and informal language promotes inclusivity and ensures that communication is appropriate for diverse professional settings, making all individuals feel respected. Using proper language increases the speaker's credibility as it demonstrates attention to detail, thoughtfulness, and the ability to communicate effectively in a professional context. A positive attitude helps build trust and rapport with colleagues, clients, and stakeholders, making communication more effective and relationships stronger. Projecting confidence allows you to handle challenges or difficult situations calmly, demonstrating problem-solving skills and leadership potential. A positive, confident demeanor conveys professionalism and competence, helping to establish respect and credibility in the workplace. Confidence and a positive attitude contribute to a more collaborative and motivated work environment, boosting team morale and productivity. Confidence can also be expressed through body language, eye contact, and posture, reinforcing the message of self-assurance and positivity in interactions. Active listening allows you to fully understand the customer's needs, concerns, and issues, leading to more effective problem-solving and support. Listening attentively and avoiding interruptions shows respect for the customer, fostering trust and improving the overall customer experience. By allowing the customer to finish speaking before responding, you reduce the chances of misunderstanding their issue, ensuring accurate and efficient solutions. Giving the customer space to express themselves without interruption encourages a more open and positive interaction, making them feel heard and valued. Active listening demonstrates professionalism by showing that you're focused and dedicated to addressing the customer's concerns without rushing or dismissing their input. Being culturally sensitive involves recognizing and respecting the diverse backgrounds, values, and communication styles of colleagues, clients, and customers. Culturally sensitive communication helps avoid misunderstandings and promotes more effective interactions as it considers the cultural norms and preferences of all parties involved. Demonstrating cultural sensitivity helps build trust and rapport with individuals from different cultural backgrounds, enhancing collaboration and cooperation. Being aware of cultural differences helps prevent inadvertently using language or behavior that could be seen as offensive or disrespectful, which could damage relationships. Culturally sensitive communication reflects professionalism and empathy, ensuring that all individuals feel valued and understood, regardless of their cultural background. Using appropriate professional titles and designations demonstrates respect for a person's role, qualifications, and expertise, fostering a professional atmosphere. Addressing individuals by their formal titles adds to the credibility of communication, particularly in formal or professional settings, and acknowledges their achievements or position. Properly using titles helps build mutual respect and strengthens professional relationships by showing consideration for the individual's background and accomplishments. Using titles correctly reflects well both on the communicator and the organization, reinforcing professionalism in both internal and external communications. Recognizing when to use formal titles or designations is essential for showing cultural awareness and understanding the context in which communication is taking place. Being on time for appointments or meetings shows respect for the customer's schedule, demonstrating professionalism and reliability. If you're running late, it's crucial to inform the customer promptly, offering an updated arrival time and showing consideration for their time. Consistently being punctual builds trust with your customers as they'll feel valued and confident in your ability to meet commitments and deadlines. Being late without communication can lead to frustration, damage your professional reputation, and create negative perceptions about your reliability. When you're on time or communicate delays effectively, it enhances the overall customer experience, fostering positive relationships and satisfaction. Avoiding personal distractions such as calls, texting, and social media ensures that your attention remains on the customer and the task at hand, demonstrating professionalism. By minimizing distractions, you show respect for the customer's time, ensuring that interactions are efficient and effective without unnecessary interruptions. Staying focused on the task reduces the risk of errors, improves problem solving, and leads to quicker resolutions, benefiting both the customer and the organization. Avoiding distractions helps project a professional image, showing that you take your responsibilities seriously and prioritize customer needs. By limiting personal interruptions, you contribute to a more productive and respectful work environment, fostering positive relationships with both customers and colleagues. In difficult situations, it's important to stay calm and composed, avoid getting defensive or argumentative, which helps de-escalate the situation and maintain professionalism. Demonstrating empathy and actively listening to the customer's concerns shows that you respect their perspective and are committed to resolving the issue. Never dismiss or belittle a customer's issue, as this can lead to frustration and a breakdown in the relationship. Acknowledge their concern and work towards a solution. Approach each situation with an open mind and avoid making judgments based on the customer's tone or behavior. Focus on finding a constructive solution. Redirect the conversation towards resolving the problem instead of focusing on assigning blame, ensuring that the customer feels heard and supported throughout the process. To ensure accurate understanding, clarify vague or ambiguous statements by asking the customer to elaborate or restate their concern, reducing miscommunication. Asking open-ended questions encourages customers to provide more detailed information, helping to narrow the scope of the issue and identify the root cause more efficiently. Rephrase or summarize the customer's issue to verify your understanding, ensuring both parties are on the same page and preventing further confusion. When discussing experiences or past encounters, use discretion and maintain professionalism, especially in sensitive or challenging situations, to uphold trust and confidentiality. Stay composed and avoid letting emotions influence the interaction, demonstrating patience and professionalism even when faced with difficult situations. Clearly communicate the expected timeline for resolving the issue or completing the service, setting realistic deadlines to avoid overpromising and under-delivering. Keep the customer informed about the status of the issue or project, especially if there's delays or changes to the original timeline, to maintain transparency and trust. Ensure that the customer understands potential challenges that may affect the timeline and provide options or alternative solutions if necessary to align expectations. If any obstacles arise that could delay the process, address them promptly with the customer, offering solutions or revised timelines to manage their expectations effectively. After meeting the agreed-upon timeline, follow up with the customer to confirm their satisfaction and ensure that all issues have been resolved to their expectations. When faced with hardware or software issues, offer clear repair or replacement options based on the customer's needs, budget, and the severity of the problem. Clearly explain the available solutions, including potential costs, timeframes, and any warranty information so the customer can make an informed decision. Ensure that all repair or replacement options, as well as any actions taken, are properly documented for both internal records and customer reference, maintaining transparency and accountability. After completing the service, follow up with the customer to verify that the solution met their expectations and that any lingering issues have been resolved. Offering reliable options, maintaining thorough documentation, and following up demonstrates professionalism, builds trust, and strengthens the customer relationship. Always handle customer data, including confidential and private materials, with the utmost respect and compliance with privacy regulations like GDPR or HIPAA. Ensure that any sensitive information on devices such as desktops, computers, or printers is securely stored with access limited to authorized personnel only. When servicing devices, avoid exposing confidential information either on screen or on physical media by using secure methods to access and protect the data. Maintain confidentiality agreements with customers and adhere to industry standards to safeguard their private materials during service or repair processes. When disposing of or recycling devices, ensure that any confidential customer data is properly erased or destroyed to prevent unauthorized access or data breaches. A bat file, or batch file, is a simple text file containing a series of commands that are executed sequentially by the Windows command prompt, typically used for automating repetitive tasks. Bat files use command line instructions such as echo, dir, and del to perform actions like displaying text, listing directories, or deleting files. Batch files allow users to automate tasks such as system maintenance, backups, or software installation, saving time and reducing manual effort. Bat files can be executed by double-clicking on them or running them from the command prompt, making them easy to trigger for specific tasks. While bat files are useful for automation, they can be prone to errors if improperly written. Additionally, batch files can be a security risk if malicious code is included, so it's important to carefully review scripts before execution. A PS1 file is a script file used by PowerShell, a powerful task automation framework in Windows, to run commands and automate administrative tasks. PS1 files contain PowerShell commandlets and scripts, allowing users to perform a wide range of tasks such as system configuration, file manipulation, and process management. PowerShell scripts offer more advanced features compared to batch files, including error handling, loops, and the ability to work with objects and data in a more flexible way. PS1 files can be executed directly from the PowerShell environment or by double-clicking, but they may be restricted by Windows execution policy, requiring changes to run unsigned scripts. PS1 scripts are widely used in IT administration for automating system administration tasks, managing users, configuring software, and performing complex network operations. A VBS file, or a Visual Basic Script file, is a script file that contains code written in Visual Basic Scripting Edition, commonly used for automating tasks and controlling applications in Windows environments. VBS files use Visual Basic style syntax, including variables, functions, loops, and conditionals to perform tasks such as file manipulation, system configuration, and automation of repetitive actions. VBS scripts are commonly used in system administration for automating IT tasks, such as setting system parameters, creating users, or managing file systems. VBS files can be executed by the Windows script host and are often run via the command line, desktop shortcut, or schedule tasks. Because VBS files can execute powerful commands, they should be handled with caution to avoid executing potentially malicious scripts, especially from untrusted sources. An SH file is a shell script file used in Unix-like operating systems such as Linux and macOS, containing a series of commands that are executed by the shell. SH files use shell scripting syntax, which includes commands, variables, loops, conditionals, and functions to automate tasks such as file management, system configurations, and software installations. SH scripts are primarily used on Linux and macOS systems, but they can be run on Windows through tools like Git Bash or Windows Subsystem for Linux. To execute an SH script, the file must be marked as executable, and it's typically run from the terminal by using the // command. SH scripts are commonly used for automating administrative tasks, backups, software updates, and system monitoring, increasing efficiency and reducing manual work. A .js file is a JavaScript file containing code written in the JavaScript programming language, primarily used for creating interactive features on websites and web applications. JS scripts are used to manipulate HTML and CSS elements, handle user events such as clicks or form submissions, validate data, and perform asynchronous operations like fetching data from servers. JavaScript is commonly used as a client-side scripting language, meaning it runs in the user's browser, allowing for dynamic interactions without needing to reload the web page. JS files can be embedded within HTML documents or linked externally, providing the functionality to interact with the page's content, style, and behavior in real time. JavaScript is often used in an event-driven programming model where actions are triggered by user events such as clicks, mouse movements, or keyboard inputs. A .py file is a Python script that contains Python code, a high-level programming language used for general-purpose programming, automation, data analysis, and web development. Py files use Python's readable and easy-to-understand syntax, which includes indentation for defining code blocks, making it accessible for both beginners and experienced programmers. Python scripts in Py files can run on multiple operating systems, including Windows, macOS, and Linux, making it a versatile choice for developers. Py scripts are widely used for automation tasks, web scraping, file management, data analysis, and even for creating graphical user interfaces or web applications. Py files are executed by the Python interpreter, typically from the command line or an integrated development environment or IDE, making them easy to run and debug. Scripting can automate repetitive tasks such as file management, copying, renaming, and deleting files, or system backups, saving time and reducing human error. Scripts can be used to configure system settings across multiple machines, ensuring consistency and reducing the need for manual intervention in large environments. Scripting can automate the extraction, transformation, and loading of data, or ETL, such as processing logs or updating databases to streamline workflows and improve efficiency. Scripts can automate the installation of software on multiple systems, applying necessary patches and updates, ensuring that systems remain up to date with minimal manual effort. Scripting can be used to monitor system performance, log files or network traffic, and automatically send alerts when certain thresholds are reached, enhancing proactive management. Scripting can automate the process of restarting machines on a schedule, ensuring systems are regularly refreshed without requiring manual intervention. Restarting a machine via a script can be used as part of a troubleshooting routine, allowing administrators to quickly reboot systems after applying updates or addressing minor issues. Scripts can be used to restart multiple machines simultaneously or in a specific order, useful environments when many devices that need periodic reboots for updates or maintenance. Scripting allows remote restarts of machines, making it easier to manage devices in different locations without physically accessing them. Regularly scheduled reboots through scripting can help clear system caches, improve performance, and prevent memory leaks, contributing to overall system health. Scripting can automate the process of mapping network drives, ensuring that users have access to shared resources without needing to manually configure them each time. Scripts can be used to remap network drives across multiple machines, saving time and ensuring consistency in larger environments where users need access to the same network resources. Scripts can be tailored to automatically map different network drives for different users based on their roles or needs, improving efficiency and simplifying system administration. When network drive letters or paths change, scripts can be used to quickly remap drives without requiring manual intervention, ensuring minimal disruption to workflow. Network drive remapping through scripting allows for centralized management, enabling administrators to make updates or changes across multiple systems with a single script, reducing the complexity of manual configurations. Scripts can automate the installation of applications across multiple systems, saving time and reducing manual effort, especially in large environments. Scripting allows for the installation of multiple applications in a single run, ensuring that all required software is set up efficiently without user intervention. Scripting can also configure application settings after installation, ensuring that all applications are properly set up to meet organizational standards. By using scripts, administrators can ensure that software installations are consistent across all machines, reducing the risk of errors and discrepancies. Scripts can be executed remotely to install applications on machines located in different areas, streamlining the installation process without needing physical access to each system. Scripting can automate the process of backing up important data on a scheduled basis, ensuring regular backups without requiring manual intervention. Scripts can be customized to back up specific files, directories, or entire systems, making the backup process flexible to meet different business or personal needs. Scripts can include error handling mechanisms to notify administrators if a backup fails and log the status of each backup for future reference. Scripts can automate the backup of data to network drives or cloud storage, ensuring data is securely stored off-site or on a shared network location. Automating backups through scripting ensures that backups are performed consistently and reliably, minimizing the risk of data loss in case of system failures. Scripting can be used to automatically gather information about system configurations, hardware specifications, or network status, saving time and reducing manual data collection errors. Scripts can process log files to extract specific data such as error messages or usage statistics, enabling efficient monitoring and troubleshooting. Scripts can be used to gather detailed information about installed software, hardware components, and system settings, which is useful for inventory management and audits. Scripting allows for the automated extraction of data from databases, making it easier to collect and analyze large sets of information for reporting or further processing. Scripts can be scheduled to run at specific times, ensuring that data collection is done regularly and with the necessary customization for particular needs. Scripting can be used to automatically initiate software updates on multiple machines, ensuring that systems are always up to date with the latest security patches and feature enhancements. Scripts can automate the process of checking for available updates, downloading and applying them across all systems, reducing the need for manual intervention. Scripts can be scheduled to run at specific times, such as during off-peak hours, to minimize disruptions and ensure that updates don't interfere with business operations. Scripting allows administrators to initiate updates on remote machines, making it easier to manage updates across a large network without needing physical access to each device. Scripting can include error handling to log the status of updates, notifying administrators if updates fail or require attention, ensuring the update process is tracked and monitored. Scripts can unintentionally contain or execute malicious code, such as malware, if sourced from untrusted or compromised locations, putting systems and data at risk. It's crucial to only run scripts from trusted, verified sources to avoid introducing malware. Even seemingly harmless scripts can contain hidden exploits or payloads. Scripts should be executed within a controlled environment, such as sandboxing or using security measures like execution policies to minimize the risk of malware execution. Before executing scripts, especially those downloaded from the internet or third parties, it's important to conduct a thorough review and test them in a safe environment to ensure they don't contain harmful code. Regularly use anti-malware software and monitor scripts for suspicious activity to catch any malware before it can cause harm, and implement security tools to scan scripts automatically. Scripts can unintentionally alter critical system settings, such as network configurations, user permissions, or system policies, leading to system instability or security vulnerabilities. Before running scripts on live systems, it's important to test them in a controlled or sandbox environment to ensure they don't modify critical settings or cause unintended side effects. Always create backups before executing scripts, particularly those that alter system configurations, to ensure that the system can be restored to its previous state if necessary. Implement logging within scripts to track changes made during execution, allowing for easier identification and reversal of any unintended changes to system settings. When writing or executing scripts, ensure that the commands are clear and targeted only at the desired system settings to prevent accidental changes to other configurations. Scripts that do not properly manage system resources, such as memory, CPU, or disk space, can cause system instability or crashes, especially in resource-intensive operations. Inefficient handling of memory in scripts, such as failing to release resources after use or creating memory leaks, can lead to browser or system crashes over time. Implementing error handling mechanisms within scripts ensures that the script can handle unexpected situations, such as resource overloads, without crashing the system or browser. Scripts should be designed to monitor and limit resource consumption, such as by controlling how much memory or CPU power a script uses during execution to prevent crashes. Before deploying scripts, it's essential to test them thoroughly in a controlled environment and optimize their performance to ensure that they don't adversely affect system stability. Remote Desktop Protocol, or RDP, is a proprietary protocol developed by Microsoft that enables users to remotely access and control a computer over a network connection as if they were physically present at the machine. RDP is commonly used for remote troubleshooting, managing servers, and accessing workstations from different locations, providing flexibility for IT professionals and end users. RDP connections should be secured using strong authentication methods and encryption to protect sensitive data from unauthorized access or attacks. RDP typically requires the proper configuration of network settings, such as opening the necessary ports and ensuring the firewall is properly configured to allow safe access. While RDP is widely used, alternative tools like virtual network computing, or VNC, and third-party solutions like TeamViewer or AnyDesk may offer additional features, security, or ease of use, depending on the environment. A virtual private network, or VPN, creates a secure encrypted connection between a user's device and a remote network over the internet, ensuring privacy and data protection. VPNs are commonly used for secure remote access to corporate networks, ensuring that sensitive data remains protected when employees connect to the network from remote locations. VPNs help protect user privacy by masking their IP address and encrypting internet traffic, making it more difficult for hackers, ISPs, or other third parties to monitor or intercept data. Various VPN protocols, for example PPTP, L2TP, OpenVPN, and IPsec, offer different levels of security, performance, and compatibility, allowing businesses to choose the best option based on their needs. VPNs can be used to bypass geographical content restrictions, enabling users to access region-locked websites or services by connecting to servers in different locations. Virtual Network Computing, or VNC, is a remote access protocol that allows users to control a remote computer's desktop environment from another device over a network. VNC is platform independent, allowing users to access and control systems running different operating systems, for example Windows, Linux, or macOS, from any device with VNC software installed. VNC provides real-time interaction with the remote desktop, allowing users to view and control the remote system's graphical user interface, or GUI, as if they were sitting in front of it. VNC is typically less secure than other remote access tools like RDP, so it's important to use encryption and strong authentication to protect remote sessions. VNC is commonly used for IT support, remote system management, and accessing headless systems, but it may be replaced by other remote desktop solutions for enhanced security or additional features. Secure Shell, or SSH, is a cryptographic network protocol used to securely access and manage remote devices, often used for command line interface, or CLI, access to servers and network equipment. SSH encrypts the data transmitted between the client and server, ensuring secure communication by protecting against eavesdropping, man-in-the-middle attacks, and data tampering. SSH supports multiple authentication methods, including password-based authentication and more secure public key authentication, which provides stronger security for remote access. SSH allows for the secure execution of commands on remote systems, making it an essential tool for remote system administration, file transfer, and troubleshooting. SSH is commonly used by system administrators and network engineers to manage servers, perform system configurations, and transfer files securely over unsecured networks like the Internet. Remote Monitoring and Management, or RMM, refers to a set of tools and technologies that allow IT professionals to remotely monitor, manage, and maintain systems, networks, and endpoints. RMM tools provide real-time monitoring of hardware, software, and network health, alerting administrators to potential issues such as system performance degradation, security threats, or hardware failures before they escalate. RMM enables IT support teams to remotely troubleshoot and resolve technical issues, reducing downtime and minimizing the need for on-site visits. RMM platforms allow for automation of routine IT tasks, such as software updates, patch management, and backup verification, streamlining IT operations and ensuring compliance. RMM tools often include security features like patch management, antivirus monitoring, and data encryption to ensure that systems remain secure and compliant with industry regulations. SPICE, or Simple Protocol for Independent Computing Environments, is an open-source remote display protocol designed to provide high-quality access to virtual desktops and remote servers. SPICE allows users to access graphical user interfaces, or GUIs, of remote systems with improved performance and low latency, making it suitable for virtualized environments. SPICE is often used in conjunction with virtualization platforms such as KVM or kernel-based virtual machine to offer a seamless experience for users accessing virtual desktops or servers. SPICE supports advanced features like USB redirection, clipboard sharing, and multi-monitor setups, making it a robust solution for remote desktop access in business environments. SPICE includes built-in security features such as encryption to ensure safe transmission of data between client and server, preventing unauthorized access. Windows Remote Management, or WinRM, is a Microsoft protocol used for remotely managing and administering Windows-based systems, allowing administrators to run commands, scripts, and access system information remotely. WinRM is commonly used with PowerShell, enabling remote command execution, automation, and management of Windows systems through PowerShell remoting. WinRM uses secure communication via HTTP or HTTPS, ensuring encrypted data transmission between the client and server and supporting authentication methods like Kerberos or NTLM. WinRM allows for centralized management of multiple Windows machines, enabling system administrators to configure, troubleshoot, and monitor systems across a network from a single location. WinRM must be enabled and configured on the target machine, including setting appropriate firewall rules and authentication settings to ensure secure and efficient remote management. Screen sharing software allows users to remotely view or control another system's screen, facilitating collaboration, remote troubleshooting, and support. It's widely used for remote technical support, virtual meetings, training sessions, and collaborative work, enabling real-time interaction and assistance. Examples of popular screen sharing tools include TeamViewer, AnyDesk, and Zoom, which provide both screen sharing and remote control capabilities. Screen sharing software typically includes encryption and secure authentication to protect the privacy and integrity of the data shared during the session. Many screen sharing tools are compatible across different operating systems, such as Windows, macOS, Linux, and mobile devices, enabling seamless access and support across diverse environments. Video conferencing software allows individuals or groups to communicate through video and audio over the internet, facilitating remote meetings, collaboration, and communication. It's commonly used for business meetings, virtual team collaboration, remote training, customer support, and educational purposes, allowing people to connect across different locations. Some widely used video conferencing software includes Zoom, Microsoft Teams, Google Meet, and Skype, which offer features such as screen sharing, chat, and file sharing during meetings. Video conferencing tools often include features like encryption, password protection, and waiting rooms to secure meetings and prevent unauthorized access. These tools support a variety of platforms, including desktops, laptops, and mobile devices, ensuring flexibility and accessibility for users across different devices and operating systems. File transfer software enables users to transfer files between computers or devices over a network, ensuring secure and efficient file exchange. Popular protocols for file transfers include FTP or File Transfer Protocol, SFTP or Secure File Transfer Protocol, and SCP or Secure Copy Protocol, each offering varying levels of security and functionality. Well-known file transfer tools include FileZilla, WinSCP, and CyberDuck, which provide graphical interfaces for managing files and connections, making them accessible for both novice and advanced users. Secure file transfer protocols like SFTP and SCP offer encryption to protect data during transmission, ensuring privacy and preventing unauthorized access to sensitive information. File transfer software is commonly used in IT administration for managing backups, software updates, and large file transfers between remote systems, making it essential for network management and support. Desktop management software is used to remotely monitor, manage, and support desktop systems, allowing IT administrators to maintain multiple machines from a centralized location. These tools often include features such as software deployment, system monitoring, patch management, inventory management, and remote troubleshooting, streamlining IT operations. Examples of desktop management software include Microsoft Endpoint Configuration Manager, Manage Engine Desktop Central, and SolarWinds Remote Monitoring and Management, which offer comprehensive management solutions for IT environments. Desktop management software helps enforce security policies, such as ensuring that antivirus software is up to date, applying system patches, and monitoring for compliance with company policies. By automating routine tasks like software installations, updates, and system monitoring, desktop management software increases productivity and reduces manual intervention, leading to a more efficient IT operation. Security considerations for each access method. While RDP provides full remote access to desktops and servers, it must be secured with strong authentication, encryption, and firewalls to prevent unauthorized access, as it is a common target for attacks like brute force or ransomware. VPNs secure remote access by encrypting traffic between users and the network, but the security of the connection depends on using strong encryption protocols like IPsec or SSL and properly configured access controls to mitigate risks such as man-in-the-middle attacks. SSH is widely used for secure remote command line access, offering encryption for data transmission and strong authentication methods. However, it's important to disable weak authentication methods like password-based and use key-based authentication to enhance security. VNC allows remote desktop access but lacks built-in encryption, making it vulnerable to eavesdropping. To secure VNC, it should be used in conjunction with a VPN or tunneled over SSH to encrypt the connection. These tools require secure protocols such as end-to-end encryption to protect the confidentiality of secure communications and data. Strong authentication and access controls are also essential to prevent unauthorized participants from joining sessions. Application integration refers to the process of connecting different software applications to work together seamlessly, allowing data to flow between systems and improving overall functionality. AI can enhance application integration by automating the data synchronization, improving decision-making processes, and enabling predictive analytics to anticipate user needs or system requirements. APIs, or application programming interfaces, are commonly used to integrate AI capabilities into existing applications, allowing systems to interact and leverage AI features such as natural language processing or machine learning models. By integrating AI into applications, companies can create smarter, more adaptive systems that personalize user experiences such as chatbots for customer service or AI-driven recommendations. When integrating AI into applications, it's crucial to consider data privacy and security, especially with AI-driven processes that handle sensitive user information, ensuring compliance with privacy regulations like GDPR. An appropriate use policy outlines the acceptable behaviors and practices for users when interacting with an organization's technology, including AI-powered systems, ensuring they're used responsibly and ethically. The acceptable use policy for AI must include guidelines on the ethical use of AI, such as avoiding bias in decision-making algorithms, ensuring transparency, and respecting user privacy. The AUP should address how AI systems handle personal data, ensuring compliance with privacy regulations like GDPR, and specifying that data should be securely processed and protected from misuse. The AUP helps prevent misuse of AI technologies, such as using AI for malicious purposes, and sets clear boundaries for what is acceptable behavior. To ensure compliance, organizations need to actively monitor AI usage and enforce the AUP with consequences for violations to maintain trust and integrity in AI applications. Plagiarism in AI refers to the unethical use of AI-generated content, such as text, images, or code that is copied from external sources without proper attribution or permission. AI tools that generate content must follow copyright laws, and users must ensure they're not infringing on the intellectual property of others by using AI to reproduce protected works. A plagiarism policy related to AI should include guidelines for properly attributing sources and giving credit to the original creators of content, including when AI is used to assist in content creation. The policy should outline the consequences of using AI to plagiarize, emphasizing the importance of originality in research, assignments, and professional work. By setting clear expectations in a plagiarism policy, organizations can promote ethical practices when using AI, ensuring that AI tools are used responsibly and not to undermine academic or professional integrity. Bias in AI refers to the presence of systematic errors or prejudices in AI algorithms that can lead to unfair or inaccurate outcomes, often based on flawed data or assumptions. Bias in AI can arise from various sources, including biased training data, flawed algorithm design, or human bias introduced during the data collection and model development process. AI bias can negatively impact decision-making processes, particularly in sensitive areas like hiring, lending, healthcare, and law enforcement, leading to discrimination or unequal treatment of certain groups. To limit bias, AI developers can use diverse and representative datasets, regularly audit algorithms for fairness, and apply techniques like bias correction and model transparency. Limiting bias in AI is not only a technical challenge, but also an ethical and legal one, with regulatory frameworks like GDPR and EEOC guidelines focusing on preventing discrimination and ensuring fairness in AI-driven decisions. AI hallucination refers to the generation of false or misleading information by AI models, where the system provides content that seems plausible but is factually incorrect or fabricated. Hallucinations in AI can occur due to biases in training data, insufficient or incomplete datasets, or flaws in the model's ability to interpret or generate accurate information. Hallucinations can undermine the reliability of AI systems, especially in critical applications like healthcare, finance, and customer support, where accuracy is paramount. Mitigating hallucinations involves improving data quality, using more advanced AI models, implementing strict validation processes, and leveraging human oversight to verify AI-generated outputs. Limiting hallucinations is crucial for maintaining trust in AI technologies and ensuring compliance with legal standards, as incorrect or fabricated information can have legal or reputational consequences. Accuracy limitation in AI refers to the inherent challenges that prevent AI models from consistently providing 100% correct results due to issues like incomplete data, model constraints, or environmental variability. AI accuracy is influenced by factors such as biased or unrepresentative training data, the complexity of the algorithms, and the quality of the input data used by the AI system. Low accuracy can result in faulty decision-making, especially in critical applications like healthcare, finance, or autonomous vehicles, where small errors can have significant consequences. To address accuracy limitations, AI developers can enhance data quality, fine-tune models, and use more advanced machine learning techniques like ensemble learning or deep learning. While striving for high accuracy, developers must also consider computational efficiency and response time, as extremely complex models may be slow or require too many resources to be practical. Private data security involves safeguarding sensitive information such as personal details, medical records, or financial information, ensuring it remains confidential and protected from unauthorized access. Public data security refers to protecting data that is openly available to the public, such as government datasets or research publications, ensuring it's used responsibly and does not lead to misuse or misinterpretation. AI plays a crucial role in both private and public data security by detecting anomalies, identifying potential threats, and automating responses to safeguard data from breaches and cyber attacks. Private data is often subject to strict privacy regulations, such as GDPR or HIPAA, requiring AI systems to adhere to legal standards when processing and storing sensitive information. AI models must be carefully designed to handle both private and public data according to security standards, ensuring that private data is securely processed while public data is used for general purposes without exposing vulnerabilities. Private data sources are datasets that contain sensitive, proprietary, or confidential information, often owned by individuals or organizations. These datasets are typically protected by privacy laws and require explicit consent for access and use. Public data sources refer to datasets that are freely available to the public, such as government data, open research databases, or publicly accessible APIs. These datasets can be freely used, shared, and analyzed without restrictions. AI models utilizing private data must ensure that the data is anonymized, encrypted, and handled in compliance with privacy regulations like GDPR or HIPAA to prevent unauthorized access or breaches. AI models using public data are often trained on open-source datasets, which can be useful for a wide range of applications but may lack the accuracy and richness of private data. When using both private and public data, AI developers must ensure transparency in data sourcing, adhere to ethical guidelines, and mitigate bias to ensure that the AI models are fair and accurate. Private data includes sensitive information such as personal identifiers, medical records, or financial details that require strict privacy protection under laws like GDPR, HIPAA, and CCPA to prevent unauthorized access or misuse. Public data, while more accessible and often free to use, still requires responsible handling to prevent misinterpretation or misuse, particularly in AI models that may inadvertently expose or manipulate data in ways that compromise privacy. AI systems working with private data must ensure that privacy regulations are met, such as anonymizing data, implementing encryption, and obtaining user consent to prevent privacy breaches and maintain legal compliance. While public data is not typically subject to strict privacy laws, AI systems must still ensure the responsible use of public datasets by preventing bias and ensuring that the data is used ethically and transparently. AI developers must find a balance between leveraging private and public data for training models while adhering to privacy standards and ethical considerations, ensuring that both data types are used appropriately. And that is it for the CompTIA A+ 2201202 course, version 1.0. Be sure to check out the rest of the study materials on the channel, and good luck on your exam and success in the IT industry.